You're not getting it. If you look at look what I wrote down in chat. Look what I wrote in chat.
Yeah, dude.
And,
You're just in denial, man.
Maybe it'll make sense to you.
Well, I mean, the simplest explanation.
You're misunderstanding the equivalent argument.
Ragnar, just listen. Like, just face north, right?
Because he's obviously not going to listen to any of us.
Where did you write that inside chat? I don't see it. Oh, is it are you Vom?
Vom.
Yeah.
Yeah, I'm Vom.
28 after yellow.
Yeah. So when you stare at the Polaris, stars are rotating clockwise. Like where we look up at the sky, we're not staring at Polaris. Especially where we are.
I was talking about the northern hemisphere though, and
exactly.
And the southern hemisphere. Yeah, that's how we.
Why would you look at the sky to know where the ground is?
Yeah, but this, dude. Yeah, I was there too, man. I really struggled with this for a while after watching like Professor Dave's video, trying to explain it. Oh, it's so simple: counterclockwise versus clockwise. That's not how it works. Yes, when you're staring at Polaris, that's how it works. When you're staring at the Southern Cross, that's not it's the opposite. So, hopefully that's making sense to you. If you're standing on literally the top of apparently the assumed globe, and you're looking directly at Polaris, then yes, it'll spin. Ideally, it'll spin counterclockwise. But we're not standing on the top of the North Pole, apparently, on a globe. We're standing in the northern hemisphere, looking in the direction of where Polaris is, in which the stars should be spinning apparently counterclockwise. But if you turn around and look south towards the Southern Cross, which should be spinning clockwise, it'll work. So you're getting a little mixed up. And it's not your fault.
I don't know when you joined the chat, but I've literally said if you're standing on the northern hemisphere at the top and you're looking towards the cross, right? You're looking towards the northern sky, you see the stars rotating in counterclockwise. And when you're standing on the southern hemisphere looking at the stars, you would see them rotating.
I thought we were talking. All right, maybe I'm out of my element.
Ragnar,
I wasn't talking about the places that are close to the equator or places that are.
Oh, gotcha. Right, maybe I might have misunderstood.
Yeah. Do you have the ability right now, Ragnar? Do you have the ability right this second to face north? Can you do that real fast? Just face north.
Well, I could, yeah. Just take out a compass, look at my north, and.
Well, I mean, at this very moment, can you just pretend you're facing north, right?
Mm-hmm.
Or can you actually face north just to make it so there's no confusion? Like face north.
Yeah. Sure.
Okay. You're facing north. What direction? What hand is point? Like if you just stretch.
Is he still talking, or is it my mic? Hello.
No, he cut out. Yeah.
It's probably my trash headphones. My left headphone stopped working a minute ago, so I guess the mic died. Finally, if you're facing north, stick both your hands out.
Yeah.
So they're your fingertips are 180 degrees apart, and you're facing north. Which hand is pointing east, and which hand is pointing west?
If I'm looking north, I would say east would be my right hand, and west would be my left hand.
All right, now turn around and face south. Which hand is pointing east and which hand is pointing west?
Well, that's, again, you're changing the direction of east and west now.
Yeah, so therefore...
No, but if... Okay, so
listen, dude, trace the path of the stars going north, east to west.
No, but again, you're talking about the equator where you see the stars rotating east to west. I'm talking about the spheres on the top where you're looking towards the northern sky. That means that don't look at east and west. Look at the rotation at the direction of the rotation. We're talking clockwise and counterclockwise, not east and west. East and west obviously changes depending on which direction you're looking. Right?
Yeah, but the thing is, if the
clockwise and counterclockwise does not change according to which direction you're looking.
If you're facing north and the stars are rising, in the east and setting in the west, and you turn around and face south and the stars are rising in the east and setting in the west from the same location, facing north, you're going to get counterclockwise movement. Facing south, you're going.
Okay, I'm going to cite this. Yes, I'm going to cite it from an astronomy website. Now you're going to say that they're full of shit too. That's what you're going to have to do. You're completely wrong, dude. It's time to just bite the bullet.
Yeah, dude, come on. I mean, you even had a Glober saying that you're 100% incorrect, and I get it, dude. When you hear new information,
he's got another Glober now. Well, he's got 3 Globers. He has the one who made the Star Trails video. Now he's got the one that just spoke to him, and now the one from this website too.
But Mr. Vom just got in mid-conversation. He didn't hear my whole argument, and when he heard the whole argument, he literally sided with me. So I don't know what you're talking about.
Well, then he's wrong too. You corrupted him back to stupidity if that's the case. Because if you face south, like this source I just posted, this guy understands it. It's completely down to observer orientation. You are wrong, and if Vom is with you now, he's wrong too, unfortunately.
Yeah,
I'm sorry.
I'm not with Ragnar. Sorry.
Then I guess you don't understand how rotations work.
No, it's you who doesn't understand. Read what I just posted. Read what I just posted. Read what I just posted.
You don't need to be a rocket scientist to understand this concept.
Well, apparently you do, because you're not understanding.
Not very complicated.
You're not understanding it, dude.
I was you, bro. I was you, Ragnar, like a few months ago, just drilling these guys.
Did you go, Vom? Did you go flat Earth then? Well,
no, he's just being honest about what we see.
I'm kind of in the middle ground. I think it's a globe still, but
he's a flat Earth. If you're in the middle, you're a flatty, dude. Come on.
Yeah, maybe.
You're there.
So here's what this guy's
I'm not quite there. I'm too nice, but I'm not.
So here's the important part. Yeah, in other words, while the sun, moon, and stars travel from east to west, the direction we see them moving depends entirely on which direction we are facing at the time. Facing north, they appear to rotate counterclockwise. Facing south, they appear to rotate clockwise. That's it.
Yeah, but if you're facing north on the northern hemisphere, then obviously you would see it rotating counterclockwise. If you're standing on the southern hemisphere and looking south, then it would seem to shift. But if you're looking south on the northern hemisphere, it would not change.
Yeah, it does change. That's what I just showed you. Denied, and what this source is also saying.
I don't know where you brought this source from. Just because some retarded guy said something doesn't mean
he's not retarded. You are, dude. Everybody else knows this. You're the only one struggling. This is not controversial in the astronomy community or anything like that. It's just you not getting it.
I'm sure it is.
Yeah, it is. Look, man, I'm gonna read.
And that's why point one of the Earth is flat earthers, and the rest are.
It doesn't even matter who they are. Everybody else is getting this, not you.
Mm-hmm. Yeah, look. Sure. I hate to read off ChatGPT, but even ChatGPT says the exact same thing, right? I wrote, look, if I'm standing in the northern hemisphere, facing north, and then turning around and facing south, would the stars appear to rotate clockwise and then counterclockwise when I turn around? It says yes. The apparent rotation of the stars would seem to change direction depending on your perspective, but this is simply due to the way you're facing relative to the celestial pole, right? And then it goes on to explain it just the same way that Heretic just read out.
And can you repeat that? It said it would appear. Right?
Yes. Because so they're still rotating. No, exactly, right? So it's just depending on your observer position, right? The way that you're standing, because all of the stars, anywhere you are going to be rotating east to west around the North Star.
Again, that's false, but okay, we can disagree.
It isn't false.
We can agree to disagree.
Just look it up, right?
Yeah, I did look it up.
We can't agree to disagree on
this. I'm pretty sure I got this down, but okay.
You don't.
So hold on. Look, let me ask you one more question, right? In the southern hemisphere, do the stars rotate east to west?
No, the stars rotate clockwise in the southern hemisphere. If you're looking towards the north, if you're looking towards the southern cross, then towards the southern point of the sky, then yes, they would be rotating clockwise. Only on the equator would you see them rotating east to west.
Okay, so I just wrote in the southern hemisphere, do the stars rotate east to west? Yes, in the southern hemisphere, the stars appear to rotate from east to west, just as they do in the northern hemisphere.
Depending where you're standing on the southern hemisphere, right?
No,
the equator.
It's east to west, anywhere you are. Anywhere.
Nope. Sorry, that's not true.
So I got another source now. Now I got another one. You're going to have to say that this resource is also full of shit. You're going to just have to go down the line denying everything, right down to your own sentence for this.
I mean, it's kind of hard to
here with your AccuWeather forecast. On the East Coast tonight, it's going to rain blood. And you're going to want an umbrella, maybe a jacket, but because there's going to be a lot of it.
So
I got the Penn State College of Education now.
Wait.
The Penn State College of Education.
I'm just waiting for Art to ask us to laugh because
you're going to have to say that the Penn State College now they're full of flat earthers and retards or whatever you're going to say because now they've just told you the same thing.
They'll grow up eventually and then they'll become Globers. Don't worry. It's just a phase they're going through in college.
Yeah, see that you're actually doing it. No, they're not doing that.
I'll move on to the next topic.
Globers. They say they're putting it down to the rotational axis.
Since you don't believe in gravity,
no, you're not going off. You're not talking about anything else till you get this because we're not going to talk
why does weight seem to reduce around the equator?
Yeah, you're about to get muted now.
Yeah, we don't want to have to mute you, bro.
Why are you muting people? Because
you're not listening. Somebody's trying to talk to you, have a conversation, and you want to skip. Yes, he is. He's asking you a question, and he's actually giving you citations, and you're ignoring. That's what you're doing.
Yeah, we're not going to talk to someone who's not dishonest. If you can't be honest about this,
let's move on. And I'm just gonna mute you. How about that? Are you gonna either have a conversation with Heretic?
Then that's just.
Or are you gonna have a conversation with Heretic, or you're not? What are the other?
I'm literally having a conversation with him right now. I don't know why you're so upset.
You're not having a conversation because he's telling you something, and you're ignoring him and trying to say, "I'm gonna skip over."
I wasn't ignoring him. He was just posting clips and links in the side chat.
Dude, now you're calling me a liar.
Bro, he's giving you a Penn State University citation right now. Just listen to the citation, right? We want to have an intellectually honest conversation, and now you're denying, right, university citations that are stacked up. So you need to concede that you were wrong before we can move on to the next point.
I can bring you citations as well, and I can show you clips as well. It's not going to get us anywhere.
So let Heretic read his out. Hold on a second. Let Heretic read his citation out, right? And then you have to get a citation, right? And you have to bring your evidence because we've shown you enough evidence.
ChatGPT is a citation and evidence as well? Since you seem to use it before.
No, dude. Look, I told you I hate using ChatGPT, but even that, right, told you. Even that told you were wrong, right? Because
so you weren't going with the ChatGPT. That would be enough. Okay.
So now we've got Penn State. Yeah. All right. Go ahead, Heretic. Read. Yeah.
It says, since like the sun, the stars will, for the most part, appear to rise in the east and set in the west, so the apparent motion of a star will depend on which direction you face. An example follows in a 3-second movie. The top left panel, you see the stars appear to rotate counterclockwise around the north celestial pole, which is what we would see if facing north. If facing north. In the top right panel, you see stars rising in the east, moving along circular clockwise paths, setting in the west, which is what which is the behavior we see facing south. Yeah. That's all it is. Very facing north or south. It's which way you face.
Yeah. Because like I said, if you're facing north,
see the sky flip around, dude. That's not what happens. Nobody will tell you that happens. You will not find a college or a university or anybody tell you that that's what happens.
Again,
except for the guys who watch Professor Dave, maybe.
Well, Professor Dave kind of owned Flat Earth Dave on that debate. If he watched it, I don't know if
it's irrelevant.
Dave's a moron.
I assume him to be. Is Flat Earth Dave like one of your sages, or is he just like a random?
Why are you going off the point that we're discussing?
You're the one who brought up Professor Dave, not me.
It's with relation to this point.
Okay. So this is ChatGPT. Okay, I posted on the side.
Yeah, okay. Clockwise around south celestial pole, counterclockwise around north celestial pole.
Yep, which is my point, basically.
Well, you see the same thing.
Australia for a second.
Yeah.
So
if you turn around and look south, so you're saying if you turn around and look south, I'm facing south from the northern hemisphere, now those stars are not going clockwise around the celestial pole I'm facing?
What I'm saying is if you're looking up towards, let's say for a second we're looking towards Polaris on the northern hemisphere, right? If you're looking towards Polaris, you look at a fixed point, right? No matter in which direction you're looking at, east, west, it doesn't matter. You can rotate in 1,000 directions. They're always going to rotate in the same path around that fixed point.
Okay. Yeah, they're going the same way.
That's false, and that's fine.
But, no, well, I mean, depends what you mean by that. They're going the same way objectively, no matter which way you're facing. That's true.
Yeah, east to west.
I don't think I'm getting my concept clear to you guys, but it's
why are you why are you even trying to give us a concept? Like we've already seen directly what happens.
Yeah,
we don't need to really conceptualize it.
Okay.
Just deal with the raw facts of what we're looking at.
Can you explain why things weigh differently around different positions of the flat Earth? Like
sure,
why
if you're going to be, I don't know, we can talk about that if you're going to be honest about what we just talked about. Because if you're just going to be dishonest about this topic and then change it, and you're just going to do that again.
Wait, agreeing to disagree is not being dishonest. I'm like, there's nothing to disagree with. I can move. You haven't convinced me on this matter yet. That's what I'm saying.
Yeah, okay, the sky doesn't convince you, right?
Dude, well, why should we talk to somebody? It's an objective thing. Sorry.
It is an objective thing, and I already explained my position on it, but you seem to, lackluster.
You're just wrong. So if I'm looking south from the northern hemisphere, those stars I'm looking at are not going to be rotating apparently clockwise around the celestial.
Which direction is south from the northern hemisphere?
Oh my God!
Which direction is south?
I'm looking towards the south celestial pole. That's going to be south.
How can you see the south celestial pole from the northern hemisphere?
I'm not going to see it, but I'm going to see stars that are around it.
But south can be any direction, right?
I'm going to see stars that are circumpolar to it.
How?
And they're not
if you're looking south, you may be looking in any direction. You don't know if you're looking directly at the southern stars that you mentioned.
Well, I just face the opposite way from north. I face Polaris, and I turn around 180. Put the camera 180 and look at the stars there. You're telling me those are going to be going not clockwise?
But if it's not a globe, then you're not necessarily looking at that cluster of stars you just described, because 180 from north can be any direction, right?
Oh my God, dude.
I mean, that's your claim, not mine. I don't know why this is...
not my claim. I said looking towards the south celestial pole.
How can you look at the south celestial pole from the north pole?
I said looking towards it.
How do you know which way is towards it? How do you know which way is towards it?
Your body. Listen, dumbass. You turn around and you face towards that direction.
How do you know which direction that is? If you said south, could be anywhere.
God. You know where north is at, right?
Yeah, we know where north is. We have a compass.
180 degrees then.
Okay, 180 degrees from north can be in any direction, right? You can be 180 degrees.
Oh, then you're just a moron.
Okay, if you're 180 degrees from north, it could be any direction. If you're on a globe, right? If you're even on a disc. If you're on a disc, right? Imagine there's a pin.
I'm not on a disc.
Take a circle. Take a disc.
No, we're not on a disc. Now you're straw manning. So we're looking towards the north.
You're on a square. You're on a pizza or whatever.
No, we're looking directly facing Polaris. We're gonna go 180 from that. There you go.
Where are you facing Polaris? Okay, where are you facing Polaris then? In which direction?
In the so-called northern hemisphere. I am looking.
Let me draw this. Let me draw this for you. Let me open Paint.
You don't even know what you're going to be drawing. I already heard you. Disc. I'm not saying disc. I'm not talking about.
It's not a disc. I'll draw. Okay, this is the.
I'm not talking about an AE map either. I'm not talking about all the stars going around Polaris either. I'm talking about the two celestial poles.
1 second.
Hey, Heretic. Is this the guy who used Professor Dave as his example just now?
I never used Professor Dave. You brought up Professor Dave.
That's where they got it from, I think.
So Professor Dave thinks flat Earth is a disc.
I don't know. I didn't bring up Professor Dave. You guys did.
We can no longer use anything he says. How's that?
I didn't bring up Professor Dave, so I don't know what you're on about.
Don't use anything he said. It's not a disc.
I didn't bring up Professor Dave. I'm going to say it again. I didn't bring up Professor Dave.
Go ahead, keep talking.
I did not bring up Professor Dave, so I don't know what you're talking about. This is my picture that I did on Paint. Okay,
you're so annoying, dude. You just want to talk over.
I'm sorry for being annoying, but
yeah, you just talk over. You know what? Every time they're gonna talk, I'm gonna mute you, and then when you're gonna talk, when you're gonna respond, I'm gonna unmute you. How about that? If you can't handle the conversation, this is the way it's gonna have to go.
Well, I can handle the conversation. I can't handle when random retards get on the chat and try to throw their points out of turn and just try to speak. I'm trying to debate one person at a time.
Not a normal retard.
This is the picture. This is the picture. Can you let me finish? So the circle is this.
Yeah, I'm sorry.
Yeah, just while he's on mute quickly, right? He's denying that the stars rise in the east and set in the west in the southern hemisphere, right? We got Harvard University. I don't know why the hell I have to read this freaking obvious quote out, but the Harvard University, right? In the southern hemisphere, the stars rise in the east and set in the west.
He must be extremely new to this topic. He doesn't sound like he knows anything that he's talking about.
As Elbow TV said, we no longer have to talk about which way the stars go.
Well, stars only go one way. That's east to west.
And this other guy seems to think they go in two directions. You get to the equator and it splits like an Oreo cookie when you split it apart.
Yeah. Yeah, you step foot across the equator, suddenly everything's now going clockwise. I mean, that has to be what he thinks is happening. That doesn't make any sense. That doesn't happen. He's the one saying that, everybody else is spatially challenged is kind of wild.
I don't think the star conversation is going to progress because, I'm not sure who the Glober was, but there was someone else who claimed to be a Glober and tried to correct him, and he still wasn't. And
then he said the guy agreed with him after trying to correct him, and he just denied what we showed him too. It was like, okay, we're going to show you Star Trails video taken from Northern Hemisphere looking south, and he just denied it. He said, oh, well, we don't know what camera they're using or what lens they had, or maybe the image is flipped. That's all he's going to do. Deny, because he's got this idea about what's going on, and he's not going to move from it for some reason. Doesn't really do you any good to just deny what everybody else knows, deny observable reality, or you're trying to make claims about it. You look like a fool, dude.
Well, a few minutes ago, probably about 15 minutes ago, I heard him say something about rotation of storms. And I don't know if he realized it or not, but he's claiming the Coriolis effect. So maybe we could see if he wants, because he's not going to get the Star Trails thing. It's going to take probably 48 hours or so for him to realize he was incorrect, which is, that happens to me. Like, if I'm dead set knowing for a fact I'm right about something, and then I find out I'm objectively wrong, it's human nature to to fight against that for a bit.
Yeah, but we can all have a conversation and listen to the other person's point, not just blah 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 blah. The verbal diarrhea of the mouth without actually saying anything, and then not listen to anybody else's point.
True. I'm just as bad about that as anyone, Elbow. You know that. You've muted me. Well, I don't know if you muted me, but you've shouted at me before to shut that up.
If I want me to unmute him, I can, but
so let me propose, maybe the point we should push in on is how do storms propagate within a closed system versus an open system? Would that be a valuable point to proceed upon?
I was thinking more, he's claiming that Earth is rotating under storms, so therefore they move in different directions. I was figuring maybe kind of nail down, stuff rotating in the sky under a spinning stuff. Shit.
This guy.
Let's talk about the rotating globe.
This guy's still denying that stars rise in the east and set in the west in the southern hemisphere.
No one denied that. I said that's actually correct. But if you're standing on the equator, not if you're standing on the top of the southern hemisphere. But we can move on to the next topic. Wait.
Literally, right? It's on recording, and you literally denied that.
You can't record without my consent. This is on tape right now. I do not consent to my recording. And if you post it, you're going to be charged. You're going to be charged with
I'm just letting you know something right now. This entire conversation was recorded, right, and is still being recorded.
I do not approve it. I do not approve it. You do not have.
Yeah, by coming into this room, you're definitely consenting.
No, you do not have.
Well, then if you don't consent, you could definitely leave.
Now we can continue to the next point.
Hold on.
Why do you need to mute though? It's like 5 people versus 1. You should be able to win this debate easily. If it's 5 people versus 1.
Dude, you win. You win.
Okay, so just say I won. Why would you
on YouTube?
Why would you circle jerk this whole time if you can literally just fucking say that you lost?
Okay, you won. What you want? A cookie?
Okay, thanks. Yeah, I'll
all right, then have your cookie. Have fun. Bye.
Thanks.
You won.
Thanks.
There you go.
Thanks for the cookie. Appreciate it.
Yeah, act like you're gonna win something, man.
That has 2 bots recording, bro. Like it was your choice to come in here.
Before we started the conversation.
They're visible. It's right there. It says YouTube bot 2, YouTube Live.
According to the Discord laws, you have to say you're being recorded right now.
No. The
Discord laws.
Goddamn. Where's the police at?
Dude, I gotta shut you up for a second. I'm in Ohio. It's just a one-way record law here, so I can record you without you knowing.
What's the Discord laws over there?
Go ahead, post it. We'll see what happens.
Oh, it's live right now. What are you talking about, dude?
Dude, you're streaming. You've been streaming.
I'm bringing you in Discord court.
How many viewers? How many viewers?
I'm gonna sue you in Discord court now.
How many viewers are we looking at right now?
33 million.
Look for yourself. Go to the YouTube bots and look.
Where are the YouTube bots? 1 second.
Click on YouTube and look at their tag and follow the link.
I guess not only that. I guess he forgot to read the rules and info. Number 8 says, by joining this server, you consent to be recorded.
Oh my! Oops. 33 million people just see you drop the ball.
7.
Oh my God. Go read the rules and info, man. Go read the rules and info. If you missed, I guess if you don't know how to read, I guess that's why a lot of people. Dude, shut up! I'm talking, dude. Shut up! I'm talking. There's people. If you don't know how to read rules and terms and services, it says on this server rule. Oh my God! Can you shut up, dude? Can you shut up? Can you shut up? I'm trying to talk. I'm trying to give you some information, and you just keep talking like your conversation is over mine when I'm actually speaking. I'm actually telling you something. I'm a mod, dude. Shut up. I'm trying to give you some info.
And I have power.
Okay. Guess what? You're banned, bro. Fuck you.
Right up. Oop. Oh yeah. That was a mess.
Wait, who's a mod here?
I'm a mod.
Ragnar gave up.
Can you guys tell me why the Earth is flat?
Oh, who said that?
I muted him.
Somebody tell me why the Earth is flat.
Water's flat.
That's your
Welcome to
the round, doofus.
Water is flat.
DMOC, tell me why the Earth is flat.
Oh, we're gonna get
water is flat.
Speak.
Pretty easy question to answer.
Speak, DMOC.
Water's flat.
Water's
not
flat.
Can. It's not.
DMOC, speak.
Globe Earth always this crazy in every room you go into, or just flat Earth rooms?
No, they like that in the vegan room too.
Something that crushes reality. Banned what's his name because he was right. You guys banned Ragnar because he's right.
That's why we banned him. That's why we banned him, right?
Yeah, we banned him because he's correct.
Bunch of group think in this bitch.
Echo chamber.
Yeah.
Icon, what is your best globe proof?
My best globe proof?
Yes, like what's your
the Earth's curvature is visible.
From where?
You just
from a plane.
Oh. Sure about that?
Positive. I've seen it with my own eyes.
Sure about that? You seen it with your own eyes. Did you look through 3 layers of bent plexiglass to see that curve? I think you did if you were looking out an airplane window.
When you pressurize an airplane, your windows are going to bow out a little bit. So yeah, they're going to be curved.
Yeah. The question is, was the horizon at your eye level at 35,000 feet?
What?
Was the horizon at your eye level?
Was the horizon at my eye level? No, because I was in a plane.
You had to tip your head down to see the horizon. You just look straight out, right?
Yeah.
Yeah, so but it's the same idea. If you're looking at a sphere in your hand, right? You can see the curvature.
What if, like, physicists from your belief system told you that you didn't see curvature? Would you believe them?
What?
If a physicist from your belief, your cult, told you that you didn't see curvature, would you believe them?
What do you mean? I don't understand the question.
If one of your authorities told you that you didn't see curvature, would you believe them?
If Neil deGrasse
but I
Tyson
do see curvature.
Would you believe him?
But I'm telling you, if they tell you that you were tricked and that's not really curvature, you have to be much higher.
Anybody else? I know myself that I can see curvature.
Well, Tim,
he's seen something curved, but that doesn't mean the horizon was curving.
If I have a ball in my hand, I can feel that it's curved.
Right, but when you look through 3 thin plexiglasses at a curvature that's thousands and thousands of miles long. So if I can see
something in my hand that is curved, and I can feel that it's curved, so I know that it's curved, and then I also, in a plane, I can see the curvature of the Earth, why would it be different?
If you hold a chessboard in your hand that you know is flat, and you look through a bent plexiglass at the chessboard, it'll seem curved as well, right?
You're saying that airplane windows make...
Yes, sir. Absolutely.
Oh my god, that is such a piss poor fucking argument. You guys are...
That's literally why you believe you're on a ball, is because you got bamboozled by some plexiglass?
All right.
Ain't that a bitch?
Okay, so explain time zones to me then.
Oh,
there's 24 of them. The sun goes over each one of them.
There's more than 24 of them. The southern part has like 37 time zones. Northern
there you go. Yeah, that's weird, isn't it?
How do you explain the 37 time zones?
But if the Earth is flat, then why? I don't get it. Why would there be time zones? Why would there be time zones in the first place?
Stop spiraling. There's 37.
That doesn't make sense because if the Earth was flat, there wouldn't be time zones.
Yeah, the sun moves around, and it's sunlight over the top of that.
No, that makes no sense. I mean,
you're thinking time. You're thinking time zones on a ball, which is all misconstrued and all fucked up.
Because time zones on a ball makes a lot more sense than if the Earth was flat. There would be no time zones.
Right, hold on. I got this. How does 37 time zones in the South make sense on a ball?
Why? So there's more time zones in the South?
Yeah.
Yes, than there is in the North.
How does that make sense on a ball, since you said it makes sense on a ball?
Flat Earth has 24 time zones on it. Ball Earth has a fucking ton of them. Like this guy's pointing out right now.
Does it have to do with the duration of... Like, it has to do with the tilt of the Earth, doesn't it?
Man, y'all always like to go to that, but it's inexplainable.
So when the Earth tilts the other way, does it go to like 15 time zones or like 75 time zones? Which does it do then?
Yeah, well, it changes, right?
No.
Time zone-a-thon. Goddamn, bro. Get all the time zones you need.
Explain to me, like, the airplanes when they're flying.
We have to explain things.
We're switching them up, huh?
You guys have to explain things to him because he knows everything.
How many things we need to explain for you to actually believe?
Well, all these things that, I need to explain because they don't make sense in your flat Earth worldview.
No, they don't exist in your flat Earth worldview. That's the problem.
Well, what's his what are airplanes? What are airplanes doing when they fly? Like, he seems like he has a claim.
Well, why is their flight path not straight across the Earth then?
What are you talking about? They're point A to point B flight paths.
But they're not. That's the thing.
They're not. How are they not?
To avoid other aircraft, but they fly from
airport to airport. Because if the Earth was flat, we can see this.
Dude, why do you
look
talk
up
to
flight
people?
paths on a Gleason map, dude. You'll see that they're literally more efficient than any other map there is.
Dude,
flying on a ball.
Why do you talk to people? What does an airplane have to do with the shape of what you're standing on?
I was going to ask him if airplanes account for the rotation of the Earth, and being as the airplane's in a second frame of reference. So, what was he going to say about that?
Probably ask another question about a totally different subject.
And also, why are other planets round?
He did
it. He literally did it as I said the joke.
And ask more questions.
Why is the moon round?
It's not.
It is. We can see that it fucking is. You're retarded.
It's not. How do you know that? How do you know that?
Explain to me why it's not.
Oh, do you
is round and flat mutually exclusive?
Because I can visibly see it with my fucking eyes. It's round.
Who said it's not? Who said it's not round?
You're saying the angular projection of something. How can you possibly tell if it's freaking curving? Like what?
Why would it not be square in the sky? Why would it not be square?
Land
is round.
Just stop here for a second. Who said the moon is not round?
He said square. I could have.
Who said it was land?
At the same time as
the moon is round, but it is not spherical. You've never seen it being spherical. You've seen it being round.
It just stays like it's like straight up like a dime. Like what?
You think it's just a fucking ball of dust?
Moron.
Man,
Your shit's just as
I really
fast as
wonder
cool.
how you guys get to these crazy positions.
How
really
did you
wonder.
get to thinking it's a big ball of dirt up
Because
there?
it only makes sense. It only makes.
It doesn't. It literally doesn't make any sense in no ways, dude.
You guys are fucking stupid.
It doesn't. You can't
You guys
prove
just need
anything
to
that
have
you
a
believe in.
contrarian position. That's all you guys
Literally
do. That's all
can't
you guys
prove anything that you believe in, and we try to.
I just did.
We're
What, dude?
looking.
You haven't proved anything. You
What is your validation of that? Right, land in the sky. To walk upon that claim to say, okay, there's in fact land in the sky. What are you validating?
Monkey IQ.
What is your test? No, we are asking you. What is your evidence?
Oh no.
To say that there's in fact land in the sky. Brother, this is where you.
What a bozo. He just left.
Oh my.
Did he leave?
Yeah.
Yeah, he left. That's why the yellow symbol's next to me quit the server.
You try to just go. Remember, you guys, one at a time. It doesn't take. I mean, everyone gets a turn. All right, you will get a turn to talk. So just wait and take a breath. It will happen. I know a lot of you guys come in here from other channels and you're all worked up because other channels you basically got to fight for every second of mic time. It doesn't happen here.
So you new flat earthers, if you want to take on Euclidean geometry, man, go ahead. He's here.
Huh? What?
Or you go to our channel that our flat earthers take on Euclidean geometry, man. He's a glober.
That's true. That's a true story.
What's up, Euclidean?
Hello. Hello.
Everybody's afraid.
Oh, he's
now.
a Glover.
Yeah.
It's just funny with a name like Euclidean geometry, you would think it would be a flatty because Euclidean geometry is based off of. It's based off of what?
Triangles.
Yeah, it's based off of Euclidean geometry, which doesn't have curved lines.
Right, yeah, something that requires a horizontal plane to exist on. So
yeah, something like a tangent could do as well.
Oh, so you mean just begging the question for how not curvy anything is by invoking the tangent, meaning, yes, in fact, you can't do Euclidean geometry on a globe. Sure. Just chant tangent and you'll sleep a little better.
I do sleep great knowing I live on I'm a locally linear earther, actually.
So Euclidean trigonometry, man, thinks that wherever you're at, it's flat.
It's a local.
No, hold on. Over some small portion of displacement. So like it's a calculus meme, you know, local linearity, some point on a function. If you zoom in close enough, it'll appear to be linear on a function, even if it's curving. That's where I got it from.
Oh yeah, the derivative, yeah.
So like
At
if
least
I take a 45-degree elevation angle to Arcturus or just some random star, right? And that star in my sky is 45 degrees. Does the star have a ground position? Euclidean?
It does, but you don't measure to the GP though.
No, but the GP is still existing, especially when you use a Mariner sextant and you're bringing that star down to the horizon to make sure your sextant is all leveled and stuff using, the horizon that you're looking at from the boat.
Mm-hmm,
when that GP comes down to the ground, well, when the star comes down to the ground, that's the GP of the star. Could be 10 miles
you're measuring
away,
the elevation
could be
angle.
5,000 miles. Right.
Yeah, you're measuring the angle of elevation angle. You're measuring the elevation angle to the star from the tangent line.
So not curved. So you're just measuring Earth flat
not
and just
curved.
Right, exactly. Yeah, so you're literally just measuring the Earth flat, but then apologize for how not curved it is by claiming you have a tangent, which is just begging the question. I got you.
Well, I never claimed that it had anything to do with the curved surface in celestial navigation. But
well, you can't have a curved surface in celestial navigation.
Absolutely can. Bacon has done it. I'm not a big Cellnav guy, but Bacon has
Bacon already. Listen, don't bring up.
Oh, Bacon can mop the floor with you guys. Come on,
bring him in here, dummy, and I'm gonna have him put his eyes on the ground, and his whole ball goes away when he does this demonstration. Okay,
dude, I spank Bacon every time I encounter him.
No, you don't. You're not a child. Spank Bacon.
Where's Bacon been? I haven't seen Bacon in probably like 3 months. Where's he been?
I think he's got a second job. He's been working a lot.
Oh, fair enough. Yeah, Bacon also thinks celestial. He thinks the celestial sphere is the surface of the ground that you're standing on too. So, what does Bacon know?
Yeah, what does Bacon know? I don't know, but he's made quite a few models that accurately predict where you are. The globe.
Incorrect.
Globe.
Incorrect. I've already debunked it here when I did it.
How did you do that?
On Stellarium. Bacon plays on Stellarium, dude.
No, he doesn't. He made his own model.
And I
debunked
his model. Remember when I had him put his eyes to the ground and I had him give me the stars that were below his eyes? But he could see them before when they were whatever above the ground. But as soon as you put them on the ground, no, it's a flat horizon straight out. And he couldn't answer the question. And he actually quit a few times on me.
I highly doubt this has happened, Radwin. You're like F tier flat earther.
There's many people in here right now that know exactly what I'm talking about. Stop
no,
telling
I
me.
wouldn't. I wouldn't believe you, but I might believe somebody else. Okay, let's put it at that.
Well, at the end of the day, Bacon can be your authority on this subject, but yeah, we don't hold him as our authority on this subject, so whatever Bacon says is pretty irrelevant to the conversation here, and he's not here to speak for himself.
Yeah, true.
It's true, unfortunately, yeah. I mean, I'm not a big Cellnav guy, so I just did appeal to Bacon. Yeah, it's my fault.
So what's your expertise in your globe Earth arguments? Like, what do you get at?
I don't do as many demonstrations as you're just. A good one is, at what point does the container have to be in order for us to still have gas pressure? Because we observe a gradient that extends very far up into the atmosphere. So
gases start at the ground. Now what?
All right. So we observe very low pressure at high altitude, right?
Yeah, because gases start at the ground. Now go on.
All right. So at 31 kilometers, it's roughly 1% of what it is at sea level. So
gases start at the ground, and then you're going to have the most there. And then now what?
So the pressure will continue decreasing, correct?
Oh, is it colder or hotter up there?
There's a curve.
So it's not colder and it's not hotter?
There's a curve as in the temperature, guys.
Is it colder or hotter in the sky?
Depends on where you are, because it will get warmer and hotter.
Answer the fucking question, dude.
No, I'm not going to answer your question because it's formatted wrong. You do realize that there's multiple temperature curves. It's not linear.
Hotter
like
in
what?
The sky.
What's it?
It's not linear. It varies a lot.
Temperature curves.
I can.
You just said it was a curve, though.
Chat. But it's multiple, yeah.
So
if I'm in Saudi Arabia,
would the pressure be greater where it's more heat, or would it be less pressure where there's more heat?
It would be higher pressure if there's more heat.
Okay, so at the ground where the temperature's 70 degrees and you go in the sky and it's 30 degrees, where is there going to be more air pressure?
Well, again, you're misunderstanding because it's not linear.
Answer the question.
Radwin, you don't understand. It's not linear.
Don't tell me I don't understand.
You don't understand. Look in the side chat. You don't understand. I get it. You're not very bright. For an engineer, right? Supposedly an engineer, he doesn't understand that it's not linear.
You know, those are ad homs, right? All you're saying is he doesn't understand, and you're calling him stupid. You're not actually addressing anything he's saying.
I keep calling him stupid because he keeps trying to assert that it's this way that it is, but I keep trying to explain that it's not, but he's just talking through me.
I waited for you to finish. Is it warmer at the ground or in the air?
Look in the side chat, or else I'm not answering that question again.
I'm looking at the side chat.
So do you see how it's not linear?
Is it colder at the ground than in the air, or is it warmer at the ground?
Okay, he's not understanding. He's bricked.
All right, let's look at your picture. How many feet? 10,000 feet. Is it colder at 0? Is it colder at 10,000 feet than 0, or is it warmer?
That's kilometers, buddy.
I don't have glasses on. I can just see 10,000.
10,000? There's no 10,000 on this graph, actually. So you really need to put glasses on.
Yeah, you're talking about the one above it? That one definitely has 10,000, 20,000, 30,000, blah, 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 blah.
Yeah, I'm looking at the blue one.
Okay, the blue one. Okay, that's my bad. Yeah, okay. At 10,000, it is colder. Yeah, but as you
make me look like an idiot, dude.
Well, you are an idiot, but you do that yourself. But don't worry about it. Okay, so at 10,000, it's colder. And then when I go up to 50,000 meters,
that's it.
It's done. Almost as hot as it is at sea level.
We are done.
But then when I go up to 50,000 meters, it's almost
higher you go.
No, Radwin, then it gets hotter again. Why does it get hotter again, but the pressure keeps decreasing? I thought that's in violation of what you said. But it gets warmer again.
Who measured that?
Who measured that? So you're begging the question of who measured it?
No, I just want to know who measured it so I can look it up.
Who measured it? That's a new one.
Sounding rockets, balloons. Do you want me to get the measurement for the data for that?
At 50,000 meters, what's the average temperature?
According to this graph, it'll be about 260 Kelvin.
Which is what in Fahrenheit?
I'll have to do the conversion for that.
260 Kelvin?
Yeah.
So 8.3 degrees.
At
50,000 meters.
Yep.
For what location?
You mean what location?
Where's the vertical coming from? If you have 50,000 meters, where's that started off at? Where is it? Is it in Alaska? Is it in Saudi Arabia? Afghanistan? Is it in
Pacific Ocean?
Timbuktu?
Atlantic Ocean? Where's it at?
This is just like the average temperature distribution across, like the norm, like normalized across the average places. I don't think that this is
horizontal.
Oh, geez, D-Mox.
What is the average temp at 50,000 meters in Fahrenheit? Let's see what Google says. Negative 69.7 degrees Fahrenheit, according to the standard atmosphere model.
Negative what? What was it? Negative what?
69.7 degrees Fahrenheit.
Wow, that's pretty damn cold. So the pressure's going to be lower up there if you don't understand that.
Yeah, but it gets hotter. But again, there's a temperature.
It gets hotter where? At what altitude does it? So it gets hotter than negative 69 degrees, or it gets hotter than the surface that all this is taken from in the first place?
Was that AI overview? Come on, don't trust AI overview, dude.
Put that in the chat.
Overview?
Well, it was an AI overview, but usually you can get the where it's from, the engineering toolbox, Universal Weather and Aviation, 1976 Standard Atmosphere Calculator. Those are the citations that just pulled from to give me that AI answer.
Yeah,
so he's using an AI that actually gives citations. There's a difference for you Globers that just go out and use an AI versus people who have AIs that do citations like I own. I have an AI, and when I ask it questions, it automatically, because I preloaded it in the back end to always give me a citation, PDF, or a link to where I can get this information from.
Oh, Bacon's in here. You can destroy him again, like you said, Radwin. Can you do that for me?
What would you like destroyed?
I don't know what you were saying that you were destroying Bacon about before.
Is he here?
I said I destroy Bacon, and I
is here. Yeah.
every time I talk to him.
Bacon, put on Put on your.
I've been destroyed many times.
Yeah, Bacon. Go ahead and share your 2D screen and show us how you get angles to stars off a ball without using the center of the ball. That is.
Hey, you don't use the center. You use the horizon and the star.
You're going to explain everything to us. Go ahead. I'm going to actually let other people handle this because this is great and anybody can handle Bacon. And when people start over talking, I'm just going to moderate again. Go ahead, everybody. If you need me to do this for Bacon, I will. But I think there's another guy that wants to take them on. Bacon's easy to do. All you have to do is tell him to move his eye position to the ground to 0, and his everything doesn't work.
Yeah, because that's why nobody does that. Nobody puts their eye on the ground.
Oh, why do you do that when you're using celestial navigation?
You don't put your eyes on the ground.
Yeah, your eye of height correction to the ground. Why do you need that?
Yeah, doing a calculation is not the same as putting your eyes on the ground.
Yes, it is. Exactly.
It is, Bacon.
Putting your motherfucking eyes on the ground, you idiot.
Yeah, if you put your eyes on the ground, you no longer see the horizon. So you don't put your eyes on the ground. You do calculation instead.
Exactly. I win again. He didn't even have to do the demo. Thank you, everybody. See how easy that was?
Bacon, when you're doing dip correction, what are you correcting to? Your height above what?
Your height of height is what gives you the angle correction.
Yeah, your height, your eye height above what when you're doing dip correction with the Mariner section in the boat? What is? Let's say
that's
you're
not
40
the correction.
feet.
That's how you derive the correction.
You're 40 feet above what?
Above the water.
Oh, you don't want to say it, do you, Bacon? Come on now.
That's the answer. Are you expecting a different answer?
The correct answer. I mean, yeah, I guess water. You get like a B+, but it's referred to as your height of eye correction above. Begins with the letter S.
It's referred to as height of eye correction. It's not referred to as height of eye correction above anything.
Oh, it's not. So it's not your height of eye correction above sea level.
I didn't say that. I said that's not how it's referred to. It's just referred to as height
to anything. Yeah,
that's
height of eye above sea level. Right. So you're correcting for your height of eye above sea level, right?
So you're going to speak for me.
You won't
if you're going to speak for me, then why are you asking me questions? You want my answer, or you want your distorted version of my answer?
I like Astrolab Sailing's answer, yeah. Astrolab Sailing.
Yeah, never mind. I mean, if you want to ask
directions to your sextant reading,
if you want my answer, then
no. We want the actual answer, not your opinion of the answer. We want the answer.
That's not my opinion. That's my answer.
No, it's not. It's definitely not your answer. If definitely your opinion. If it's just you're saying that it's just referred to as height of eye level, it's not.
It's height of eye correction or dip correction.
A correction? Get out of here.
It's called dip correction or height of eye correction. That's how it's referred.
Where's the dip corrections to?
Say that again.
Where does the dip correction corrects to?
What do you mean corrects to? It just subtracts.
Where does it correct to?
Oh, it just subtracts the difference between a height of sextant and the height of the star above a.
What? Dip correction is the height of the sextant to the height of the star?
No, height of sextant is called the raw measurement is called height of sextant. You're probably not familiar with the vocabulary used in celestial navigation, but that's how it's called. Height of sextant. HS.
Height of sextant above what?
That's just the name of the angle between the star and the horizon.
Above what?
It's the angle between the star and the horizon.
You won't say it. That's like, guys.
That's the answer. It's the angle between the star and the horizon.
So
that's
again,
what height of sextant
you're
means.
Claiming that the citation from Astrolab Sailing would be incorrect, that when you're taking your sextant reading, you need to make a correction to what your sextant says to get the reading converted to a sea level reading. Yeah, you disagree with that?
I didn't say anything about that. I said what the HS angle means. It's the angle between the horizon and the star. That's what the HS angle is. It's called height of sextant or sextant altitude.
No, my question was to you, what's the dip correction corrects to?
I already answered it. It just didn't like my answer. I said it subtracts the difference. It subtracts the difference between the height of sextant, which is the raw measurement, and the apparent altitude, which would be the angle from the star to eye level.
Based off of, Bacon? Come on now. What is the height of the sextant based off of? The raw measurement of what? Of what?
Of the angle between the star and the horizon.
What is the horizon,
the definition
Bacon? Bacon, you see now listen, if anyone in here is on the fence and they're listening to you, what are you doing, man? You're literally afraid to say.
I don't care. I'm giving you the correct answers.
You are terrified. You are absolutely terrified to say that height of eye correction is based off of sea level. You literally can't. You're so scared you can't even bring yourself to say those words. That is
me not giving you the answer you want me to give.
It is. It is extremely.
Can you allow me to finish a sentence before you start a new one? Can we do a back and forth here? Every time I start answering you speak over me.
You literally did it. You cut me off. I was about to say it's extremely telling how you cannot allow yourself to say height of eye corrections based off the sea level, which is where if you're corrected for 40 feet, you're 40 feet above what, Bacon? 40 feet above potatoes? Are you 40 feet above?
When I said the water, when I said
the water,
when you asked me that question,
what's the water? Yeah,
I'm trying to answer you.
Go on. What's the water, Bacon?
Yeah, if you shut up, you might get an answer.
You
shut up so I can give an answer.
You said you were trying to what?
I'm just waiting so you stop speaking so I can answer you. Thank you. When you asked me about the height of eye was above what, I said the water. You can take that as sea level. That's fine. Like it's 10 minutes. You're dancing now for 10 minutes. You're dancing now for 10 minutes because I said the water.
You're trying to figure out any way possible you can not say the word sea level.
I just said the water. That's fine. If you want to take it as sea level, it doesn't matter. We're simply talking about the distance between your eyes and the water that your boat is floating on. If let's say there is a high tide, right? So that's going to rise the sea level. That's not going to change the distance between your eye and the water. So you can simply say that's the distance between your eye and the water. That's just a simpler answer. That's not an incorrect. You're just dancing around.
So is sea level not crucial for the sextant?
Well, if we're simply talking about the position of the water below your eyes, that's what we're referring to. That's just another way to refer to the same.
Is sea level not crucial to the position of a sextant?
For the height of eye correction, you mean? Of course.
Okay.
That's the distance too. It's the distance between your eye and the water. And the position of the water, that's what we're calling sea level. So yeah, obviously.
Oh, okay. Just wanted to make sure.
We just called the same thing by two different names, and like for the past 15 minutes,
But when we say, when we say sea level, you say, well, that's not my answer. Like it doesn't have nothing to do with it.
No.
For
what I said that wasn't my answer.
Bacon, you've been trying to figure out a way not to say sea level. No, that's what's been going on for the past 15 minutes is you being afraid of the phrase sea level.
Until you guys let me finish my sentences.
Okay, yeah. So for the past 15 minutes, you've been terrified of the phrase sea level. Yeah, we know.
Okay, when you strawman me, you allow me to respond to you. You just cut me off as soon as I start speaking, right? That's not how it works.
What was the straw man?
Well, what I say was simply that the distance was between your eye and the water. I didn't say anything about... When I said that was my answer, I wasn't complaining about he saying sea level instead of water. That's not what I was referring to. That wasn't what the conversation was when I said that's not my answer. When I said that's not my answer, he was saying a bunch of things that I didn't say. It wasn't just saying sea level instead of the water. That wasn't what happened. You're just taking that from a different conversation.
Sorry, go ahead.
That's a straw man.
You said water because you were afraid. Oh.
I already said sea level. I already said that when I said water, you can take that as sea level. But what do you mean I'm afraid of saying?
Is height of eye correction based off of your height above sea level, Bacon? Yes or no?
I already said yes to that. Why are you asking that again?
Okay. Fair enough. Next point. Go on.
When I said water, I said already that you can take that as sea level. That's fine. It's just the way you're phrasing it. Doesn't matter. Like
what's your height of eye correction with a? What's your height of eye correction when you're using an aviation sextant?
You don't do height of eye correction for aviation sextant.
What about when you're using a mariner sextant, but it's foggy? And there's times where you go out on your boat and like you can look straight up and see all the beautiful stars, but you can't see 10 feet in front of you because you're sitting in fog, but the fog's not like covering the top of your, it's not covering the sky. What do you do then? And let's just say it's crystal clear. Your boat's not even rocking, which happens very often in the middle of the ocean too. There's plenty of times where everything looks like a sheet of glass. That seems like it would be really good conditions to use what's known as an artificial horizon. So, when you can't see the actual horizon, right? When you can't see the actual horizon, and you bust out your mariner sextant, what is your height of eye correction when using an artificial horizon on the deck of the ship?
There is no correction for an artificial horizon for the height of eye.
Yeah, because you're just a mere few inches above the surface of that horizon, made with the mercury table.
That's not why. That's not because of the distance between you and the mirror.
Then what is it?
That's because there's no dip.
What? Right? Why isn't there any dip? Because you're mere inches above the surface of the artificial horizon.
Because you're not sighting a horizon. Yeah, you're not sighting a horizon.
You're using the artificial horizon. The reason why there's no dip correction is because you're just a mere couple inches off of the artificial horizon. No,
that's
not. So what do you? So I set up the artificial horizon, and then I go and bust out a 30-foot ladder, and I climb to the top of the ladder, or am I kind of just standing over the table?
Yeah, an artificial horizon. You're not sighting a horizon. You're sighting the same star directly and against its reflection. There is no horizon that you're seeing.
The reflection. How do you sight a star directly with an artificial horizon, Bacon?
Can I finish? Okay, you sight the star. Let me finish. You sight the star and then you sight its reflection. You're not sighting anything that is a horizon. The horizon is simply the name of the tool that gives you the reflection.
We're not going to go down the reflection road, you dummy.
He just brought that up.
Bacon, do you use the artificial horizon to level your mariner sextant?
Level my mariner sextant? No.
Well, the same exact principles apply whether you're using an artificial horizon or the actual horizon. You still have to bring the star down to the artificial horizon and rock your sextant and make sure that everything's horizontal, right?
No. You have to simply pair the reflection of the star with the star itself.
So you don't have to rock the sextant with an artificial horizon?
No.
Are you sure about that?
Yes, so otherwise the stars don't overlap.
So you're not cutting the star in half with the artificial horizon? It's not the exact same principle, Bacon?
It's not the exact same measurement. You don't measure the same way. It's a different way of measuring the angle to the star. There is no horizon, that's why there's no dip. It doesn't have anything to do with the distance to the artificial horizon.
Yeah, literally because you're just inches above the artificial horizon.
No,
everything you do is exactly, says you.
Yes, I'm explaining you how the artificial horizon works. It has nothing to do with your...
Yeah, Bacon, if I was to put a life jacket on and jump in the water with my sextant, what would my dip correction be then?
Pay attention to it.
Yeah, I don't listen. All I need is what the hell I just said. I don't need any review of anything.
Well, then it's just
if you're too dumb to understand reality. Listen, if you're too dumb to fucking understand reality, you should be your only peer review, and everybody else should agree. They should have to because you're going with reality. Who the fuck would you need to peer review?
Just saying stuff. So.
A tree's a tree. Do I need a peer review for that? An apple seed is an apple seed. Do I need a peer review for that? No, you don't need a peer review for motherfucking facts. The earth is flat. I don't need a peer review for that.
Yeah, you do.
No, you do. Because you're a weirdo and you don't believe nothing. You don't like science. You don't like physics. You run away from reality. That's your fault, brother.
Okay, well,
get with the program.
Publish your paper and then you'll have credibility.
No, get with the program. The blueprint of life on a flat.
When you submit a peer-reviewed paper that states the Earth is flat,
then I'll did elevation.
Do you know how many
peer-reviewed papers have papers you want on elevation? How elevation doesn't work
how
on
many
a
have
ball.
been accepted?
What do you mean? We're going to accept what you draw on the wall.
And counting.
Yeah, how many have been accepted?
I accept whatever you draw on the wall. Go read your paper on globe elevation.
Until they're
Start
retracted.
to finish, read your paper on globe elevation and how to draw it for Democ. And then when you can't, dummy, you can't follow fucking basic instructions on drawing a ball or proving it on the wall, then shut up. We don't have to do any of that.
Well, then I don't have to listen to you.
Follow instructions. A, get your ink pen. B, dot to dot your circle on the wall. C, prove that's elevation. We'll all go home. We don't need any more. You can write your own books on retardville and on how balls work and elevation of balls. You could write 20 million books. Here's how elevation on balls work. You'd be the only fucking human in the world who wrote a book on elevation on balls and proved it.
Who are you talking
and you'd have to get all the money.
Yourself.
Science, no, I'm talking to a goopball who doesn't know globe elevation, where science doesn't back globe elevation. Science couldn't tell you how to produce globe elevation or demonstrate it to your grandma or a little kid or a guy down the road that has $1 million waiting for you. Fucking goof troop. So when you can get to demonstrating fucking globe elevation, all the globe guys will have checks for you. When you demonstrate anti-gravity is gasoline, all of them are going to give you checks.
I feel sorry for you, Democ. I do.
I feel sorry for anti-gravity tires that roll in a circle. Can't keep them down.
You're already smoked. You're already smoked on gravity. Get the fuck out. Don't even talk about it anymore in here.
Oh, excuse me. Sorry.
I didn't say anything about gravity. He did.
Hey, flat earthers, what's going on?
Hey, you sound cocky. What's up, buddy?
Hey, yeah, do you guys just sit here quietly waiting for Globers to come? It's kind of weird.
Yeah, I think that's weird in this. No, I find that weird too. Like, I'll come in here and there'll be like 50 people and everyone's dead ass silent.
It's like you guys are just waiting for a Glober to come in and like make fun of you. It's kind of strange.
We're waiting for a Glober to come in so we can put him live on 2 streams on YouTube and make fun of him.
Sure, but the problem is I always like bitch slap you guys around and I win the arguments, so it's not as fun.
When you get ready to leave because you ain't got a globe.
What? I don't. Okay, that went over my head.
Lou, what's your best argument?
Other planets around.
That's not enough purpose, you retard.
It's kind of simple. Yeah.
Round gas.
How does looking in the sky make the?
How does every other planet's round, but ours is a square. Like
how does looking in the sky make the ground?
Get out of your mind, bro.
Bro, I mean, it's kind. I mean,
dude, how does looking in the sky make the ground curve?
Thanks for muting me, fag. Yeah, so basically, like, if other planets are round, our planet is probably round too, right?
Dude, how does looking in the sky make the ground curve?
It doesn't make it curve. You should just assume that it's curved.
Who says Earth is a planet?
Everyone.
What about Venus? When you look at Venus,
hang on, let's get to that. Hang
is
on,
Venus round?
Yeah.
Is Venus round?
Yeah, hang on. Why is Earth not a planet? Repeat that. So you don't believe in
wandering stars?
Okay. Do you believe space? Is space?
It doesn't meet the criteria. It doesn't meet the criteria set out by both modern and classical definitions.
By said T-Dub on Discord. Okay, great.
Okay.
Where would you like to start?
He broke TOS, right? Or did I miss here?
What?
Check. You guys hear me?
Oh. Yeah, he said the F word.
All right. Well, he's going on mute.
Oh.
He did it on purpose. He's bailing out.
What F word? I don't know if I heard it. Maybe I didn't hear it.
Yeah. I'm watching Angels of Light on Modern Day Debate right now. Do you guys know who he is? He pops in all the different servers. Angels of Light or Angels of Light, whatever.
Yeah, he was on with McToon, right? Or no?
Did he debate McToon?
No, never mind.
Brian did last night, and it was it left a lot to be desired.
Brian should learn to compose himself, I think.
Right. See, like just being an audience member in that live chat, at one point it was like it had to have been almost 40-60. You know, but when they do the polls and they go, is it the Earth flat or is it a ball? And then it dropped down to like 30-70, and it bottomed out to like 21, whatever. But for a minute there, it was almost 50-50. It doesn't. And what flat earthers have to realize, no matter what form you're in, you're always going to be outnumbered. It's just inevitable.
Not necessarily.
He didn't need to spiral during Q&A.
Right.
I think it's all about what they choose to talk about too. When the Glober's always the one that gets to pick, and then they have like fucking they done sat for 2 weeks and thought let's do this topic, and they got all this shit, and you come in there and you're just knowledgeable on what the fuck you want to say, and they have this certain thing they're going to like push with this topic, the idea, the whole narrative of it. It all works together against you, like you just said, in a weird way, but. If you're a funny bastard and you're and you do the right thing and say the right shit, like it has to go, it has to sway towards your way. It just like a little bit more, like it has to. Especially if your truthful shit, like statements, are truer than his. All he has is red face and words he thinks are gonna be better than yours. You know, tenable. Like, get the fuck.
He was getting real. Damn it, my Wi-Fi went out. Oh, it's back.
They won't debate any topic that makes any sense. And like when he demonstrated a ball, does he honestly think that's a fucking demonstration of what was asked? Do Globers really believe that?
What?
That's the problem. Globers believe that ball he held up is their model. And they believe 100% him spinning that fucking piece of shit made any sense.
Huh?
The ball, the Siemens, when you spin a ball with the light bulb in your room, and you got a big ball that's like a fucking globe off the desk. It's really huge. You know, like a 2 foot tall or 1.5 foot tall or 1.5 foot wide ball in your hand. And the light bulb in your room's only like 3 inches, right? And then you think they think that's going to make, that's just light from your room on the ball. That's the sun.
Huh. It's just a concept, brother.
What is nowhere close near necessarily any kind of reality we're ever trying to talk about? Cool, then.
It's just the basic concept.
What is a not concept that's not real, that's not the thing you do, that has nothing to do with how it works? That's really going to help us, isn't it? Hey, kids, we're going to tell you a concept of making this, right? But then when you really want to do it, remember, you're all going to get hurt. Huh? The concept is safe, but really doing it's going to chop our arms off? I don't think what you're saying makes any sense, buddy.
It's just
I think you need to stick to the real reality and not concepts if you're trying to explain reality.
Why not? Why not use concepts?
Why not a ball be a ball? So you're telling me it's too hard for a little globe ball and a fucking sun ball to be their self? Maybe if you did it to scale, maybe the two balls could be their self. And then we could see what you were talking about with a globe model. Maybe with little temperature pads on that bitch to show us what the heat is hitting it from some kind of hot sun you got somewhere. Maybe use the real sun. Take your ball outside, roll it around in fucking circles.
I'm not going to use the real sun.
Why not? What's better than the real sun to be the real sun? See what I mean? You guys are fucking weird. What, are you going to use an ice cube for the sun? Is that what you're thinking?
No, you just use a light bulb.
Supposedly the model. This is what we're working with, boys.
A light bulb.
Science is going to show you an ice cube for a sun because suns are hard.
A light bulb.
A light bulb is a sun? I thought it was a ball of gas.
They both give out light. That's the point.
Huh? That's the point, huh? Okay, yeah. So why don't you use a Bic lighter or a campfire at night?
You could use that if you want.
Okay, so go outside at night and use a campfire and show us how your globe model works with the seasons and temperatures on it.
All right, I could do that.
How far away are you going to get from the campfire?
I don't need to get that far.
You need about 93 million or something.
It's about the concept, not the distance.
No, you need 93. No, exactly the concept of 93 million something. Not the concept of being arm's length away, weirdo. You think arm's length away from one light bulb to a bigger than a basketball globe and a little bitty light bulb is giving kids the concept of a fucking huge sun gas and a little piece of grain of sand 93 million miles away, but still like a grain of sand to the sun?
Yeah.
You think that gives us...
Yeah, it does.
So when you look at that model in the classroom, your teacher's holding up a grain of sand and a light bulb? What's going down? I don't see that.
No,
hold on a minute. No, we want the scale model. We want the version that works, one that gets the right way.
Yeah,
so make the light source smaller than the ball? Wouldn't that prove flat Earth?
It don't matter.
No, you're trying to prove a ball, not a flat Earth. So you don't want a little light source. You want a big fucking light source.
As long as the light's shining on it, that's all that matters.
And then you got pinholes so we can see what the globe sees, what kind of sun it would see? Or you just don't want to do that?
What's the pinhole for?
It's going to be you. It's going to represent your goofy ass on the ball. That little pinhole camera is going to be you looking in that direction. It's going to record that direction. We're going to see what you would see on the ball. Oh, that's exactly what you have to do.
Why?
See a fucking sun in Antarctica spin around you, or a North Pole, or to see your equator. What are you, not okay? Because you don't know what the fuck that looks like from a real ball. You have an imagination. You see what happens over flat Earth. That's not a ball. I don't think you've ever seen what happens on a ball.
No, we're on a ball, son.
No, you've never seen what happens on a ball. You just asked, why would you do that? So you could imagine what it really is like to be on a ball. You would need a ball for that. I'd imagine. Not outside on flat Earth.
No, I can imagine I'm on a ball. I don't need anything else.
By looking up at the stationary from a stationary flat Earth?
Yeah.
So you imagine you're on a ball when you're on flat Earth. Maybe that's your guys' problem. You should stop imagining balls.
I don't assume it's flat.
Assume you can measure. Shouldn't assume anything. You should measure.
NASA says it's flat and stationary in their documents for building airplanes.
I don't assume anything.
Assume it's flat and stationary.
That's just for convenience.
What is reality?
So reality is convenient?
Yes.
No, it's not reality. They use it for convenience. Reality is not convenient. That's the whole point.
So what's the best way to show a rotating planet moving so fast, 50 different speeds and directions, by showing a non-rotating stationary planet? That's what you're saying? That's how you demonstrate movement? That's the closest way for globers? Globers are going to show you stationary stuff not moving at all, to show you that you're on a spinning planet going through space and falling and spinning and chaotically This is weird. You guys have some weird ass fucking ways to show kids the opposite of reality and keep telling them it makes sense in reality.
It's not chaotic.
What isn't? The demonstration you haven't came up with yet? The wrong model? The flat stationary Earth you keep telling them's moving? It's weird, isn't it? We don't even have your idea. You got an idea of yourself, and us flat earthers, me and the other gentleman right here, we couldn't even fucking fathom the idea of what you're talking about because you don't have it.
I know, that's why you're a flat earther.
The globe doesn't exist. Well, what are you without a non-existent globe or no globe physics? What could you be?
I have a
Demonstrate
proper
globe
imagination.
physics. We'll take a look at your globe physics. How do you make stuff orbit? How does magic gravity stop working for you in a lab when you got balls of different sizes, different masses?
What do you mean?
Different masses. Why are they not orbiting? They're balls. What would stop them?
Because of the Earth.
Because so mass doesn't attract mass, and no orbits happen because of Earth. Okay.
Yeah, because Earth is massive, bro.
So there's no such thing as an orbit because of Earth. Now you're with us, no Space Jam. Now you just eliminated space with us. No orbits down and around the Earth because of Earth. You can't go down around the Earth. I'm with you, brother.
What do you mean? Things on Earth are going to be attracted to Earth.
Hey, it's your words. You're the one that said because of Earth you can't do it. I'm with you. Flat Earth will not allow you to go down.
You can't attract two balls on Earth because they're attracted to the Earth.
Attracting balls on Earth? Where have you seen that happen?
That's what you're saying.
No, that's what you're saying's happened with gravity, dumbass. You're saying you've seen two balls attract each other. Where have you seen that?
If one ball is the Earth, if one ball is the Earth, yeah.
Have you seen a leaf attract to a ball or any other mass?
Yeah. Yep.
So you have stuff attracting horizontally, and you have helium balloons going away horizontally that way to space?
It's not. Why would it be horizontal?
What do you mean? Why would it be? Every direction is to space from a ball. Are you retarded? Go get a ball.
Earth,
go get a fucking ball.
Are you
we'll
retarded?
prove what we're talking about here. We're not playing games here. Go get a ball. Act like you're on top. Point any direction. Where are you pointing to? Space. Don't be so retarded.
What?
I know it's hard. Balls are hard. Ball physics that don't exist are fucking hard, brother.
Everything is attracted to the center of the Earth. It's simple.
Where at? Show me that. Show me helium balloons stay underwater, or air bubbles stay underwater when I pile water on them.
Why do you love helium balloons so much?
Dude, I got a dense ocean. The whole fucking ocean is weighed down on this air bubble. I'm about to fart, and this air bubble is going to outdo the whole ocean and all of Earth's gravity from a big hole, and it's still going to release. What did gravity not do? Fucking nothing. Gravity could not affect my air. Now you think there's air balls called suns. You think the sun is an air ball?
Underwater? Hold on.
No, you're underwater in space. You got an underwater air ball sun in space floating around, don't you?
No.
Yeah, air ball planet, a gas planet. No.
Yeah, what? You're
rambling. That. Prove that can happen.
Stop, dude.
Magic
try to
man.
Have one coherent thought for a second.
No, you can't have one coherent explanation or demonstration of ball physics. You will not. You will not demonstrate globes of gas in a vacuum. Show us how that works, globe physics. Coherently, please.
In a vacuum?
Yeah. Outside in your vacuum, you have a ball of gas you think are planets or suns. Could you produce either one of those since you know the ingredients, you know how it all works? Please, globe physics.
What do you think, I'm God?
No, I think you can go to a lab. Now skedaddle and get her done. Show us how the gases work.
Things work differently at different scales. What don't you understand about that? What works
at what scale that you're not producing that and you're talking a good game? You're going to hurt our ear now, right? Can you hurt our mind with physics with our eyeballs, or are you just going to fucking beat our ear to death?
Just your ears.
Just our ears. You heard it here first, folks. The great globe deniers can only deny their own globe and prove flat Earth. They're going to beat your ears up till you're blue in the face, and they'll never demonstrate anything. Here we are. A happy place. It's good to be a flat earther. We can demonstrate stuff. Isn't that cool?
I can demonstrate a lot of shit.
No, you can't. You can't demonstrate a fucking thing to do with the globe. You just went over it all that you can't demonstrate. Fuck, you don't even have a clue how.
It's just gravity, man.
No, you don't even know what a model is. Shut the fuck up. You fall short on knowing what a mile is to scale. Stupid. Scale that down. Yeah. Yeah, it's called 1. This is hard, right? So if you got 24,000 miles for the globe, you'd use 24,000 millimeters or half a millimeter or 24,000 fourths of a millimeters. Then you need 93 million millimeters. But that's just for your model that you know all about, that you can't produce, that nobody's ever seen before in their fucking life. No one. No human has ever made a globe model anywhere. I don't know what their math is even for. What's your math for when you can't use it to produce your air gas planet?
Why does it need to be to scale?
Because that's how you're supposed to make the cake of gas planets with your ingredients of math. Math is supposed to be your ingredient to physical fucking attributes of property. Just like I need 4 scoops of this, 1 pound of this, 15 liters of this. Understand? Gravity guru, your fucking gravity math. The math is supposed to be your ingredient to get your planets made. This much hydrogen, this much helium, made from this much squeezy magic in a vacuum. Right? So get her done. Show us how that works. Show us how you prove that.
You want me to make a planet?
Brother, I want you to put 2 gases inside a vacuum chamber. It's going to make a planet on its own, right? How are you going to stop it? You stop nature and evolution and gravity and stuff? What a fucking powerful dude.
You're
about a bad
scale.
motherfucker. You are anti-gravity.
It's all about scale, brother.
What is the non-existent thing you can't do but talk our ear off? Thank you. It's all about talking our ear off to scale. I got you.
It's just gravity, bro. It's beautiful.
Yeah, what you have it.
Shut the fuck up with your gravity, you globe retard.
Gravity. It's just gravity. It takes balls to admit that it's a globe, you know what I mean? You gotta have a big set of balls to know it's a ball.
Oh, you didn't last long, did you?
We need more conversations like this. This is good.
Yep. Shows the status of globe these days. Quiet. Nobody can talk about it anymore.
Man. Maybe they're bored.
Yeah, they should be, because they got nothing left. They tried and tried and tried, and we just sit here and knock them down, pulling strikes all day long.
You do that.
Easy. Anything you say that's globe proof, we knock it just knock it right out of the ballpark. That's no good.
I haven't seen that or heard it.
Oh, well, you haven't been listening.
Oh, okay. Well, the globe is in the claim. Flat Earth is the claim.
How is flat Earth a claim?
Because it goes against the consensus. So you have the burden. Yeah, the globe doesn't have to prove anything. You get that, right?
Everybody says
Northern Hemisphere. Different constellations in the sky.
Everybody thinks there's unicorns in their garage. I have to go along with it.
Well, if you were talking about unicorns, that'd be different, but that's not what we're talking about.
Why is it different? If everybody thinks Santa Claus, if kids 6 and under think Santa Claus is real, does that make Santa Claus real?
I don't know. If you could show the Santa Claus is real, that'd be different.
No. You don't know if Santa Claus is real or not. You might have something wrong with you, dude.
Somebody else might think Santa Claus is real, so what do you do with that person?
Look at them like they're fucking nuts. Ask them if they're okay.
What do you with a person who thinks Santa Claus is real?
Yeah, it's called the globe.
You fucking for real, man?
Yeah, they believe the Santa globe is real. Globers believe the Santa Claus globe is real, and we're trying to convince these kids. Grandma and Grandpa lied. The government
Raiden
lied.
said that he believes in Santa Claus still. He's not sure if he's real or not. Yes, you did.
I said I believe in Santa Claus. When did I say that?
You said you're not sure.
No, I was just going along with you. You're talking about everything but the Earth. So unicorns and Santa Claus.
The Earth is a unicorn.
Irrelevant stuff, you know?
Right. The globe unicorn. It's irrelevant, right?
I was just making the point to him that the globe isn't a claim.
The globe is a unicorn. We know. You don't have to make that point to us.
How is a globe not a claim?
Because it's the consensus. That's why flat Earth is the claim.
What does that mean by it's a consensus? I don't understand.
You don't know what that means?
No.
Okay, well, I'll explain to you one time. The scientific consensus back.
No,
the Earth
that's
being
wrong.
A sphere,
There's no scientific papers that measured the Earth to be a ball.
You can read about it. Use Google as your friend.
That's what I'm telling you. There's no papers that say Earth is a ball.
Okay, who told you that?
Dude, you're the one who said it's there. I said no. You need to provide it.
Show me 3 that says the Earth is flat, and I'll turn into a flat earther
That's
immediately.
not how this works. You made the claim. Provide your proof.
I don't need to provide anything to you. What do you mean? Look at the satellite image.
So you jumped to space.
Debunk it.
Wow. So you got nothing left.
Yeah, debunk it.
You got nothing left. I jumped. Yeah, airplanes take the pictures.
No, airplanes aren't satellites. What do you mean?
I told you how you're getting your pictures.
Read about it. What are you asking me for? You know how to read, right? Or are you illiterate?
Nigger.
Has anyone got a premise conclusion for the flat Earth hypothesis? That's what I thought.
If most of the known surface of the Earth is water, and water at rest seeks level, then the Earth is flat. There's your
I don't know. What makes you think it seeks rest? When have you ever seen water rest?
No, I said when water is at rest, it seeks.
When is water at rest?
You know, in a contained environment that has no dynamics.
What, like the ocean? You saying the ocean is a contained environment?
No, yeah. Well, I would say that water needs to be contained. Yes, in every scenario, it has to be contained.
Is the ocean contained water?
I would say that the land contains the water.
And would you say the ocean is contained within that land?
Yeah, lower than it.
Yes.
Lower than the land, not higher. No ball.
Yeah, but I don't ever see the ocean at rest.
I don't ever see the ocean.
People have thought the tides. People have thought the tides for millennia. I'm afraid.
Do you really think this is a good
The ocean has never gone to rest.
Go above the dirt.
Hold on.
White horses that represent the sea foam bouncing off the rocks
really listen?
have never laid
do you
rest.
really think? Listen, Flippy Flop.
Nightly,
you really?
the waves lay siege.
Are you not listening? Are you going to listen? Are you really thinking that this is a good line of argumentation against what I said?
Yeah, because you're saying at rest, and I'm like, bro, there is no
just
at
because
rest
of
in water.
hydrostatic equilibrium. So we can say for sure that water at rest will seek level on its surface. You agree with that?
Even in lakes and rivers, you see water moving. It moves.
So what
no, there is a state.
If water
there is a state at which there is no. Just one sec.
Just look across the surface, my friend.
Listen, dude. In the field of hydrostatics, there is a term that they use for when a liquid is at rest. They understand that due to the molecular theory,
fools and they're idiots.
That there is movement within the molecules. They understand that, but for all intents and purposes, it looks to us, the surface, as if it is still. They call it at rest.
You have given me no good reason to believe that water is ever at rest. Whenever I look at the water in my cup, I see it moving.
You're just being pedantic. You're just being a pedantic fuckwit. That's all you're being.
Ever-present movement.
You're not presenting a good argument to what I said. I gave you a
being more difficult than you have to be.
You said water is flat at rest.
You're intentionally being a fucking difficult little child.
In fact, when I fill up my cup, I actually see the water act like a dome over the shape of the water. It's not a flat surface.
Buddy, maybe you should put the Adderall drip in.
Do you want me to show you a picture of it making a dome over the surface of the cup?
You're talking
I can send you a photo of it.
Oh yeah, let me just let you get it all out, buddy. You go ahead and say everything you need to say.
Despite its container being absent from its presence, the water do not floweth over the rim of the cup. It maintains its position in domes like a present shelter.
Add a bit more, dude. Add a bit fucking more. See what happens.
Do you not understand?
You don't. Think you're going to come in here with some sort of fucking gotcha, And you've got nothing, dude. Nothing. You've got meniscus on the top of a cup. Holy shit, Earth must be a globe. Fucking idiot.
Water at rest is not flat, Brahim. I see it move even in this, and even when it is doming like it is, it's still moving.
You said you've never seen water at rest.
Bro, it's not at rest. It's still moving.
How would you know then?
Because it's still moving. You can see if you put like a particle, like for example, if you put sugar in there, you'll see the sugar get moved around by the water.
That's cool.
As the hotter water goes up and the cooler water goes down, you actually see, the movement.
That's cool. Did you have a point?
Yes.
Which is?
I made the point.
Nope. You didn't make one.
Water is not at rest and it is not flat.
Not at rest and not flat.
Yes. And you are idiot.
Is that an argument?
That's a claim. I'll back my reputation on that claim.
Well, it's kind of a red herring to the current claim.
It's fine. This is a new argument. I felt that we just concluded the previous one.
No, we didn't.
Oh, did we
didn't really argue
it was
anything.
pretty conclusive.
You just said it's not.
It sounded like we agreed. It sounded like we agreed. Really. It's not at rest, and it's also not flat.
You're just imagining things. You said it's not at rest. Doesn't have to be.
And it's not flat.
Well, it's seeking level. Is it not?
It's seeking level. What does that mean?
Yeah, so if it were perfectly still,
are you a Freemason? Are we trying to meet upon the level? Is that what you're saying?
No.
Do you want to part upon the square, or are you just... What is this?
This is you just saying stupid shit to avoid the point.
Cool, bro. Some wear collars, other wears chains, but, no penny makes a dollar.
So you should say that it's seeking a curve if you believe that it's a globe that this water is conforming to, not that it's just not at rest. Because you could say the same thing either way. Oh, there's waves, bro.
Yeah, bro, there is waves. There literally is waves.
It was a non sequitur.
It's actually such a great point that you brought up that there are waves, because, that's not flat. That's not
like
flat.
stacking water?
So, when you come over here and you say the Earth is flat, bro, I'm like, bro,
yeah, I know it's flat because
that contradicts my experience, bro. That contradicts my direct experience.
You cannot stack water. If you shut the fuck up,
so you're out here talking like the Earth is flat and there's a mountain
above the dirt,
speak over the fucking top of everyone. Right, so for your benefit, I've posted a citation in the side chat from a physics textbook, Henry and Katz. Henry Samat and Robert Katz, physics textbook, chapter 8, page 152. The points at the same horizontal level surface within a body of liquid are at the same pressure as long as the liquid is at rest. In fact, this statement is often taken as the definition of a level surface. I want you to go now and eat shit. An idiot.
Can you guys kiss already?
Yeah, because on the globe, water at rest would be curved. So what if I came back and said, water's never at rest? You'd be like, well, you're retarded. So you're just showing you won't engage with the point, which is all I need to hear.
It's just a deflection away from Flatsy's main point.
Yeah, he's just obviously a troll. Yeah.
So why do you guys think people are retarded? It's not flat. There's hills. Doesn't measure flat.
Hey, is this a place to present a globe Earth proof argument?
That'd be awesome. I appreciate it.
All right, I'll do my best. I'll probably fail, and you guys will slap me down.
It's all right.
I just want to see stacking water.
All right, I want to start. I want to come at this from the field of engineering, or surveying for engineering, civil engineering. So, land surveyors, I've discovered through a book called Surveying for Engineering.
But not the land? I just want to make sure you're not physically doing or touching any water. You're just reading books. Go ahead, brother.
Yeah, I heard the gentleman earlier referring to a physics book for definitions and for information, referring to Surveying for Engineering by Uren and Price. This book's been around for like 45 years. It's basically a high level. It's like we could call it like a Bible for surveying and engineering.
Does it just show us where water can be higher than my mud puddle or your aquarium, or where you don't need any aquarium walls to make a 10-foot high mud puddle water aquarium?
Yo, D-Muck, you gotta chill a little bit. He's trying to chill, bro.
Yeah, cool story.
Okay, so here's the argument. It goes like this. The geological surveyors for engineering, they perform their surveys effectively. This is my first premise. When they do their work, which includes a bunch of math, they're successful.
Yeah, but do they touch water?
Being that they don't fail in their projects, the math is correct. That's
2 + 2 is 4. I didn't have to touch anything. It doesn't make sense. Where did they touch grass or water?
All right. So, if we accept that they are successful in their leveling efforts,
making shit up, no.
I'm sorry. Am I just gonna be heckled while I'm trying to make the argument for you to examine, or are you?
Yeah, I think this guy is triggered.
Okay, so premise 1, they are successful in their leveling attempts, right? Premise 2 is that in the work that they do, they are including a radius value for the Earth, which is 6,371 kilometers. Their math depends on the radius value, and it does work. If the radius value was wrong, their projects would fail. And since their projects succeed, and they're able to do this in every direction, meaning a radius value is being able to be applied in every direction successfully, the only way to have a radius in every direction is for it to be a sphere. Therefore, the Earth must be a sphere, or else their projects would fail.
So I heard a claim in the form of an argument. So there's a lot of nuance there that's going to need to be addressed.
Well, I stated 2 premises, which premises are claims in themselves, but the conclusion.
You're saying that they go out to achieve a certain. They go out to achieve a certain goal, right?
Yes.
Practically do something in reality. What is that they're going to? What are they aiming to achieve?
Leveling and gauging distances.
Elevations?
I'm sorry, you were cut off there. What'd you say?
The elevations?
Yep, elevations. Yeah. These are some of the things that they do, right?
Okay, that's what they're going out to do.
Right. I guess level and gauge, you could say that it's Yeah, right.
But leveling, as in a horizontal plane of reference, right?
Correct. A constant elevation. Yeah, that would be level.
So and then you said that they apply a value, a radius value, 3,959 miles. What form do they apply it to that horizontal plane of reference?
Right. So they apply a curve correction formula, which is CC being curve correction equals.
Why would you do that? Why would you do that?
To account for the curve.
I haven't measured it yet. This is supposed to be measuring it, not presuming that it's already there and using values which represent that curve, which you haven't yet measured and demonstrated to exist in the first instance.
Well, the thing is, even if they had made the number up and guessed it, or if an angel came and told it to them in a dream, or if it was given to them in a fortune cookie, if they applied this number into this math and it was the wrong number, their project would fail. But since the projects don't fail, it must be the right number. You see?
They know they haven't failed.
Because they come up with the correct. Because they come up with the correct distances and their buildings end up.
So they know it's correct. If that's the method by which that they're using and saying that they're not incorrect, they're claiming to be correct using that methodology, right? Then how do they know? By what other standard was it compared?
Well, because let's say if they're, 15 kilometers from a mountain peak, and then they
know they're 15 kilometers from a mountain peak.
Well, they can pace it out
using the method that you just described.
Right. Because they can pace it out afterward and confirm that the measurements correspond with reality.
Pace it out how? How do they? What do you mean pace it out?
Well, they could, roll a wheel and count how many revolutions. They could pull out a tape measure. They could in
that's how they get the distance to the mountain in the first instance.
No, they can calculate using the theodolite and taking visual reference points, then applying the curve correction formula in part of the equation of measuring the distance, and then they can confirm that they got it right, and it corresponds to reality.
So they do it with their guess first, and then take a measuring wheel and walk to the destination target.
Well, no, that's a mischaracterization. It's not a guess. I'm saying even if it was a guess, it just happens that they ended up with the right number for the radius value.
It would be a guess.
Yeah, even if it was a guess,
you don't know.
Saying. Even if it was a guess, the point is that
it is a guess.
But the point is
a guess.
All right.
Where did they get that radius? Where did they get that radius value from to be able to apply it in the first?
That's actually irrelevant to my claim.
No, it's not. If it's the foundation of this claim,
it's not relevant.
You're going to have to verify that that's correct.
No, it's not relevant. Who or where?
It is relevant because if that part's not true, then any derivatives, then anything derived from it can't be true either. Like if that part is incorrect or invalidated, then I can't determine the validity or the veracity of anything you're claiming is derived from it.
That's false.
I'm saying that this radius value is fundamental to this.
If they received the number from a con man pedophile, it wouldn't matter. If it's the right number, it's the right number.
Dude, I can't entertain any claim that is based off this value until we've established that this value is true.
But the proof of its trueness is in the result that it corresponds with reality.
Well, that would be affirming the consequent form, a logical fallacy.
No, wrong.
Yes.
No, it's right. 4 plus 4 is 4.
It's also a pragmatic fallacy.
And a pragmatic fallacy.
4 plus 4 is wrong. 4
Can
plus
you define
4 is
for me
8.
how it turns out to be a fallacy?
4 plus 4 is 8.
Where did they get
sphere?
What are you guys talking about?
By asking me, you're performing
radius
a genetic
fallacy. Where did they get the radius value?
You're performing a genetic fallacy. You're saying that the origin. You're saying that the origin of the number determines whether or not it's true.
Oh my!
I want to evaluate the process by which that value was derived.
Genetic fallacy. Genetic fallacy.
It's not a genetic fallacy.
No, it's not a genetic fallacy because I want to determine the veracity of the methods used in order to get that value to see if it stands to reason or has any sort of flaw.
No, but this is, if correct, I told you that this is the recipe for making cookies, you follow the recipe, you get cookies, then it is a recipe for making cookies. It doesn't matter where that recipe came from.
What's the recipe to measure the earth?
I'm not telling you. That's not what I'm telling you. I'm telling
you're not measuring earth. Go home. That's what you need to do. That's the whole point here.
All right, I'm telling you the recipe for curve correction.
You're telling us math recipes to do math.
In measuring distance, I'm telling you the curve correction.
So far, you've made claims. You haven't actually provided anything like that shows that anybody actually even did.
The proof that the Earth is round is my girlfriend has a fat ass.
Well, actually, I did. I started
immature little shit. Piss off.
I started with the proof that this is real. This is what engineers do in the field. This is in their textbooks. This is the formula that they use. They apply it in reality, corresponds with reality because we get the results that we're looking for.
You're claiming that's the case, right? I said that there were still nuances that need to be addressed. Exactly what did they do? Where were they? What instrumentation did they use? How did they do all this? At what times a day was it performed? What else did they account for? There's a lot of other things involved, right? So you just made this claim that this thing was done, that someone went out to achieve something and they could not have achieved it without this precious radius value number, which you refused to discuss the origins of.
So you're saying, your argument is, I don't believe you that they do this?
No, the argument is that you don't have no proof of that radius value. That's the argument.
I just presented proof of the radius value.
What is it?
That when we apply it as a curve into the curve correction formula, it corresponds with reality.
So you don't have no actual proof. You don't have an observation.
That is actual proof. That is.
So you didn't measure it then, right?
That's not the only way to get proof.
So it's no measurement, no observation.
This is a test of it, and the test shows true.
Test of what? We literally just told you.
This is a test of the radius value.
Great. It's affirming the consequence then.
See, the thing is, if the number was not correct, their projects would fail.
Yeah. So
since the projects don't fail, the number is correct.
So basically, you seeing something.
But I wasn't affirming the consequence. Actually, you called that one. You said that if the number is correct, the project doesn't fail. The project doesn't fail, so the number is correct.
Affirming the consequence.
Yes.
Yeah. Well, regular Joe is right. That'd be an affirming the consequence fails.
Well, no, it's the law of excluded middle. It either is correct or is not. There's no other option.
No, it's affirming.
And if it's not incorrect, then it is what?
No,
it doesn't matter. The way you structured it was invalid. Circular reasoning.
It's not circular reasoning.
It's
law of excluded. It's law of excluded middle. There's no other option. This is not a false binary. It's either incorrect or it's correct. It can't be both.
You're already assuming that you are correct. You're affirming the consequence.
No, I'm proving that I'm correct.
No, you're not proving anything. You're assuming that.
You can deny
correct.
that, but I actually I've set up a logical syllogism. And it's totally sound. It's totally sound.
I'm explaining it. You just basically saying that to yourself. Now it's just confirmation bias at this point.
But you still haven't shown that they actually
you already came up with right. You already came up with a radius. You already came up with a radius value without confirming it to be true. This is not a measurement. This is just a calculation. And you're saying that somehow you're using it as a correction for actual measurements, even though the calculation isn't the actual method because you haven't measured it. You just put in this calculation in there, and then you say, oh, if I see this in reality, therefore it's true. It's a classic affirming the consequence fallacy.
At least show some fucking documentation and point us to the exact page and paragraph or whatever where the measurement was taken and they applied whatever formula you think they needed to correct for, right, in order to get a correct distance. Show us that.
I can do that.
Okay, so you're going to show us where you measured the curvature, right?
That's not what he said. That's a
the documentation should be
goalpost?
identifying the curvature that you're getting this calculation from. Or else you just saying you just putting it in there. That would just be an assumption.
Well, he asked me for one thing, and then you asked for another.
Oh, so you want to run away from the affirmative consequence fallacy that you in, huh?
That's not what it is. You're just wrong about that.
No, I'm actually right about that. You just explained what it was. If I assume P is true, therefore I would see Q. I see Q, so therefore P is true. Affirmative consequence.
That's not my argument. That's not how it's structured.
That's literally what you just said, verbatim. You said, based upon my calculation, I assume it. I based upon the calculation that I'm already assuming to be true. If I apply it in reality, just basically putting this calculation along with a measurement, and if I see that, therefore my premise is true. Affirmative consequence in logical fallacy, circular reasoning.
Do you understand what law of excluded middle means?
Yeah, it's a affirmative consequence, which you explained, sir. I just told you what it was.
No, I'm asking you, do you know what, can you tell me what law of excluded middle is? I don't have to know what you know. I just know what you just did. No, you don't know what I just did. You're misrepresenting.
I just told you what you just did.
No, I'm not doing the P equals
Q. Trying to explain it another way. I just told you what you just did.
No, you're just coping, actually, because you're just not coping. You're sort of straw manning what I'm doing, and it's a cope.
So I'm straw manning what you actually just said to us.
Yes, correct.
Great. So show me where the straw man is at.
You're saying that I'm saying if P, then Q, Q, then P. And that's not what I'm doing.
Okay, that's just a formula of the affirmative consequence fallacy. Explain.
Right. What I'm doing is a different formula.
Okay, based upon what you told us, you said that you're putting a radius value, something that you already assumed to be true. It's not a measurement. It's not nothing that you observe, right? It's just something that you're going to apply, right, with a method of a measurement. So it's just a calculation. And if you apply this calculation based upon a prediction that you see into the real world, therefore that calculation is true. That is a classic affirmative consequence fallacy, because you already begging the question that the radius value is true before you apply it to anything like a measurement, which is not a measurement, right? It's just a calculation for a correction for an actual measurement.
The difference between what I'm doing and what you're saying I'm doing is this. In the affirming the consequent fallacy, it's structured that if this, then that. Well, we have that, therefore we must have this. Mine is different because in the affirming the consequent fallacy, there are other possibilities for what could explain Q. That's the problem. If P, then Q, Q, then P.
It's just illogical.
No, I'm right.
No, it's not. Wrong.
No, the reason why the affirming the consequent fallacy exists
is affirming the consequence fallacy because it's indirect. You haven't proven P to be true yet. You only using P in circular reasoning. That's the purpose of affirming the consequence fallacy. Not it could be something else. What are you talking about?
Exactly.
In my formula,
it's circular reasoning, Big Tech. Stop trying to run away from it.
It's not.
It's circular reasoning.
I mean, you can keep asserting
read the
that.
Philosophy backing it up.
You can assert that all day, but
it's circular reasoning. You don't have no proof. You haven't validated your claim of curvature, sir. You already assuming it to be true. It's just a calculation. It's just a concept at this point. But you assume that it's true, so therefore you're going to put it with a measurement, right? Which is actually a correction. It's not a measurement. You're just calculating a correction. Therefore, it works within your paradigm. Therefore, this curvature must be true. The thing that you already begging the question of. Classic affirmative consequence. It's if I assume P, this calculation of a radius value to be true, then I would see it within this. Then I could correct for this measurement, and I would assume that it would be true in reality. I corrected. This model actually works according to this calculation. Therefore, P must be true. Classic affirmative consequence fallacy.
My argument is
circular reasoning.
Well, you gave an affirming the consequent, and that's what the logical form you gave is, and that's always invalid.
The form of the argument is this: if this equation works, then the Earth must be a sphere, and there's no other thing it can be.
Affirming the consequence.
Yeah, if this formula works, fallacy, it must be a sphere.
Yeah. You realize that you're.
Well, it seems like you reworded it this time, because the other time when you're talking to regular Joe, you said if it's a sphere, yeah, then we get this equation. We have the equation, therefore sphere.
Right, because if you're going to word it that way, then we're going to go back to our original question that we're going to have for you. When did you validate this calculation or this radius value?
Radius, yeah, yep.
It's validated through testing.
Great.
That'd be circular reasoning again. Right, to use the result in order to confirm your if is circular reasoning, unless you know that your P is true in the first instance, and then it's valid. Then it's a valid modus ponens.
You keep trying to run away from that part. It should be very easy if you got a measurement of curvature, or you can validate it in any way. It's just basically you identifying it to be true.
Also, the reason why it's not sound logic that because first of all, you're using logical fallacies, but your way of thinking about it could be attributed to something that would be in optics rather than actual Earth curve. So you need to be able to attribute every single thing that is, because the only way that you're able to do this is with optics. So that should be a factor. Don't you agree?
The only way you're able to do this is with optics, so it should be a factor.
Right, with the surveying. Isn't that what you guys are still talking about?
Yes.
Yeah, they use line of sight measurements, right?
Yes.
Okay. Right. So you're using optics to get these measurements. So don't you think that it's wise to make sure that those optics are accounted for? This is why what you're saying can be attributed to something, let's say, like the Rayleigh criterion of optics with the angular resolution and the angle of incidence. Like those things, actually, that's what your supposed Earth curve is anyways. It matches perfectly, and it's not accounted for when you're talking about optics and using line of sight measurements.
So is are you wagering that these surveyors who are succeeding in their projects are not taking into account?
That's just your claim that they're succeeding.
They're
using flat Earth measurements. I don't understand
you
that.
You still haven't provided any documentation or any form of publication which is showing that they did succeed. Why don't you start there?
Wait, I need to prove to you that I need to prove to you first that civil engineers are successful in their
that these actions were performed. Yes, like show something that would lend credence to this story you're telling us.
Yeah, they measure curvature. That should be pretty easy.
What if I show you a structure that was built that's 4 kilometers long?
Oh my fucking God.
It's designed to be perfectly flat for a scientific experiment that's taking place that requires it to be flat. And in the construction of this structure, the surveyors did apply this.
So pretty much everything was shown.
With that, right? Show us the documentation detailing what you originally fucking stated.
Or it's just a basis assertion at this point. Yeah, you saying, "Oh, well, I'm gonna show you something else besides what you're supposed to be claiming, which should be your main premise."
So do I get it right that you doubt that this happens and exists?
No, we want you to show us.
Okay, if you don't doubt it, then what's the purpose of me having to do that homework for you? If it's not in doubt, then what's the purpose of this inquiry?
Well, how do you know about it? Did you just hear about it on the grapevine, standing at the fucking water cooler at work, or what? Source.
I mean, you're getting really upset.
Hide your sources, dude.
Hey, what's with this whining type of talking you're doing to me, mate? Like, hey, just relax. I'm asking you a question. if it's in doubt, then it's worth us doing some research.
Provide your sources.
I'm asking
for
you
this information that you have obviously gained from somewhere. We're interested in where it came from.
And antagonistically demanding this of me. Is it
because you're being a little bitch?
Oh, okay. So, all right. Always nice talking to the flat earthers. They get triggered. Everything they don't like is fake.
Poison in the well. Here we go.
And then they
as always. Here it comes.
Yeah. Moon landing was fake. You're correct. ISS is fake. All that shit's fake. You're right.
There we go. We got it.
Yep.
So when they're blown out with
like
an argument,
Glovers always do. Whenever we ask them about curvature, this is what happens.
Well, I mean, they get upset.
What happens.
They start yelling at you and calling you a bitch, and then they call things into question that are not in question.
Even though
everything I don't like is fake. Everything
we ask him to provide evidence, and here he go.
Well, I mean, you could ask.
All we ask you to do is just.
You could also give me a reason why you're asking. I think that's fair.
I mean, the only thing we ask you to do is
because we want to analyze the authenticity and veracity of the information that you're supplying. We want to know where it came from and who's claiming to have done all this shit. Maybe we might want to go out and do the same thing ourselves so that we can then know too. Like you seem to know all about it.
So you just don't know about civil engineering.
You making a claim about it, so you don't want to present it.
Yeah, I think you're playing ignorant as a form of coping and dodging.
No, we just playing.
That's what I'm suspecting. I'm suspecting that what you're doing is leading me with a red herring of like, oh, prove it to me, big tick. Oh, I don't believe you. And I think we all know that it's true.
So you want us to just trust me, bro, because you say it so, or whatever? That's what you want.
Well, just it's. I'm literally asking you.
I mean, you're the one that brought it up.
True. You won't bite the bullet and say, yes, I doubt that that's true. Nobody's saying that to me, and I keep asking.
We don't know anything is your claim.
Oh, we don't know anything is your claim. That's what you're saying? We don't know anything?
Yeah, we don't know what you're talking about.
So I'm talking to people who don't know anything. It's a little difficult.
We don't know what you're talking about. It's very specific.
But do you doubt that civil engineers are practicing this and having success, yes or no?
Yes, because you won't share where you got the information
from. So yes, you doubt it.
I doubt you. Your knowledge on this.
I'm really trying to figure out what are you saying engineers is doing? Are you talking about engineers or surveyors?
It's surveying for engineering. The engineers are doing giant projects that require level and distance.
You said it.
And the surveyors are serving this need.
Level. Yep. They just need a level. They use a theodolite. Shoot a level line, boom. Not a curved line. You got it.
Wrong. In fact,
that's what
do you know what level means to a surveyor? Do you want the definition? Because I got it.
Not a curved line.
You know what level mean, period?
It literally is a curved line, and if you don't mind, I'll read the definition to you right from this book.
Okay, so where do they measure this curved line?
In terms of level line and horizontal line.
Where did they measure the curved line?
I'm going to tell you right now.
No, you reading
these words are frequently used in leveling,
sir,
and they need to be carefully defined.
Definition. Where do they measure this curved line?
Sir, I'm trying to share with you the definition.
Right. No. We already know what you're about to say. We already know that you're going to say level means curve. You know we disagree with that.
Why would I say that?
We don't have to have an argument.
Why would I say that? Why would I say that?
You know we disagree with that. Because
you disagree with the surveyors who are doing these projects for engineers.
Okay, I disagree with you, sir. You haven't shown. Great. You haven't shown this curvature yet. You haven't shown this radius value yet. I'm trying to get you to show it. You rather just read what people say.
I'm trying to define the words that we're using so we can have.
Great. Go ahead and define it, but you will have to validate it by showing it, right?
Wouldn't that be optics?
Oh, it would be optics. So no Earth curve then.
Oh, so are you setting up a impossible scenario? Since optics are no Earth question, curve then, right? And then you asked me to show you something, and then we're going to say that it's an optical.
Yes, Earth curve is impossible. It's an impossible scenario. That's correct.
I don't know why you keep trying to use that tactic. The burden is upon you.
Fallacy.
There's no impossible. There is no impossible measure here. All you have to do is just validate a claim. Simple. If you claiming that level means, if you're claiming that level, right? And this example that you about to give us is actually the surface curving based upon whatever you want to say. You can't say, oh, we're optics all of a sudden, because that means there's no physical Earth curve then. Still not showing it.
I mean, we called into question the word level, and I'm trying to define the word.
I haven't called it in question. That you just brought that up.
I said we.
Yeah. So I gave you that. So now you would have to show it, right?
Show it?
Yeah.
You like
you
a
said
picture?
You already agreed with me.
You want me to show you a picture of a definition?
No.
That
It's not a definition. We moving past that point. I'm gonna give you your little definition in your little fantasy world, right?
How would you like me to show it?
I'm gonna give you your little definition.
You already agreed to level being horizontal.
Right.
That's correct. You already said it was horizontal.
And what does horizontal mean?
Not. There's no horizontals on a ball.
What is horizontal?
No slope.
Mean?
Zero slope.
That's not what horizontal means.
Straight line, perpendicular to vertical, no slope.
Right. Horizontal is not a straight line. Then.
What does vertical mean?
So vertical wouldn't be
perpendicular to horizontal.
And that ain't gonna measure.
Oh, right. Now we're into circular definitions.
Are we?
If horizontal is perpendicular to vertical,
it's kind of funny that we answering the question.
Sorry, I forgot for a second. Horizontal, parallel to the plane of the horizon. That's also a definition you can use. And vertical at right angles to horizontal, which is parallel to the plane of horizon.
And there's no parallels.
It's kind of funny we answering these questions like,
wait a minute,
very easily.
Use the
giving
word.
him answers and he don't like them.
Use the same word.
We giving him answers and he don't like them. But yet when we ask him to show us this curvature, he's
you
not
said
doing
horizontal is perpendicular to horizon, which is the same word.
Those are different words, dude.
Horizon and horizontal.
You think that they're the same word? You think horizon and horizontal are interchangeable synonyms? People just use them interchangeably.
It's
like I'm going to draw.
It's a different form. That's like saying flat is parallel to flatness.
That's literally the definition of horizontal, dude. Parallel to plane of horizon.
Well, let me offer you another one. This actually comes from the directives given to the surveyors who are trying to
parallels on a ball, dude.
I mean, you can keep saying.
Wait, is he actually going to provide something from somewhere?
I keep trying
a source,
and I keep
amazing.
Interrupted. I mean, I've spoken over every time that I try to offer to you.
Well, it's kind of funny that you're not being. It's kind of funny.
It's almost like you don't want to hear the answer. That's going to destroy you.
It's kind of funny that you're
almost like you're coping and running from the truth.
It's kind of funny that nobody's coping.
Everybody's going to keep on speaking so that I can't say the definition.
Yeah. No, we only speak whenever we ask you a question to basically show us this Earth curve.
Post it in the chat. Sure, I'll do that. Can I also say it so that everybody can hear it?
Yes, you can also speak it out.
Okay with that?
It's taking so long.
Anybody object to me giving this definition?
We don't got to be angry with this guy. We don't got to be angry.
I'm not angry. I want to be able to read along.
All right. You want it in the side chat, right? In the VC chat, it's right there.
Yeah,
so the YouTube viewers can see it too.
Great. Do you see the image that I've posted of the definition? Everything's highlighted.
I thought you said you was going to read it.
Tell me when, because I've been trying to this whole time. I keep getting shut down. Just give me permission.
Okay, go ahead. I already basically.
The past couple of days, I've already debunked gravity, so we can get rid of your definition since it requires gravity now.
You don't believe in little g gravity?
Great. He's changing it already. So you're not going to read it then, right?
I'm waiting for permission.
Why do you need permission, moron?
Because excuse me, sir, we don't need to result to
you're demonstrating that you're a moron right now. How many people told you to go ahead and read it?
Well, and then everyone keeps speaking over me, so I want to have the floor.
No, because you're doing everything but reading it.
Okay, now I'm going to read it. Please don't interrupt.
Stop it. Just read it.
A horizontal line is one which is normal to the direction of little g gravity, the vertical, at the particular point, such as P in the figure that I've showed you, a horizontal line or surface are therefore tangential to the level lines or surfaces at individual points.
Okay. So what's the tangent? What's the tangent line?
So then there's easily should be easy to show that there's a tangent point, right?
Right.
That would be the intersection of the observer's line of sight with the surface of the Earth, that so-called level line, which is actually curved.
And that tangent line.
So that'd be the horizon. That'd be the geometric horizon. So all we have to do is post the black swan. That's easy.
And that tangent line is horizontal, right?
Horizontal to that point.
Horizontal to the point where
there is no such point.
Right, the horizontal to the point where the Earth is where the surface is supposed to be curving, correct?
The point where you're measuring vertical with gravity.
Where the surface is
the
supposed
plumb
to
line
be
at
curving.
the point. If you put a plumb line at a point, you take it perpendicular to that plumb line. Now you have a horizontal.
But it is a line.
With that
it's
point.
not a point.
You
It's
are
a
creating
line.
right. You are creating a line.
It says right
of
here in your
reference.
definition, it's a line. Now, we
Right
could
there
go
in
ahead
my
and get
definition at the top.
You could go ahead and get the definition of a tangent line.
I'm
if you want
defining the
to.
terms level line and horizontal line.
Yeah, horizontal line is still a straight line, even in the example that you're talking about, sir.
Yeah, horizontal.
Right.
They're saying
And
the horizontal is your
It
straight
do you-
flat
do you
line.
see
the
the second red box
Let me
is
talk
because
now.
the
Let me
Earth is
talk now.
curved.
Stop. It seems like you interrupted me now. Let me talk now.
Stop me before I answer.
No, you
Go ahead,
interrupted me now.
Stop me before I answer you.
No, because I'm about to answer you. It's my turn to talk. Yes, even in the example and even in the definition that you showing us, that horizontal line is still the straight line. They call it a tangent line because at that point you still have that horizontal line. There's just something dangling beneath it, which is supposed to be curve or a circle. So that point, right, still has a horizontal line where you actually getting that measurement from. Now, you have the burden to prove that that very thing that you explaining to us right now, which will be a curved surface or a curved line, we already established that you can't get measurements with curved lines. You guys need tangents. So, still need a horizontal. Now you have to provide evidence that you have a surface or a radius value, which will be curved, right? Which will be a curved surface where the tangent line is actually needed. Or else the tangent line is not actually needed and it's running parallel to that surface in order for you to get ground positions. So it's either one, that horizontal line is running parallel to its surface. You're looking at the line of sight is that vertical line of sight line is actually intersecting with the horizontal line, which you guys are calling tangents. Or it is actually a tangent and you could show us that the Earth is actually curving. Now, go back to back to what you're supposed to be explaining, the burden
I'm
that you
politely
actually
waiting for
have.
when it's my time to.
Yes. Not yet. Now, back to what you supposed to be explaining. I gave you your little definition. Now you have to demonstrate the Earth surface actually having a radius value. Can't just say we just going to calculate it, because you just said that based upon this definition, you guys are actually taking measurements of Earth curve. Show us it.
Show us that deviation of the surface away from that horizontal that's being established.
Here it is. The horizontal line is the one that's being measured through the optics of the theodolite. That's true. It is a tangent, a perpendicular tangent off of the vertical of the point of the theodolite. That's the horizontal line. However, the surveyors are achieving level, which is different than horizontal. Level, as defined in this manual for the surveyors, is a line along which all points are the same height or altitude. Because the Earth is curved, level lines are also curved. So we're establishing horizontals, taking optical measurements with horizontal lines, and then applying the radius value curve correction formula to create level from horizontal.
You wouldn't need to.
You wouldn't need to if the Earth was flat.
Magical nonsense.
You wouldn't
need to if the Earth was flat. But since you do need to, the Earth is not flat.
Dude, you wouldn't need to correct anything. You'd just simply measure the curvature. You'd be measuring that the Earth's surface is deviating away at a curving rate away from that horizontal reference.
Yeah. And you actually getting your GP or your geographical positions on that tangent line.
So my point is that you wouldn't need to apply the curve.
The only one. So again, sir, only that tangent line. So again, only the tangent line is where you're getting these geographical positions or the ground position, right? Being connected from that vertical line, and your so-called level line is just based upon the calculation that you refuse to explain, or you refuse to give us a natural observation for, or even a measurement for. Right now, you're just telling us, oh, well, we actually need this tangent horizontal straight line in order for us to get ground positions for. But we do have a dangling Earth surface there. We call it a level line. Great, but you're still actually getting the measurements on the horizontal line, which is supposed to be perpendicular to the Earth's surface. And your corrections is based upon...
That's exactly my point.
Your correction is based upon a radius value that you refuse to validate.
It's validated through the test.
Right, so affirming the consequence again, right? Circular reasoning.
If I aim the gun the right way and I hit the target, then the gun was aimed.
Circular reasoning in logical fallacy.
Did you just try the Texas sharpshooter fallacy again? Well, wow. I don't mean again. You know what the Texas sharpshooter fallacy is?
No.
You shoot your gun, and then you draw the bullseye around where the bullets are the closest together. Right, so you shoot the gun at the side of a barn, and wherever the bullets holes are closest together, that's where you draw your bullseye.
In the formula 4 + x = 6, what is x?
Who cares? Is this a math test?
Somebody's got to be able to figure that one out.
Yeah, I'll ask ChatGPT. Can we stay on topic?
4 + x = 6. What is x?
Who cares?
I do. That's what I'm asking.
Is it relevant to this?
Yes.
Actually, it'd be 10. You do it in your head.
10?
4 + 6 = x. X would be 10.
No, the question is 4 + x = 6. What is
2?
X? Thank you. Can it be anything other than 2?
No, but that's mathematics.
Right. Mathematics. Kind of rigid.
Yeah, it is. But we're not dealing with straight arithmetic.
So we can prove what x is. Can we not?
Yeah, given axioms, right? So we start a mathematical system with some given axioms. So we could make mathematical systems where, that's not true. And we could do operations based upon that not being true. And deductively, right? I'll give you an example. Okay, this is the best way to do it. But I'm gonna use logic. Now, for a conclusion to be true, it has to have 2 true premises, right? So I could say Aristotle's all men are immortal. Aristotle's a man, therefore Aristotle is immortal. That would actually be a deductively true statement, but it's not true in reality. So you can make deductively true statements with mathematics that are not true in reality.
We started with a false premise there that all men are immortal, right?
Yeah, exactly. It's not a true premise.
But my premise is that is a true premise, which is that these civil engineers that are leveling the ground, they are coming up with level surfaces.
Well, I mean, technically, the level line, right, is only level at the point of the measurement. That's what it says in surveying. It's only valid at the point of the instrument.
Right.
Yeah, and nowhere else. Can't extrapolate it out.
So when they want to make something that's perfectly flat and they factor in an R value in their calculation to do that, that proves the R value was correct. If it ends up being, if they end up with a true flat surface and they factored in the radius, then the radius factor was correct.
I mean, what flat surface are we talking about?
Okay, if you want me to prove one, I can do that.
No, I'm asking you. Well, first of all, you couldn't possibly prove it because they'd be using spherical geometry, and straight lines can't even be expressed. So I don't even know how that would even work.
Well, then it's of no use to ask me for an example. Then,
because spherical geometry is non-Euclidean, so like straight lines can't be expressed because one of the axioms is that there's no straight lines. So saying, hey, there's something straight or flat in spherical geometry, it's nonsensical. It's incoherent.
Well, I'm talking about Euclidean geometry. I'm talking about flat. If you want to make a flat surface over a curved level surface, right?
I mean,
so if
the way human beings make a flat surface in reality is we use a level, right?
Well, I mean, what kind of level? A spirit level?
Yeah, they make all different sizes. We would use that, or we would do leapfrog trigonometric height. We would do leapfrog trigonometric heighting, which is a surveying technique where you just leapfrog over heights.
But even a spirit level, it relies on a curved piece of glass.
What does that matter? Not necessarily, because some theodolites. Well, I mean, spirit levels, yes, they use the curved piece of glass, and they used to use mineral spirits, but it's a different type of fluid now. But so check this out. As you know, there's different size spirit levels, right? There's little torpedo levels, the 6-inch levels, 24-inch levels, 4-foot levels, 10-foot levels. But you can use each one of these, right? And they're all not going to indicate the same level. Now, the idea that you can take a theodolite and like level out to fucking a mile or 2 miles or 10 miles with a little bubble level inside your theodolite is absurd on its face. That's why they say in surveying, the level, it's only level at the point of the instrument. They say this in the field itself.
Right. Well, no, the horizontal.
That horizontal level line.
Wait, you're conflating horizontal and level.
That runs through the theodolite. It's 90 degrees from plumb, but they also say plumb line's curved, so plumb isn't even perpendicular to the surface of the Earth. So what are we even talking about?
Who says plumb line is curved?
Geodetic surveying.
Oh, I'm not familiar with that.
Oh yeah.
Are you familiar with the Laser Interferometer Gravitational Wave Observatory called
LIGO? Yes.
Interferometry. Interferometer.
Right. Right. Should they shoot lasers and they test the interference patterns in the lasers, and they're looking for gravitational waves. And what I found is
I'm familiar with it. I'm very familiar with it.
Okay, cool. So then you're probably familiar.
I'm more familiar with it than you are.
So you're familiar with it.
I'm not trying to brag. I'm just saying I'm very, very familiar with it. I know exactly what they did. I know exactly your technique. I know how many times they had to survey the frickin' place. I know what the addendum frickin' documents say. After the fact, after they surveyed it and everything was fucking wrong, they had to go back after they hired 2 more fucking survey people, and then they issued another fucking addendum document, right, where they had somebody review all this shit. Yeah, so the surveying.
Are you talking about the construction?
The construction of the LIGO was problematic, to say the least. And I also have the civil surveying diagrams, the ones that are filed with I don't know if it's a township or a municipality, wherever they have civil engineering diagrams. It actually shows that it's concave, which is crazy.
It's concave?
Concave, yeah.
The tunnel that they shoot that laser down?
Yeah, so they have their elevations, right? They have the civil engineering is like the blueprint, right? So the blueprint it's on a piece of paper, right? So the lines going across the piece of paper are just like in Cartesian coordinates, and it has the distances and the heights above sea level. And then if you follow the profile of the LIGO instrument, it dips down and then dips back up. So it's actually concave. I could show it to you if I could find it. Hold on a second.
Yeah, I'd like to see that.
They had all sorts of problems surveying that shit. I think they ended up using like a custom geoid or something. They did the same thing at CERN. They also did the same thing at the Proton Accelerator in Japan. So, with all due respect, right? So, this isn't like the first time many of us have heard this. Like, we've been hearing about LIGO and fucking neutrinos and everything going back 5-6 years. So we're well familiar. I mean, some of us haven't been around as long as others. But this is something that was brought up a lot in the past.
So if I understand right, so I'm under the impression that being that they needed a flat level surface for 4 kilometers in the construction of that
within a tolerance.
Vacuum tube. Yeah, because there's like almost like a meter of deviation, supposedly because of the Earth's curve, right? That they had to accommodate for.
No, they have a tolerance where the beam has to be so far away from the sides of the instrument, the sides of the vacuum tube.
Right.
Hold on, when I find the document.
They also had to hit the reflecting surface at the end, and it had to be at the correct height, 4 kilometers away. So the construction of this vacuum tube tunnel had to be straight, not swirly, curvy, and also at the right elevation at the end. But it turns out that the elevation at the one end is a meter higher than the elevation at the start.
Yeah, and the elevation in the center is lower than the end. So, I mean, what are you telling me?
Yeah, I haven't come across that. That's interesting. Yeah, if you could show me that.
I have to find it. I got a lot of shit on freaking LIGO. Because people bring it up for all different reasons, right? Say, gravity waves, true gravity, and all that shit, right? So that's one thing that people bring up. And then there's the survey. Then there's the instrument itself. God damn it, I got a lot of shit on this. Then there's the instrument itself, like how it was surveyed. So I got stuff on that. So it's a bitch to find. So give me a second. I mean, you can keep talking. This is going to take a minute. I have to go through like shitloads of stuff.
All right. Well, hey, if I can find out from you that surveyors don't know what they're doing and their shit's all whack, that would be news to me. That their science is just garbage.
Why do you have to bracket and don't know what they're doing?
Yeah, who said that?
Yeah, the doctors know what they're doing. We call medicine an art. Okay, so things are more of an art than a science, right? So we have science, which is an idealized way we think the world works, but when we go out into the world, it don't work that way, right? So we have to fudge shit to get it to work, get it to match reality. We do this all the time. I don't know why this is like mysterious. Like we do this all the time. It's literally called engineering.
It's good hearing you in here, Indio.
Hi, Flatsy. How are you?
Good. How are you doing? You have good time with family?
Oh yeah.
Good.
I'm a granddaddy, so I got to see my grandson.
All right. Yeah, we got to see a lot of
he's like
our
9
friends
months
and
or
loved ones.
something.
Awesome.
Let's say it again.
We got to see a lot of our friends and family and loved ones and all that. That really covers it. We got to see a lot of loved ones. Not everybody, but a good portion of it. So the kids had a good time.
Darn it.
I don't mean. Well, I guess it is. I guess while we're pulling that up, could we entertain the idea? Like, I'm interested. What's like? I'm of the understanding. You can set me wrong. Are we back to the drawing board on like some sort of model or representation for where the sun is and what it's doing after the Antarctica thing?
How do you think the globe does it? Can I ask you that? You think they take a 3D globe and then they model it all out like that?
I don't understand the question really.
How do you think where the sun position is? Say what sunrise time is, solar noon, sunrise, sunset, where it is, the angle, the azimuth and elevation angle, right? How do you think that gets predicted now? Like if you go on Time and Date or SunCalc or the U.S. Naval Observatory, and you get sunrise, sunset time. How do you think what model do they use to give you that information?
I see. Like I think you might think I'm asking you a different question. So my question is more like, what do you think's going on? I don't mean like model that you're going to use to predict time and stuff. I'm just saying like one explanation. I mean, it used to be, as far as I understand it, is that there's no 24-hour sun in Antarctica because that wouldn't work on our concept of what the flat Earth is.
Well, I mean,
do we have a new concept that we're working on, or?
So the thing with the 24-hour sun, everyone conceded that there was 24 hours a day. Like the problem with 24-hour sun is we had 5 cooked videos, and what are we supposed to go by? And you had testimonies of like Amundsen, so he wrote in his notebooks the entire time he was stranded there that he didn't see the sun the entire time except for one day. Yeah, so that's what Amundsen wrote in his notebooks. He wrote that his whole crew was going fucking crazy because it was daylight all the time, but they never saw the sun except for one single day. And when the sun came out, everybody cheered, and it's like they had a party. That's what he wrote in like his logs of his experience there. So what are we supposed to say? We're supposed to just go, oh yeah, there's a 24-hour sun because what?
Okay, well that's fair. If you were just like doubting, right. So we lacked information, but what I also have heard for a long time is that that there can't be a 24-hour sun down there because of our concept of what the sun's doing. And I've heard people saying, yeah, if it turned out that there was a 24-hour sun, that'd be a big problem for us.
I don't think it's a problem.
So that's what I'm asking. It's like
because whatever the sun is in relation to the Earth is an inference, right? And whatever you make of it, it's going to be theory laden, right? It's going to be laden with theories about what the sun is relative to the Earth, how the light rays reach you, yada yada yada. It's laden with theory, so it's really not a problem. It's not a problem at all.
What about over there versus under? You said under the sun under. What if the sun's not under, and that's our whole point, and it's not under anything at all? It's over that way for whatever time. Yeah.
Yeah, so theory, right? So the globe theory is like, all right, the globe theory goes like, well, this is why we can see the 24-hour sun in Antarctica. And then I'm like, well, what's your theory why you can see it?
Yeah, that's the funny thing is that's why I brought this up is because they don't use the globe model to even predict it if that happens.
Exactly.
They use something called the equation of time, and it's referential only to the sky. It has nothing to do. It's observer dependent, meaning you could be on the back of a fucking, a rabbit. It doesn't matter what you're on because it's completely from the view of the observer. Wherever the celestial equator is, if you know the time of the year, you know the time of day, you can predict where the sun's going to be relative to the celestial equator. Has nothing. You could be on top of anything. Doesn't matter what you're on.
No, but I'm not asking about like the time. I'm saying just like why.
Well, you said the globe has an explanation, dude. You don't have any then why don't you predict where the sun is? Why don't you use that to predict the sun?
No,
then why don't you use that to predict the sun location?
Hold on. I'm saying it has an explanation for why you're able to see the sun over your head for 24 hours.
Yeah, but it's okay.
Well, so what's your explanation?
The story is that Listen. First of all, I don't care about abductive logic. So abductive logic is for freaking midwits, dude. Like seriously, that's how I feel.
So
abductive logic, the best explanation based upon the evidence we have. That's more of a statement about human psychology than it is truth, right? So, what's your explanation? What good is an explanation if your explanation is non-scientific?
So, explanation.
Do you think that? Well, I mean, I could make some shit up. Would you be happy with that? Have you seen the physical demonstration of somebody doing it? Have you seen that? I'm sure you've seen frickin' Sacred post it.
Posting what?
Someone took a light in like a glass, I think it was a half silver mirror or something, and
oh yeah. Super fluid in the ceiling.
No, he didn't use super fluid in the ceiling. He used like a glass, or I don't know if it was a mirrored dome or a semi-mirrored dome.
Right. I heard him say that represents potentially some super fluid up in the top of the dome.
Well, I mean, I don't know. I mean, would that make you happy if we said super fluid? I mean,
no, that's just what he said.
I don't know what his thing is. The point is that they've demonstrated this in a physical demonstration. Now we could say, "Oh, look, dude, it matches like the observation, so this must be physically real," but that would be based with bullshit, right? And it's the same thing of saying, "Yes, the globe must be physically real because it matches some explanation that the globe gets." The point is, though, is that you have an explanation, but it's not a scientific explanation because you don't even use it, the so-called explanation, to model where the sun is in the first place.
No, I totally agree with you that it doesn't prove the globe.
Do you understand what I'm saying? You have the model you use is not a globe model.
The model we use is not a globe model.
Did you not hear the whole thing about the equation of time that I just told you? It's observer dependent.
Yeah, but because you're pivoting to the category of time prediction.
No, azimuth and elevation angle of the sun. The azimuth is the direction the sun would be relative to you, and how that in the elevation angle, the elevation would be how high it is above the horizon.
And we can't determine that using the globe?
I mean, maybe you can, but the way you do it now, by type, like I said, how did MC Toon or frickin' Duffy or any of how did they figure out that the sun was supposed to be up 24 hours a day and what angle it was supposed to be above the horizon? They went to time and date and they typed in the location. But time and date uses this thing called the equation of time. In the mathematics, if you look at them, there's no globe in those.
But isn't that just for convenience?
Yeah. What do you mean for convenience? It's not because it's the spatial reference is the celestial sphere. It is only relative to the celestial sphere, where you are relative to the celestial equator. Where's the celestial equator in the sky? That's it. That's all of it.
Right, but that's the celestial sphere.
So you think you're trying to take the celestial sphere and turn it into a physical ground sphere?
No, I'm not saying it proves the physical ground. No, I'm not saying that. But I'm saying we do call it a sphere because that's the way it appears.
And to a degree,
it appears.
If you cherry pick and you ignore things.
But my question is, like, I've been interacting with flat earthers and I ask them a thing like, well, where does the sun go at night? And they say it goes away. And I go, away where?
Yeah.
And it goes away in a circle like a clock around in the sky. And then I go, okay,
well, I mean,
is there a 24-hour sun in Antarctica? And they go, no, it can't be.
I get it, dude. Okay. Sun doesn't have a true spatial position. And you're not going to like this. Okay. But you have to like it because it's part of the globe model. So if you look at the sun, right? Say it's say you're in New York City, right? And it's frickin' noon. If you look at the sun, and then somebody's on the Mississippi River, and they look at the sun, and somebody's in Florida, and they look at the sun, and you're all looking at the sun at the same time. If we drew lines of sight intersecting your lines of sight, they would not intersect the sun. You would all see the sun in a in a spatial position that's not common to all of you. And this has literally been demonstrated over and over again, and it's part of the globe model. So when you say, where's the sun? Okay. Yeah, it depends on where you're at. The sun has where it appears to be. You see an apparent sun, but you don't see, like, it's not an object like that, right? It's not like looking at a building that's 20 miles away. Everybody's looking at the building. Sun isn't like that. And you can take the same time and date, right? And if you take time and date, and people have done this, they've done it in AutoCAD, they've done it in Blender. You take the same time, right? Same time of day. You map onto a globe the azimuth and elevation angles, and you try to intersect them, the lines of sight, right? Based upon the azimuth and elevation angles. I see the sun here. This guy's angle to the sun is there. This person's angle to the sun is there. Where do those intersect somewhere in space? They don't. And the more pieces you add, the more observers you add, the worse it gets. Now, this is why they say this. When you said, hey, it looks like a celestial sphere, that's why I said, yeah, kind of, but not really. They only do observations of the sky where it follows this celestial sphere is from 30 degrees below to the horizon. They won't do any measurements. So for celestial navigation, for astronomy, for anything, because things are displaced relative to the so-called celestial sphere. Above that, up to 80 or 70 degrees, from 70 to 90, they won't do any observations either. So it's really just like a ring in the sky. If you want to keep for real, I'm talking about practical use. I'm not talking about theoretical. I'm talking about when people go out, astronomers, navigators, when they go out and they actually do an observation, they don't do any observations below 30 degrees, and they don't do any above 70 degrees. When I say 70, from 70 to zenith, right? And the reason is because they can't get accurate measurements. There's problems. So when people say celestial sphere, in practical terms, it's really just a ring of the sky, where this so-called linear relationship to the surface of the Earth, this distance linear relationship with angles applies. But I don't even know if that's true, because I've never actually seen any verification of that. But that's a long way of saying that everything in the sky has an apparent position, including the sun. When we say the sun goes away, that just means, yes, from your viewpoint, you see the sun move away. And then there's somebody else west of you where they can see the sun and it has a position. But someone's west of you and you see the sun and they see the sun and you try to intersect the lines of sight, you're not looking at the same place. And I know I bet you that's very hard to accept. But if I told you, you're not looking at the sun because light takes 8 minutes to get here, you'd be like, no problem. And if I told you, well, when you see the sunset, it's actually being refracted up over the horizon and the sun's already under the horizon, but you see it, you'd have no problem with that. You have no problem. I mean, maybe I don't know you good enough to. I'm just saying, Globers, if a flat earther says, yes, there's an apparent sun, that's a bunch of flat earth bullshit. But when we tell them about their apparent sun, all of a sudden there's no problem. The sun's in apparent position, dude. It's not in a true position. It's apparent. So when you say, where does the sun go? It moves away from your viewpoint, but it's not like it's a physical object like a bowling ball rolling away.
What is it?
Fuck if I know. That's debatable,
$1 million question.
Got it.
I mean, there's one theory is that it's metallic fucking hydrogen. That was the prevailing theory, is that the sun was condensed matter. That was the prevailing theory until to the end of the 1800s.
Mm.
So
I'm weird about the sun. Oh, sorry, my bad.
Yeah, I was going to follow up with a question though about the Antarctica thing. Like, so my understanding is that basically, like when it was noon in Australia, they still had the sun overhead, apparent sun overhead in Antarctica, which was basically the south tip of South America, on the opposite side of the flat Earth. So, what's our? Have we made any ground toward explaining that?
I mean, we could just say the sun rays freaking reflected off the dome and bent around shit. I mean, we could make some shit up. Would that make you feel better?
Yeah. I mean, but
what it could is and we could affirm the consequence, right?
Start trying.
We could say the sunlight reflects off the dome to the other side of the flat Earth, and we'll see a 24-hour sun. We see a 24-hour sun, therefore the sun reflects off the dome, and it's a flat Earth. We could just do the same stuff you do. We could affirm the consequent, make all sorts of silly statements, but I hate to say this, we're not like you guys. We don't affirm the consequent. You know what affirm the consequent is, right?
Yeah,
P, then Q, therefore P.
Yep.
So,
we were deep in that
so I mean,
right.
Yeah, so I mean, that's the problem with induction.
You know what?
Is that any inductive statement, period, any statement that uses inductive logic affirms the consequent.
Well, then why do you say the Earth's flat? Then why do you say the Earth's flat?
Because we can measure it directly. We don't have to use induction. We can use deduction. Because we can directly compare it to things.
Physical, empirical, touchable, tangible.
Like
not just math.
Such as?
No, so listen, okay. You look at the sun, you draw conclusions about things that are not the sun. Those conclusions have to be an inference because it is indirect, right? Look at the sun, draw conclusions about the Earth. It's like trying to figure out what your house is built out of because you can see through the peephole door and you can see what all the other houses in your neighborhood are built out of, right? And going, they're all brick, so maybe I live in a brick house, right? You see what I'm saying?
Yeah. But what about yours? Like, so what's different about your claim? How do you prove that the Earth's flat?
It's the only one like it.
Directly.
Can you show it to me? How do you prove it?
Directly. You have to directly measure it.
And who did that?
Dude, like, I mean,
every surveyor ever.
Fucking laser tests.
Every person ever who ever measures the Earth measures it on a horizontal.
Yeah, there's up to, like, I mean, I don't know how many you need, right? So there's over land, over water, microwave, radio waves, like so you name it. There's all sorts of.
So how does the argument go with the laser test? If laser does this, then Earth is flat. And then it does it.
No. You measure the distance between the laser and the surface of the Earth, and if it doesn't. And if it's in parallel, to a degree, obviously it's not going to be perfectly parallel because, we don't have infinite measurement precision, right? To within a degree, right? So within some degree of certainty, you can say, hey, the laser does not deviate from the surface of the Earth at a rate of curvature as predicted, right?
Therefore,
it can't be curving at the rate as predicted, right?
Isn't that?
But there's a whole bunch of other consequences that are necessary consequences to that. Because if it isn't curving,
did you do the same thing?
No, it's not. Because you're doing a direct comparison of one thing to another. We're comparing the laser with the Earth, and then we're measuring the distance between them.
And
right, so we're doing a direct comparison. It's not. We don't have to go. We don't have to go like.
Do lasers always shoot straight?
Generally, yes. I mean, there's certain conditions where you can make it not shoot straight.
Such as when they.
I mean, you can shine it through freaking glass or water or sugar water, or you can fucking shine it through CO2, butane,
or through what about atmospheric layers?
Yeah, but you can control for that. So you can measure the weather, and you can do other things, right? So you can measure varying distances, right? You do more than one measurement, and then you go repeat the measurement, right? So the chances of you going on 2 different days, like say you randomly pick 2 days, like 3 weeks apart.
Can you show me some of these
and the weather conditions? And the weather conditions are identical to get the exact same experimental result of refraction, right? This is the refraction beam. But the thing is, there's no basis for refracted laser beams anyway, in normal conditions, and that has been experimentally verified.
Can you show me some of this?
Yeah. Hold on. I couldn't find that fucking Lego thing. I know where it's posted, but it'll take me forever to find it.
Because that sounds like if P then Q, Q then P.
No. We're just doing a direct comparison. It's more like if A equals B and B equals C, then A also equals C.
I wish you were here earlier because that's exactly the formula I set up, and they called it A affirming the consequent over and over.
No, that would be an identity.
No, you didn't. What he's explaining is the Moelis tolerance. I don't know why you're trying to compare its difference. He's measuring the Earth directly. You coming up with a calculation without validating it to be true first.
Moelis tolerance?
Here's one, man.
What's Moelis tolerance?
It's a form of a deductive argument.
You got to study these arguments, bro.
I just don't know if I heard the words right. Moelis tolerance?
Modus tollens.
Yeah, Modus tollens. Yep.
Yeah, but it's not the same thing. If P, then Q. If not Q, then not P.
Right. When it's indirect. So if it's indirect or it's not validated, then you using something that is not indirect. In your example, you was begging the question actually. So it's actually you was begging the question fallacy, and you was trying to confirm it due to an observation for it to be true, which was indirect to the point because you haven't actually validated your premise to be true in the first place. So it was circular reasoning which you was using. And his point that he's using, he's actually coming up with a test based upon something that is directly to his premise. So he's not assuming that his premise is true. He's actually trying to test it directly, where he's forming a modus tollens, or modus, whatever you want to call it. So basically he's testing it without assumptions at all. It's not like, well, this is my base premise and I'm assuming that it's all really true, or it's a calculation I haven't validated. He's actually validating it through direct measurements with a laser test, where you just using the calculations and then you saying, well, if the calculation work, then therefore it is true. So that's the difference between a modus tollens and begging the question or affirming the consequence fallacy. Your argument, or if you want to say if somebody else's argument is indirect and his is direct.
So I posted 2 laser tests. These are like 30 miles. And so they're multiple tests. It's not like they just went out once, shined a laser, and was like, hey, look, victory. No, multiple tests. So the one that was done at Lake Esalis's greatest laser experiment, that's 5 tests, 2, then 3 weeks apart. They brought meteorological stations, whatever. So they did this test. They shine the laser, starts at 10 feet. They pick it up at 4 feet. Okay. Now they should only be able to pick it up if they were on top of a 40-story building. Even if there was refraction, that would only, so-called standard refraction, right? That would only bring it down 5 meters. That would only, in case you didn't hear me, that would only bring it down 5 meters. So they should see it at 127 meters. Standard refraction would bring that value down to 122 meters. But they picked it up at 1.5 meters. This is like 2 orders of magnitude difference. The other one was done over Salt Lake. And this one is just fucking crazy because what they did was they kept getting further and further away from each other successively, right? So like they went like 11, and the other ones too. The other ones are multiple distances with a horizontal pan, but this is like they actually like, okay, we picked you up at 11 miles, we picked you up at 20 miles, we picked you up at 30 miles, and then they started doing variations where they were like 30 miles away, driving across the fucking desert, watching the fucking light go sideways, right, going from like left to right across their field of view, 30 miles away. But 30 miles away is like, it's supposed to be like 600 feet under the curve of the earth. This is like hundreds of feet. It's not like a little bit. Okay, so these results are orders of magnitude different than the prediction. Now, someone might come along, well, you didn't control for a variable. You can't say the laser was straight. So it's actually, you don't really know. But there's no evidence available anywhere that shows that lasers or any other light gets refracted at all. It's just something, it's an ad hoc hypothesis so that the globe can't be falsified. That is literally what it is.
We watch rainbows refract. Yeah, we can watch rainbows refract in the daytime, and nothing matches that rainbow. Is the rainbow the measurement of the Earth? No. Light refracting at the rate of a curve. It doesn't happen. Look at a rainbow. I'm just telling you, brother. The fucking curve's right in front of you. That's not the curve of Earth. Earth's not curving. That rainbow's based on a horizontal. And some of the rainbows are circle.
Yeah, look,
standard refraction requires R. They don't have it. Sorry.
Yeah, that's also circular logic or spherical logic, infinite circles.
Yeah, but they don't have the radius value of Earth. So how are they going to claim it for their refraction values?
Exactly.
I mean, that's actually whistling past the graveyard. How can I even demonstrate refraction exists at all? Right. So that is really the elephant in the room. How,
according to Snell's law,
evidence that it exists?
Two mediums and a hard boundary.
Yeah. It's supposed to be a well-defined boundary. Like what's the evidence that exists at all? And what is the evidence that's out there right now, right? If you go through the academic literature, there's no evidence for it. The academic literature basically says, yeah, we tried to model it, we can't do it. Right? And so we did some laser tests, and then because there's other phenomenon, right? If things were being refracted, that we would see this phenomenon called dispersion. You see it in astronomy. They actually make correctors, dispersion correctors for telescopes. They make those, but you never see this long distance observation, Mount Canigou is being refracted 2 miles up over the horizon. Well, why don't we see any of these dispersion effects? Why don't we see magnification effects? Why don't we see not magnification, but it actually appearing smaller because the optical path length is longer, right? So think about this. If you have something far away in a distance and you have a straight line to it, if it has to take a curved line to you for you to see it, it's going to appear farther away because the optical path is longer. Why don't these things appear farther away? Why don't, when they go up on top of Canigou, make a 275-mile observation where there's supposed to be all this refraction and curving light, right? How come it doesn't look like it's 300 miles?
It would go in all
directions. Well, that's what it should look like because the optical path. We judge distance based upon what is the length of the optical path. That's how we actually judge distance. And there's distance cues, but if the optical path length was longer, it would appear farther away than it really is. And there's dispersion. Dispersion is really the elephant in the room because this is how a prism works. This is how Demock's rainbow works, right? Is fucking rainbow in the sky. Because when the white light goes in, each wavelength has a different path that it takes, and it gets spread out in space. And you have red here, blue here, green here, orange here, red, purple there. If we're getting these weird refractive effects, why don't we ever observe this? Why don't I look at, like I said, Canigou, and it's blue on top and red on the bottom, like we do when we see dispersion of celestial objects? We've never observed this. And one of the Canigou images is taken with an apochromatic telescope. That means the telescope has a dispersion corrector in it. So say you saw dispersion, right? It can't be from the telescope because the telescope is dispersion corrected. It would have to be out in the environment where it's happening. But we don't see that happening. We don't see it out in the environment. There's no dispersion in any of the images. So we don't have to just rely on, our theory says that there's a spherically symmetrical temperature gradient and density gradient, so the rays of light have to curve. Well, yeah, dude, it wouldn't matter what your model is. It doesn't matter. Eventually, whatever theory you have or hypothesis, You actually have to demonstrate it with an experiment. You have to test it in the real world and retrieve the empirical data to validate whatever model you have. And that's the rub, because there is no empirical data. That shit's getting bent up over a curve of the earth. None whatsoever. Not even a single thread iota of it. Sorry about the rant, dude, but I hate having to beat this fucking topic over and over and over again because someone says the fucking magic word refraction. Dude, it's annoying because I know that there's nothing to it. It's really just fucking hollow.
Yeah, but when something becomes refracted, that means it's no longer physical.
True. Yeah, then everything becomes apparent, and you just throw out geometry, and you really can't make any geometric claims at that point.
I guess that's my point, is that you're having an apparent light that you're receiving at the end of the laser test.
Yeah.
I'm not saying that.
That seems redundant.
But I mean, if I ask for well, how do you know that where's flat? And you throw lasers at me, it's okay, so you have an apparent light position.
I'm not saying the laser's being refracted.
Well, since that's a possibility, how are we not doing an affirming consequent when we appeal to the laser?
So you're claiming that entire laser beam is being refracted up, and that laser beam is
Here's the thing, right? I guess it's annoying for us because you know what it really is when you boil all of this down. Flat earthers are just trying to chase down the claims of globers, and every time they're proven to be false, there's some ad hoc explanation that somehow flips the burden back onto us. For example, hey, the horizon is Earth curve. Oh, is it 1.2 times the square root of the observer's height in feet? That's where it'll be, eh? No, incorrect. It's not going to be a tangent to the point of the ball, right? Which would be marked with an X, labeled the horizon on all of the EDU websites that I can find. Okay? So since it's not that, even though that is the claim, what are we really talking about? You have no claim. Why are we talking about refraction? What do we need to? It was your.
Well, he asked for the evidence. He asked for the evidence that the Earth was flat. What's our argument? And I said, hey, we can measure the height of a laser above the surface of water, and we don't have to assume anything, right? Because we can just take a tape measure, right? We can just say, hey, the laser's this high here, the laser's this high over there. And his argument is, well, refraction can confound the results. Yeah, but how much? We're talking about differences. Well, hold on. We're talking about differences of 2 orders of magnitude. We're not talking about a small difference in the experimental.
That's where we get on the back foot. The burden is on us for some reason. Again, if he wants to know about refraction, the bottom line is people who believe in the globe took flat earthers to the beach to point out how laser tests would prove that there would be 8 inches per mile squared. What are we talking about?
All the calculations for refraction are based off of Snell's law. And when you're looking at a distance over the water, like for instance, the Black Swan oil rigs, how sometimes they play peekaboo over the geometric horizon because when they say that, they're claiming those oil rigs aren't physical. They're mirages moving upward. All that is based off Snell's law, but the thing is, they're missing a component to Snell's law, which is the boundary. There's no boundary separating 2 mediums.
Well, you just contradicted yourself because it's not based off of Snell's law. But I get what you're saying.
It's refraction. Refraction. Snell's law is the law of refraction. So therefore, what they're claiming has to be based off of Snell's law, and it's taking little chunks and pieces and skipping over everything else and added an artificial radius value that has not yet been shown because it's not possible.
Okay, so let me just chime in on it. It's not based on Snell's law, and it is. It is based on the radius value, and it's not. It is based on Fermat's principle, and it's not. It is based on, it depends on who you talk to. Depends on which globe earther you talk to that's going to come up with their version of the ad hoc excuse. That shows you that it is an ad hoc excuse is because there's no uniformity in what the excuse even is. And if you ask them for the evidence, they can't point to where that evidence is. They'll point to you to a theoretical fucking a website that sells, light bends shit over the curve of the earth. Like, no, I want data that demonstrates it. You'll never get that. Ever, ever, ever. You'll never get one itty bitty bit of data, actual data where they tested it in verified the model or whatever it is they're saying, Snell's law, fucking R, 76R or whatever. There's no experimental data because science is supposed to be empirical. That's what I thought. It's supposed to be based on empirical tests. Where's the empirical tests? That's all. That is really what the bottom line is.
Right, but claiming something is refraction, but then saying it has nothing to do with Snell's law, that's like talking about entropy and then claiming it has nothing to do with the second law of thermodynamics. You can't separate entropy from the second law of thermodynamics because the second law of thermodynamics is the law of entropy. Like the same thing with refraction. Refraction, it's Snell's law of refraction. So anything that is claimed to be refraction has to follow Snell's law, and it's missing the main thing, which is a boundary between two mediums. But they get
they use multiple models. That's the point I was getting at is they use multiple, depending on the globe earther you're talking to.
Right.
So as far as refraction goes, we use a bunch of different models for refraction. Just period. Right. So there's the ray optic model. There's the wave model. You can even have a photon model. There's a quantum mechanical model. There's the Fermat's principle model. There's Fresnel's model. So there's a whole bunch of mathematical models. They're all used for different purposes depending on whatever the application is. You'd use a particular model. Now, I understand what you're saying. Hey, you can't have refraction without Snell's law, but that's just one model. That won't cover what's called a gradient indexed medium, right? So there's a gradient that would slowly taper off. The model they use is called the principle of least time. That's what they would use, and it's actually Snell's law is actually a special case of that. So you can come up with a model of a gradient index material, but if you actually look into what would you call it? Condensed matter physics, where they try to actually make these in practice, it's fucking like, I wouldn't say impossible. They can make them, but they can't make them in bulk, right? So they can make a one-off because they have to use like fucking fluorine fucking doped glass, right? That has 10 fluorine atoms in this freaking strand of it, and 9 in this one, and 8 in this one, and you know what I mean? They're super hard to manufacture. But these guys are like, oh, this is how it happens all the time. I just don't. There's just no evidence for that shit. But listen, I understand what you're saying. But as far as depending on what globe, because they use, I'm sure you heard 76R, right? They use that because they can't, because they don't have a model. That's why they use it. It's just like a fudge. Oh, we'll just say the Earth is freaking, 16% bigger. Call it a day. That's literally what they do when they do the 76R.
Snell's law is the formula that's based off of you're talking about a boundary between isotropic media, which is that's a standardized uniform case. But then when we're talking about atmospheric refraction, it's anisotropic. So that's why the Snell's law doesn't apply directly. It's like you said, it's sort of like on a phased gradient. It's not the same.
Yeah, but when we talk, I understand. We understand that, but when we talk to Globers, they'll mention Snell's law. They'll argue Snell's law. They'll do it.
Yeah, Snell's law. I think that's an analog to that is when I talk to people that will say that you can't have gas pressure next to a vacuum, and they'll reference the ideal gas law. But I mean, that's the ideal gas law, which is it's like a rule of thumb that's assuming a pressurized system. The gas law works in ideal situations where there's not a certain amount of thermal dysregulation, which is exactly what we have in the low pressure areas at the top of the atmosphere. So the ideal gas law doesn't apply in non-ideal conditions like that, where the gas particles work differently under extremely low energy systems. It's not an ideal gas. So they'll reference the ideal gas law, but it's like that's not an ideal gas.
Personally, I've never heard of
when you say gas pressure, gas particles. I'm sorry. But when he said gas particles work differently in low pressure versus high pressure, what does he mean by that? How are they behave? What do you mean by work? Because when you say work differently, that to me that means they behave differently.
Right.
What are they doing that's different?
Right, because they don't have consistent boundary interactions. They become basically.
Well, that's not. I don't think that's true.
What is that?
I think that right, what the gas molecules do or whatever are intrinsically linked to the energy or the temperature they're in, right? So they're never going to not be linked. What's happening down here?
Yeah, but regardless of the temperature,
what's happening down there? Yeah, I'm saying what you're saying, but so what's down there is the same thing that's happening up there. The law isn't different up there. So I don't get what you mean by it behaves differently either.
Yeah, so the ideal gas. So an ideal gas is if you just literally look up the term ideal gas, which is what the ideal gas law that they referred to is. They're referring to the ideal gas law, which is about ideal gases. The definition of the ideal gas is it is a theoretical gas composed of many random moving point particles that are not subject to interparticle interactions. There are exceptions to the ideal gas law outside of those types of parameters, which would be particularly extremely low pressures. When you get to extremely low pressures or low temperatures, the ideal gas law no longer applies because we are no longer in an ideal gas situation. Ideal gas law is for pressurized, normalized thermosystems. When you get to the ionosphere, where we have basically radical ion gases that are just bouncing around, they're no longer boundaried. What's happening?
Oh my God, dude! I thought something was going on with my phone.
I took care of it.
What
is that? Goosh. Bye, Goosh. Goosh. Change your name.
Well, when a gas gets into a really low pressured area, how does the behavior change?
No, I was going to ask a question.
So yeah, basically instead of having constant boundary interactions, they're just more like they're bouncing in space.
Yeah, no. And that's what I'm going to ask you about, the ionosphere. What's that about? Where's that at?
The outer.
What do you mean by boundary interactions? What does that mean?
Hey, you focus on the wrong thing, bro. Like I'm trying to figure out where things are different. It seems the behavior of gas. So listen, I'm just trying to identify where he's saying things are different. He said the ionosphere. I mean, I don't.
Are you about to ask me for proof that the ionosphere exists? Is this set up?
No, I'm just trying to figure out like where's this data coming from to say, okay, things are different. Clearly, you just said, well, the ionosphere. How did they retrieve that data?
They'll see. There it is. I knew it. There it is.
Okay, and go on.
Yeah, no, I don't need to entertain the does the ionosphere exist thing. I wasn't setting out to prove it either.
Why? No, you're saying that gas particles behave in a particular way in a particular area, and I'm asking you, how do you know that?
Yeah, I don't.
Well, he specifically said gas pressure behaves differently in low pressured areas.
We need your help, fam.
No, you kind of do because you're not getting to the crux of what he just said. He said gas acts differently when it's in a low pressure.
Okay, it's that guy. I forgot. Go on.
Okay, so basically the idea is that gas behaves more like an ideal gas at higher temperature and lower pressure. Because the potential
I hear what you're explaining. I'm just asking you, how do you know what you said? Are you telling me you don't know?
Well, the ideal gas law is a theory for how we.
I'm not talking about the ideal gas law. I'm talking about what you said.
That's what I'm talking about.
I know, but I followed up, right? So it's not like I'm asking a completely non-sequitur question and now you're asking. You already said you were
getting a lot of echo. Something's happening.
Right?
Can't hear you. Big time echo.
Hi, when you're hot micing. Hi, when you're hot micing. I'm sure he knows at this point because I was on speaker. So whenever you feel like getting unmuted, inbox me.
So you're asking me how I know the ionosphere exists? I don't. Somebody told me.
That's not okay. Well, I'll accept that. So then your claim is just a baseless assertion, then?
No, my claim is about the ideal gas law, and I'm saying that you can't appeal to the gas.
Yeah, but you said it doesn't apply to a place that I asked you. Okay, well, how do you know what you said about that thing in that place? And you said, well, I don't know. So with that's where we are.
Yeah. Okay. Great. So theoretically, if that was the case, that there was a place along the gradient of lower pressure that we do experience as we elevate, I'm sure you would agree, that if we got to a place where there was such low pressure, as is described in this concept that we call the ionosphere, the ideal gas law would not apply to a environment like that because it's not an ideal gas.
I hear you saying that, but
that's all I'm saying.
I hear you saying that.
That's all I'm saying. So I'm liking that. I'm making an analogy to where we can't appeal to ideal gas law to what would be happening in the upper layers of the atmosphere if there is a gradient to where it goes to such low pressures and low temperature.
Well, you can't compare something. You can't compare something. You know,
I'm saying in a similar way, we can't
to something that we've never. I'm sorry, you literally weren't talking when I started talking.
Amazing,
right?
No, I don't know. I thought I was. Amazing.
I don't think you can call an analogy by comparing something that we experience to something that we do not.
Well, we can, experience gas in extremely low pressure states, right? Or extremely low temperature.
No, gas behaves how gas behaves always. Now, you're saying it behaves differently in a particular place under particular conditions. Okay, so that's a baseless assertion. That's cool, I guess.
Oh, well, you're asserting. Likewise, you're asserting that I'm sorry, I'm interrupting you again. My bad.
Yeah,
I hear you asserting that gas always acts the same way in all circumstances. How have you proved that?
In all experiences.
Oh, really? You have had all experiences?
No, all my experiences, all lived experiences. If anyone else has had a different experience, I would ask them what that was. Did you?
No, I don't do.
Okay, because if there was any human on Earth at all, ever, if I came across any human, I'd be like, oh, okay, well, seeing is that, water boils for me just like it boils for everyone else the same way, just like I'm under the same natural laws that everyone else is under. We experience the same things. I need to know how you're experiencing this thing differently. Explain it to me. I'm not going to just be like, get out of my face.
I have a basic understanding. Like I know they can ionize gas in vacuum tubes, so we can put gas into an ionized state.
Yeah, in a tube.
And we do understand that in that special circumstance, it does not operate according to the ideal gas law. It's no longer an ideal gas.
Of course it wouldn't, because it wouldn't be a natural environment, would it?
What do you mean?
I mean, you put it in a tube and then you did some stuff. It's not natural, is it?
Well, you just put it in a reduced
Well, it's simple to answer the question. I mean, you'd be like, yeah, you're right. That's not natural. I understand what you're... It's like that seems to be the appropriate...
It's not unnatural.
It's unnatural because it's not like that in nature. Now, you're trying to compare something that is unnatural. Listen, you're trying to compare something that is unnatural to this explanation of something you've never experienced somewhere else. No, sir. Not for me. Sorry. You can do that. I hope you understand how that's nowhere near good enough for me.
sir. Not asking you to do anything. I'm only pointing out that the ideal gas law, as defined by those who use it and practice it and defined it themselves, the ones who came up with it, even according to them, doesn't apply in non-ideal conditions.
I don't know what that has to do with the price of tea in China. I already told you that.
Then it's just a matter of you not being able to follow along. I don't know.
No, we are following along. You're talking about the ideal gas law not applying to a place that you've never been and don't. That's where we're at. How am I not following along?
Yeah, I've admitted that I haven't been.
Okay, so don't say things like I'm not following along when I am. Obviously, that'd be the kind of thing that breaks down a communication. That's why friends that's why they stop being friends because of dumb shit like that. When I say something correct, just go, yeah.
Well,
okay,
I don't feel like, I'm feeling a level of hostility that doesn't feel friendly from you, sir.
Because of what you just did. And I'm explaining it to you. See, a bad friend wouldn't explain it to you. And we're not friends yet. Right now, we're just talking to each other.
Right. As far as I can tell, we're adversaries.
I'm explaining to you what would piss me off, and you're doing it, and you've also admitted to it, and it's recorded. Yeah. So I was
You're doing it too. Yeah, we're in the same boat.
No, I'm just being hostile because you're doing what you're doing.
Oh, it's my fault that you're being hostile.
Well, because you're doing what you're doing. Well, I don't care that I'm being hostile. I'm not being disrespectful to you. There's a difference. You're the one saying I'm being hostile, and I'm telling you why. Again, because I'm being transparent. But we didn't need to talk about the hostility at all. All we had to do was talk about the exchange and how you've agreed with everything that I've said. So just be a little.
Except that the idea.
I didn't bring up the ideal gas law. Don't do that.
You said that ionized gas in a vacuum is unnatural, and I didn't agree with that.
What do you mean? Where in nature is a vacuum natural? And I know you're not saying that it is. They are natural.
I mean, I can't say in space because you have an assertion that space doesn't exist.
So if we're being fair,
he thinks most of nature is a vacuum. You got to remember, dude. He thinks most of nature is a vacuum.
Yeah, I understand that, but he also understands.
that vacuums exist all around us.
He understands that that's the point in contention right now. So at least he understands that he has to watch his wording. He doesn't want to commit a logical fallacy. I can feel him thinking. I at least appreciate him taking pause here and there, regardless of his belief.
I wonder if you can tell me what you think I'm saying regarding the ideal gas law.
I didn't hear you because I was talking.
Can you tell me back what you think that I'm stating regarding the ideal gas law? So
I just did like literally 5 minutes ago, and it was like a quick 2-sentence summary or 1-sentence summary. We just did that.
All right. Then let me ask this. Isn't it fair then for me to say to the person who goes, you can't have gas without a barrier? Couldn't I say, well, you show me the barrier? Have you been to the barrier? How do you know there's a barrier there?
Well, I don't think you can't have gas pressure without containment. If that's what you're asking. Because I've never experienced that.
Why not? Oh, because
I've never experienced that.
So if you haven't experienced it, it can't happen?
What I'm saying is, I've never experienced it.
But you're also saying it can't happen.
I nor any other human has ever experienced. That's like someone telling me, so you're saying flying.
Well, I'm experiencing it.
I'm sorry, I was talking again, and then you started talking when I started to leave.
I thought we were talking back and forth.
I know, but I'm about to leave with an example now. That's like someone saying that someone else can fly, like a human being, right? And I'm like, well, I've never seen that. And they're like, so because you've never seen that, you're saying, listen, high pressure always goes to low pressure. In order to have gas pressure, it needs to be confined to an area. The only way we do that is with a container. That's how we achieve gas pressure. That's the only way I know that it's possible. So that's it. Someone else who comes along with the claim that you don't need that, and that's not the case. As a matter of fact, here's a worldview with that not being necessary, I'm going to say no, sir. Respectfully.
Can I say something for the record, Newt? You know they use the ideal gas law in the situation. You're saying they don't use the ideal gas law, right? Like the 3 seconds it took to look up atmospheric dynamics ideal gas law. And I get, in atmospheric dynamics, the ideal gas law is a fundamental principle. Like what?
I didn't say that it doesn't work in atmospheric dynamics.
Then why, if someone brings it up, would that be wrong?
Because what we're talking about is the boundary between atmosphere and no atmosphere. Vacuum means no atmosphere. We're talking about atmosphere next to no atmosphere. And there's a gradient where there's a breakdown in the.
Does it go to zero? Does it ever go to zero?
No,
technically no.
10 to the negative Tor 17. Like we don't know.
So the atmosphere is the entire universe. So there's a gradient across the entire universe.
Yeah. Well, there's because vacuum means absence of matter, right? Exactly.
In a certain sense.
Yeah, so I'm never.
In a certain sense, no, dude. Like, listen. Then we're just all like the gradients of every other fucking celestial body. We're all mixing in each other's fucking gas gradient, dude.
That's right.
Dude,
He's actually that actually is right.
Yeah, that's a cool story, man. So here's the funny thing this is the thing I always find funny talking to you guys is that you guys, you claim to have a scientific backing of what you're saying, but science is based upon empiricism, and all we get from you guys are stories. We get quote unquote explanations. Explanations are not science. The science is the data. That's the science part. Right? So.
Well, I could turn that around on you so easily, though.
Yeah, full story. Anyway, so what Elijah was bringing up.
The story you just told me.
He wants the empirical. No, that's not a story.
It could be reflecting off the dome, and maybe that's why we should put.
Well, you demanded that from me. You demanded that from me. I said I could make up any bullshit. I didn't fucking volunteer that. I didn't say it was based upon science. Just horseshit.
Right, I can make up horseshit. You demand from me an answer for how there could be air pressure next to a vacuum, and I say, well, it's pressing against the surface of the Earth because of gravity, and you go, cool story.
Yeah, because like Elijah said, that's contrary to like all experience. We want the empirical data that demonstrates that that's the case, right? That you can have a vacuum next to a pressurized gaseous system without a barrier separating them, and they can be separated, gradient or no
They're
gradient.
not separated.
Because experimentally, if we do an experiment, because let's go to experiment now, we take a vacuum cylinder, right? Say it's a 100-foot cylinder. I evacuate it. It's a vacuum. There's a little port on the bottom. I suck out all the air. Now I go, okay. Now it's a freaking 10 to the negative 10 torr vacuum. I'm going to insert a little bit of air into it. And we're all on the surface of the Earth where the gravity's strongest, right? Is gravity going to hold the inserted air to the bottom of the container away from the vacuum? No. It's going to reach thermodynamic. It's going to spread out throughout the entire cylinder until it reaches thermodynamic equilibrium. It's not going to freaking sink to the bottom.
So where will it?
This is what we're talking about experimentally. You can't demonstrate it.
Where would the atoms of that gas molecule be located?
Yeah, all over the place. I mean, we don't know exactly. That's why we use statistics to get a probability of where it will be.
So we don't know.
You use the Einstein-Bolt statistics or frickin' the Einstein-Maxwell statistics.
So be some non-local place.
Yeah,
we're still getting that echo. It's not me.
No, it's just statistical. We don't know.
Oh, well then, how can you claim that what it will or won't do? If you don't know.
Statistically, it'll be at a random place somewhere in the cylinder, but it won't statistically be at the bottom, right?
So it'll just find some random place to hang out.
No, it'll be in constant motion. It'll have a kinetic energy.
It'll never stop moving?
That's right.
How can you prove that?
Well, because when we actually try to cool things down so that they stop moving, they don't stop moving. No matter how hard we try.
Yeah, but we're not talking about gas moving through space. We're talking about the atomic.
No, like experimentally, we can take rubidium atoms and we can laser cool them to form what's called a Bose-Einstein condensate, and even then they move around.
But wait, we're talking about gas.
Yeah.
Who's got that
Yeah,
echo?
I know. Rubidium atoms are gas.
Okay, so you've put a single rubidium at gas.
They use ensembles of 20. They use like an ensemble. They don't use just one.
And they perpetually move around the vacuum chamber forever?
Yes. They have if it has a temperature, it's in motion. It's called the kinetic theory of gases. So if it has a temperature, it has you can do an equivalence of the temperature to a kinetic energy.
So it goes up and down, left and right,
every
all over the place with no regard for little g. It has no weight.
Well, they don't have any little g in any of the equations.
Oh, wait. So are we talking about equations or experimentation?
Well, there's no look. Why would you even bring up little g? That's the point. Why are you even bringing it up? Because we know experimentally.
Because you brought it up first. You said, would it settle to the bottom? And then you said no. And I said, how could you prove that? And then you referred to math.
Because anywhere we measure inside the cylinder, the pressure is going to be the same. We measure at the top, we measure at the bottom, we measure in the middle, right? Once it's reached thermodynamic equilibrium, anywhere we measure in this cylinder, it'll be the same pressure, temperature.
That's fine. But where will the
point. It won't be more pressure at the bottom.
But where will the molecule be?
Who cares?
You stated that it won't go to the bottom, and I'm asking you how you can prove that.
If it has a uniform pressure and temperature, then it has the equal distribution, right? Matter per unit volume. It'll be equal everywhere. We model it statistically because we can't know with precision where every single particle is. We don't have the instruments to do that. Maybe someday we will, but right now we don't.
Well, that sort of like shoots you in the foot then. If you don't have the instrumentation to measure where the particle is, then you can't say it didn't go to the bottom.
No, we can make an equivalent. We can get the equivalent, right? Pressure, temperature, volume, right? We can get the pressure or the temperature.
But you're telling me what the pressure in the cylinder is, not where the molecule went.
What is pressure? We're talking about pressure, dude.
Deflective force.
We don't care. I don't care about you can't say, hey, pressure is different than matter per unit volume, and then claim you're talking about vacuums, dude.
Well, vacuum isn't a pressure.
Oh, really?
Yes.
So we don't use a pressure gauge, right, to measure vacuum.
Well, not directly, no.
What do you mean not directly? What are you talking about?
No, we use a pressure gauge to measure pressure, but vacuum means absence of matter.
What is pressure?
Pressing force.
Okay, the force exerted on the walls of a container.
Well, that's not only that. It could be pressure. There's a lot of different kind of pressures.
So we take a pressure gauge. What happens in the pressure gauge is there's gas.
Pressure means force over area.
And each module has a freaking kinetic energy. And if you have X amount of pressure, you can say X amount of particles hit the freaking pressure gauge over this unit time. So there must be this. And if we know the temperature, we can say, hey, there must be this many particles in this volume. The point is that if we measure the pressure and temperature and they're in equilibrium, they will not vary in the cylinder at all.
Wait, no,
right? And we can infer that without counting the particles directly, because we know that the only way the pressure gauge is going to get a reading is if it's hit by gases, right? Otherwise, you're not going to get a reading. Unless you think spontaneous pressure or something like that, like you fucking magic fucking gnomes are pushing on the pressure gauge. I mean, you can believe that, but we know that little gas molecules have to be hitting it, and so many hit it per unit time, right? We know if we know the temperature, we can say, hey, this is the kinetic energy of the gas. These gas molecules have to be traveling so fast, but we're getting this pressure reading. That means X amount of fucking particles hit it to get this pressure reading. Now we know how many particles are in this volume. It's pretty simple. It's not complicated. But the thing is, this is an experiment, right? So we can do this experiment. Like, you can say, hey, you can have gas pressure adjacent to a vacuum and it doesn't fuck off into the vacuum. You can say that. But what can you demonstrate experimentally? That's really the question.
Well, that's what I posed to you. How can you demonstrate experimentally that...
We can demonstrate experimentally we can't do it.
Well, absence of a determination isn't the presence of one. So
yeah, but you know, we don't make things work. Like, all things aren't true until they're all.
Wait, please.
Well, no, because you're trying to like do this burden of proof bullshit, dude. Listen, all claims aren't true until proven wrong. That's not how it works.
No, you said that if we put a single particle in a chamber with no pressure, that it would not go to the bottom. And I asked you how to demonstrate that. And then you referred to math.
No, I didn't say single particle. I said if we inserted gas into the bottom of a vacuum cylinder at, say, 100 feet tall, it's an arbitrary height, doesn't matter how tall it is, get 1,000 feet tall, get 1,000 miles tall, doesn't matter. We know if we insert the gas doesn't settle to the bottom. We know this from experience. We know this empirically from doing it.
Where's that test? 100-foot tall vacuum chamber.
Oh God, dude!
And the gas doesn't.
It's a Gedanken experiment, dude. Like, we don't actually need to do it. Like, if you really want to do it, like, do you really need it to be done? Something we already know.
If you're going to say that that's what happens, that you experientially.
Just use your common sense, dude. Just use your common sense. We make vacuum chambers for all sorts of purposes, manufacturing chips, blah, 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 blah. They don't have a little mixer in there trying to mix up the fucking gas off the bottom, okay? Because all the fucking gas that's up, because you can't make an absolute vacuum. So there has to be some gas particles in there. They don't have a little mixer mixing the fucking gas around.
Right. And
but you're saying is the vacuum. Why don't you just make a vacuum chamber, right? And you don't even have to have a high vacuum, because you could just take the sample and stick it at the top. All right? And if you stick it at the top of the vacuum, there'll be more pressure at the bottom. You just wait for everything to fall to the bottom. You wait for all the gas to fall to the bottom. Like, why do you even need a vacuum pump? Just fucking make a chamber, and all the gas will fall to the fucking bottom, and there'll be a vacuum on top.
Well, if the chamber was tall enough, that's exactly what would happen.
Oh, Jesus Christ.
Well, let me ask you this. Let me change up the parameters a little bit, see if it holds true.
Why does anybody even make vacuum chambers? Why make them at all? Let's just fucking make a fucking super tall fucking structure where all the gas magically falls to the fucking bottom.
So we have
but we'll always see gas at the very top. Okay, I think Indio, I think you might be confused here, because I think you're saying that outer space is a perfect vacuum, and I don't think anyone here is making that claim.
No, it's not what I said.
If the gas chamber was one...
Obviously, I didn't say that, dude, because I did the theoretical. I even asked, does it ever go to zero?
No, and I'm saying it does not. It will not go to zero.
Why would you ask me 15? Why would you ask me 15 minutes later if I think it goes to vacuum? Or think there's a perfect vacuum?
The pressure on the moon is not absolute zero.
You have no idea what the fucking pressure on the moon is, or anything about the moon, dude.
Let me ask you this question. So now this theoretical...
Or like even outer space, not even the moon, just empty space.
There's no fucking outer space, dude. That's the thing of contention.
Okay, we're getting the echo from Indio, because his lag got what I talked.
Yeah, you are.
Indio, you're creating an echo.
I had a headset on, so I don't know how the fuck that...
Well, you need to maybe turn down your volume, because
all of our voices are being picked up at your mic.
Yeah, but it's... hold on a second.
Maybe your echo cancellation's off or something like that.
Test.
Let me check.
Is that better?
No, it's still there.
No, it's check.
Hold on, let me reconnect my headset.
All right, check. He's muted now. The question I want to pose, so theoretically, if this vacuum chamber is...
I don't know how you can get an echo when it's an earbud headset, dude. Like, there's no way the mic can hear within my ear. That's impossible.
Oh, shit.
Oh, it's better now.
Let's freaking go.
The reconnected. Okay, so now theoretically, the vacuum chamber is 100,000 miles tall. Vacuum chamber 100,000 miles high. It's absolute vacuum. There's nothing in there. Theoretical. And then you somehow are able to let one oxygen gas molecule into that vacuum. Will you be able to sense that oxygen at the top and the bottom at the same time?
Can you guys
Obviously not, and that wasn't my hypothetical, dude. You guys always have to change shit, straw man, and do a bunch of bullshit. That wasn't the hypothetical.
Well, it's a thought experiment. Yeah, we hear you.
I hear you.
So the thought experiment is important because the question is, will that gas, if it was let's say it's next to a significant, it's in the same type of system that we're in now, whatever causes things to go down and accelerate down, we would call it little g. It has weight. So it has weight. Where will that gas molecule go? Would it not get attracted? Would it not be caused to go down just like everything else falls in a vacuum?
No. It has a kinetic energy.
So where
you are aware of the phases of matter, right?
Yeah.
Where will go? Just bounce around forever.
Yeah, but
Wouldn't it be losing energy when it interacts with the boundaries?
So not all gases.
Well, it'll reach thermodynamic equilibrium. So, like, it'll pick up a temperature from the cylinder itself if the cylinder has a temperature. If the temperature of the cylinder was absolute zero, eventually it would come to a stop. But your idea is that it's going to roll around on the fucking floor. No one's ever seen a gas molecule roll around the floor.
Why do feathers fall in a gas chamber?
Why wouldn't they?
I mean, in a vacuum chamber.
Yeah, go ahead, Alpha.
Yep. All right. Yo, Big Tech, are you there? Can you hear me?
Yep.
Okay.
Why do you think the Earth is a globe?
Oh, boy. We're starting all the way from scratch?
Yeah.
Okay, we were having a conversation here. We're just ditching it, going to a different one now? Everybody in agreement with that?
What do you mean everybody?
He's on break. I'm fine with it. It only lasts a minute.
Okay, before we leave this topic, Indio, do you know about sulfur hexafluoride?
Yes, I know what sulfur hexafluoride is, dude. This ain't 2016, bro.
All right, Big Tech. How do you know the Earth's a globe? Should be easy.
Looks curved.
When have you seen it curved?
Saw pictures of it.
From where?
People who went up real high.
Okay. When you have that picture in your hand, what do you have to compare it to?
Everything else I've ever seen.
That doesn't make. That's very ambiguous. Okay, let's do it again. When you have that picture of the Earth looking like a sphere, when you go outside, what do you compare it to?
Why would I? What do you mean? What are you getting at here?
Well, the images of the thing you're standing on, right?
Okay.
Okay. So if it's the thing you're standing on, where do you see the Earth looking like that image?
Where? In the globe.
Yeah, where?
On my grandfather's desk. He has a globe.
Okay, but that's paper mache, whatever.
Yep.
And that's not the thing you're standing on. So what we're trying to compare it to, those images, right? Because you think, well, that's the Earth. Well, the Earth that you're thinking of is the one you're standing on. Now, when you're looking at that image, right? Where does that image compare to what you're standing on? Should be easy.
Okay, then what's the answer?
I don't know. You tell me.
You stumped me.
I'm not the.
Hold on, Alpha. I'm gonna dumb it down. Okay, he's asking you the picture. How do you evaluate it? How someone says, "Hey, this is a picture of the thing you're standing on." So you print out the picture. You go outside. You go get a picture. You go get the ground. You go get a picture. Like, how are you evaluating it that image is authentic? That it is actually an image of the thing you're standing on.
Right.
How does that work?
I don't. I don't.
Excellent. So interesting, right? So the image that they're telling you that the Earth is a globe, and the reason why you think it's one has nothing to do with the thing you're standing on, according to a comparison from the thing that they're showing you to the thing you're standing on. There's no way to compare it to the reality.
Yeah, I haven't been there, so I haven't had that view.
No, it's not about being. Yeah, it's not about. Yeah, but it's not about being there. It's about being here. So they're showing you something that's extraordinary, right? This spheroid Earth. Now, the spheroid Earth that they're showing you, they say, "Hey, dude, you live on this thing. We check. We're showing you images of it from where we're at," and you're like, "That's awesome. I believe you. Based on you telling me this story and showing me these images, I don't need any further information or evidence. I'm gonna believe you." So it's a faith-based belief system that you have because you didn't compare the image to anything in reality. You just believe that it is so because of an image and a story. Is that true?
Okay. Yeah.
Really? Okay. Well, in that case, there's no real reason of a justification for you to think that it's a globe. You just blindly believe that it's a globe based on a really cool story.
Okay.
All right. And on the other hand, when we talk about flat Earth, we have the evidence to back up the claim. Now, I heard you saying earlier that, they're measuring the Earth, surveyors, right? Civil engineers, I think you used the word. But you're saying that they're measuring the Earth when they're taking the curvature of the Earth into account. Is this true?
Yes.
Okay.
So.
How do you know? Oh, belief.
Yep.
So looking into this, have you ever talked to a surveyor and asked them specifically, is it possible that every time you survey the land, that you take the curvature of the Earth into account when you're getting the raw data extracted from or collected from the field research? When you're out there, you're looking upon the land. Yes, you've talked to a surveyor, and the surveyor responded back to you, "I take the Earth's curvature into account when I'm surveying the land."
Yes, that's what he told me.
Who did you speak to?
I talked to him on Twitter. He could be lying to me.
Well, it's not about him lying.
Pretending to be a surveyor.
It's not about him being an
imposter. It better not be Jesse. Hold on. Is it Jesse?
Yeah. Kozlowski?
No, the other Jesse. Path of Light.
Path of Light?
Jesse Gordon.
Look up his name again. Let me see. Hold on a second.
Okay. So there's amateurs. We're not talking about amateurs. Some people are not professionals. They don't do this at their job. Real surveyors, people who do this professionally, will tell you that they're not taking the Earth's curvature into account when they're doing their planar surveying. Now, the geodetic surveying that you might think they're extrapolating the Earth's curvature from is a calculation superimposed off of the raw data that they're getting from planar surveying. I was trying to tell the chat to look at what I was texting, but it was pretty cringe when you were saying that's what they do. You're incorrect. Professionals don't do this. They don't take the curvature of the Earth into account when they're surveying the land. You're just wrong. And whoever's telling you this is probably an amateur and doesn't know what they're talking about.
What's the name of the person that you said you thought it might have been? Jesse? What's his Twitter handle?
Jesse Patholite is another guy. I don't know if he uses Patholite as a handle.
What if I brought him in here, the surveyor?
He has been.
Hold on. Jesse Patholite is not a surveyor. He's been in here.
No, I don't know.
You've been in here hundreds of times, dude.
No, the surveyor that I was speaking to. What if I brought him in here? I wonder if he can join.
What's his name? Who is it?
Path of Light.
No, he's not a surveyor.
Sorry. Hold on. No, I said what you said. It stuck in my head. It's a different P name. Phantom Thoughts. That's his handle on Twitter. Phantom Thoughts.
Yeah, please. Bring him in here.
Yeah, let me hit him up and see if he's available.
Excellent.
Yeah, can we take a side bet real quick? $50. He does. Yeah, he's never heard of curvature of the plumb line. I'll bet $50. Any takers?
Yeah, because
never even heard of it.
If he's doing rise over run and he's saying he's accounting for the Earth's curvature, he's in a whole lot of fucking trouble. So I want to hear him say from his own mouth, being a professional. First of all, we got to find out if he's a professional or an amateur, some guy who just got a theodolite and is winging it. He said, "Honey, hold my beer. I'm going to talk to these flat earthers." Like basically a Jesse Path of Light individual. I'm going to take this dude apart 9 ways to Sunday if he's lying. I guarantee it. There's nothing he can do but tell you the honest truth about what he does in his profession. And they do not. No surveyor takes the curvature into account when they're actually surveying the land, extracting the raw data from their measurements. They don't do that. 0 surveyors do that. So I'm kind of interested now. It's piquing my interest.
Yeah,
hopefully he does get the guy in
DMs, see if he's available. If I remember right, I think he said he worked for Caltrans. He does surveying for roads and bridges and stuff like that.
Excellent. Well, then he's not going to lie. And if he does, it's his ass. He's going to reap the fucking whirlwind. I guarantee it. So all we got to hear from him and him to you is the truth. The truth, the whole truth, and nothing but the truth. So help him.
Let me ask you a question about the surveying. So can I infer from what you're saying that when all of these textbooks and manuals give a curve correction formula to be used when calculating distances, you're saying that this is garbage, like lies?
No, let's not misconstrue what I said. Geodetic surveying is a superimposed application that uses the Haversine formula to actually extrapolate the rotundity of a spheroid model. Did you hear what I said?
Yes.
Hello? Okay. So they're not actually measuring curvature. The measurement is being done over planar surveying.
But my question is different than that.
I know that, but do you understand the implications? So what's happening is yeah, I know. It's a bit tough for new people to actually think about this. So whenever they're doing the surveying, this guy sets up his gear, right? Total station, whatever it is he's using. Once he sets up his equipment, he's not going to think about the Earth's curvature over distances that he's going to use, because it's for accuracy. He has to shoot for short distances, right? It depends on the accuracy of the model of total station or theodolite he's using, right? It has to have a tolerance range within a certain amount of parameters. Like, you can't just think that you're going to use a theodolite to use it for whatever distance. That's not how it works. Do you know that?
No, that's might be above my pay grade.
Well, it's not too hard, man. Think about it. So if you're using a device specifically designed for what its use case is for, there's nothing that is going to allow it to use it outside of those working parameters effectively, right? Because you want to extrapolate the most accurate data that you can possible within a tolerance. Does that make any sense?
Yeah, but it sounds like you're asking me if they're accounting for the curve of the Earth when they're setting up the theodolite.
Yeah, when they're performing their actual distance measurements, they're not accounting for the Earth's curvature. Now, this is what could happen, right? The device could have already, the new devices that are out now, already have the calculation baked into the devices, like, the computer chip. It could already be doing that superimposed over that information that's taken over the raw data. So that can happen already, because they already have models that do that probably. But the actual surveying of the land over distance is not going to be doing it, taking the curvature of the Earth into account. Specifically, not distances that they're actually going to be utilizing it for.
So actually, I'm referring back to some DMs that I had with him, and he actually addressed this point.
Sure.
And I'll read you what he said. He said, obviously, we don't use pencil and paper and calculator to correct for curve in every measurement that we do when we're on a production mode on the job. But we do use pencil and paper to calculate in our classes and on our license exams.
So what does that have to do with the calculation?
So this leads me to, it sort of begs the question, so why would they train them to do this calculation in the license exams? Are you saying, is this like part of the bamboozling that's going on or something?
Oh, dude.
They have to.
Go ahead. That's straw man shit, dude.
They're extrapolating. Yeah, they're extrapolating the WGS 84 model as in like the oblate spheroid model. So in order to fit this specific model, because they're working off of, it's almost like, let's say if you took away the Earth as a sphere, if you took that away, you would still be working with line of sight distances that the surveyors would be accounting for between point A and point B. They're not going to be accounting for curvature. It's not needed. Specifically for what they're going to be using them for.
So I just found it.
Do you agree with? I know, but do you agree with that?
I'm not sure I comprehended what you just said. I was reading through his DMs right here.
Dude, it's simple. I'm speaking English, and I think you're busy trying to figure out how to debunk what I'm saying versus accepting the very plain understanding.
I'm trying to refer to what he's told me and listen to you and contact about getting him in here, so you have to forgive me.
I don't see why. Do you think it's possible that he's going to tell you over, let's say, a couple miles that he's going to need the curvature of the Earth to be taken into account? Do you think that's going to happen?
Well, what he told me specifically is that all their GPS, which he GNSS, it's corrected orthometrically for elevations on every measurement that they make using a geoid ellipsoid model based on the globe.
Yeah.
So he doesn't account for it himself. The models are baked into the cake with the system that he's using.
Okay.
But on the licensing exam, they have to demonstrate understanding of how all that works. But now they have tools to simplify it.
Okay. So you just said you agreed with what I just said.
Okay.
Everything I said is exactly what you just told me that he said. Nothing different.
He doesn't understand. Okay. That's why it's not your fault. It's kind of esoteric, but they're making measurements, right? So you have lines of sight that are straight. So you have a triangle. That's just a regular triangle, but their coordinate system requires a curved surface because they have the celestial sphere, which the whole coordinate system, latitude and longitude, is based on. So they have this reference ellipsoid, which they're going to project these points onto, right? The actual measured points. They're going to put them onto another surface. The same way that you would scan a 3D model, right? So you have a 3D model in a video game that's just a wireframe. Well, where'd the texture come from? Well, you have to map the texture to the freaking wireframe, right? So this is what they're doing. They're basically mapping their measurements onto another surface.
Yep. It's that simple.
An imaginary surface called the WGS 84 reference ellipsoid.
Yes, exactly.
Why do they do that?
Well, the macro sense, and the macro sense, it's the Earth, taken into like the idea that you live on an oblate spheroid, so they can't just measure the curvature; they have to extrapolate it in a mathematical construct. So it's born out of that. It's not born out of a measurement system. They're not measuring the Earth anywhere. Surveyors do not do this practically. They're not practically measuring the curvature. Nobody does. They would tell you more something along the lines of, it's so minuscule, we don't need to take it into account, the curvature. And it sounds like an explanation that's added after the fact. So you're taking it as, well, of course the Earth's curving, but they're not taking it into consideration because it's so minuscule. But that's what they're telling you, although they're not.
But that's not what he said. He said
they are taking it into account.
He said they are taking it into account, and their tool has it's like automatically calibrates for it.
No, I know that. But you're not getting
the measurement, going from the measurement to the reduction. So they're taking the numbers that they measured. So they made an actual measurement, and they have data values. But they need these data values to go onto a reference ellipsoid. Their machine, right? Their theodolite, GNSS, GPS, whatever, right? It's doing the calculation for them, but it's just a calculation. It's not an actual measurement of the sphere.
Yep.
All right. So what's the problem?
They could literally presuppose any shape and map their measurements to that shape. Literally any shape. A duck.
So let me tell you.
Whatever.
Okay, but if they did that, like if they
Hold on, Big Tech. Let me just tell you, because I don't have too much time. So let me just tell you what this means. This actually means that when they're surveying the land, unbeknownst to you and probably shocker, is that they're measuring flat Earth. Because the reference plane that they're actually referencing is going to be mean across the plane. So when they're doing their planar surveying, they're extracting the raw data from their line of sight measurements. And when they're doing this, they're going to get that information. And then, of course, like you said, and I already understand, the instrument is already putting that calculation superimposed over that data measurement. Yeah. So they're measuring. I'm gonna say that they're measuring the Earth as flat.
Okay, and I know what you're going to say, Big Tech, is that if there was any shape, you'd have distortion. They're not using straight lines. This is why I brought up curved plumb lines. They're not using straight lines to project their measurements that they make onto a reference ellipsoid. They're curving that line.
Why would
not a straight right?
Why would they do
because it's not a ball, dude. What do you mean, why would they do that? Because it's not a fucking ball.
So they curve it because it's not a ball?
Well, it doesn't match. It doesn't match the sky ball. So when they do the measurements on the Earth, right, then they compare it like, hey, this star should be at zenith, but it's not at zenith. So gravity must be tilted here. But we can't have a tilted fucking plumb line because then we project it onto a reference ellipsoid, it's sideways and it has to intersect it at 90 degrees. So we're going to curve the plumb line so that the plumb line, it's like, say you had like your measurement surface and underneath it you drew a freaking circle, right? But your plumb line, instead of going straight down into the circle, it's tilted. Well, it has to intersect the circle at 90 degrees to do it right. Otherwise, the distances will be all fucked up. So the only way to do this correctly is to curve the line. So that you curve the line so that it intersects the ball that's underneath at 90 degrees. This is literally what they do. Now, the orthometric height, which you were talking about, so that is the reference ellipsoid with the EGM Earth gravitational model. So it'll automatically do all this plumb line curving in software.
So you're saying it's because the celestial sphere.
Correct the Mundo system. Let's
that's right.
What's your
wait.
I got a really good question. I got a big question.
No, hold on. Before you ask the question, because I'm about to head out. But unbeknownst to you, like you sound like a pretty okay dude. You know, you're not too dim with it, right? But if you're actually contemplating the fact that they're actually not measuring curvature, because this should be like alarm bells should be ringing. There should be red flags going up. You should be asking the very obvious question, why aren't they measuring curvature? Don't listen. Your mind is trying to do all these mental contortions to think about other things. And then you have a question in the hopper, I get it. But if you're not realizing the real reason why you should be asking why they're not measuring curvature that's going to stick out like a sore thumb every time. Now, you're going to ask everybody who thinks the Earth's a globe this question. How do you measure the surface of the Earth to be curving? Curvature measurements. Now, everybody's going to want to run to a different explanation or some kind of a theory. Stick to that question and ask them honestly and sincerely. You're going to get the answer every time. They don't know, or I'm not a scientist, or it's a calculation. It's never a measurement of the surface curving as an oblate spheroid. Anyway, I'm going to leave you with that, but because it sounds like you're not too far off from getting it. But
so my question is, what is a celestial sphere?
The sphere of infinite radius, the stars.
How do you measure that?
I mean, it's not our claim.
You're the one invoking the term.
Well, you're asking about surveying and how it's done, right? So I'm telling you what they do. So the celestial sphere is where the coordinate system is, latitude and longitude. It's actually not locations on the ground. This is easy to prove, and this is how you prove it. Try to find your latitude and longitude on a cloudy day. You fucking can't, right? Because you have no, you're hot mic'd alpha. So you can't find latitude and longitude if you can't see the star, the planets, the moon, right? They don't even have an existence. The coordinate system doesn't mean anything. That proves that the coordinate system, latitude and longitude, is in the sky. It's completely sky based. So,
right.
If we have
what is latitude derived off of? Latitude is derived off of the elevation of the planet.
Yes.
If if Polaris is 42 degrees in your sky, you're at 42 degrees latitude.
Yeah. It's circular, right? So
right.
It's not like it's measured on the ground at 42. You could, if you didn't see Polaris, you would never be able to find your 42 longitude.
Right, but
latitude, rather.
Latitude is all based off of your elevation angle to Polaris. If you're at 90 degrees latitude, Polaris is at 90 degrees. If you're at 27 degrees latitude, Polaris is at 27 degree elevation.
Yeah, and longitude is based upon where the sun is. So the sun is longitude and latitude is the celestial sphere, Polaris, basically. I mean, you can also
off latitude because the sun goes around Polaris east to west.
Yeah. I mean, well, it's a coordinate system, but the thing is, they map this coordinate system to the ground. So if we go someplace and we go, hey, I look in the almanac, the star is supposed to be at zenith. I set up my astrogeodetic theodolite, right? So it's a theodolite that looks up. I look through it, and then I center the frickin' star, and then I look at the instrument, and my instrument's tilted. It's not at zenith where it's supposed to be, and it's tilted in another direction. So what they say is the Earth is a sphere, but there's lumpy gravity deflecting my my theodolite in my level line. Right. This is the excuse. Okay.
This
has been around since the 1400s.
But celestial sphere, why is it a sphere?
Because that's how they imagine it to be. Because the model is of a sphere, is of a celestial sphere.
What model?
It's all due to perspective.
The astronomical model invented by the Babylonians in, I don't know, fucking 300 BC or something.
So it's a sphere.
Oh,
it's a spherical coordinate system. No, it's a spherical coordinate system.
Right, but you only ever see one half at any given time.
Why would we end up with a spherical coordinate system on a flat plane?
Because we can't see, because the stars we can see from anywhere. We can't, I can't set my coordinate system say I want my origin coordinates to be New York City. Well, if I'm in the Rocky Mountains, I can't see New York City. So how am I going to know where I am relative to New York City, where I can have a coordinate system based upon New York City? No, I need a coordinate system based upon some spatial reference that we can all see, right? So like I said, longitude, we all see the sun. So we're going to make a system based upon the sun, right? If I want to know how far east-west I am, if I want to know how far north-south I am, I'm going to base it upon some star in the sky. We've chosen Polaris. We could literally make any coordinate system we wanted using this. You need a spatial reference. So here's the funny thing, and like, I don't know if this will blow your mind or what. We have tried to make a coordinate system based on where the starting spatial reference is the ground. So there was, in 1927, they started what's called the North American Datum. So they surveyed, they started at a center point in America in Kansas, and then they surveyed without reference to the sky, except for the original coordinate, right? So the original coordinate, I think it's called Meade Ranch in Kansas. They did astrogeodetic surveying for 6 months to get its position in the celestial sphere coordinate system, and then they surveyed east to west, right? So that was our datum until they came up with a new one in 1983. When they made the 1983 one with the reference ellipsoid, which is completely based upon the International Terrestrial Reference System, which is based upon the celestial sphere and blah, blah, blah. When they compared the two, they didn't match. And in fact, there was like a systemic error. So if you start at like maybe the Ohio River Valley, right, there was no error. Like if you go east or north-south, right? So it's not a straight line. It's not like a longitude. It's kind of squiggly. But as you go east, everything is closer together than it should be. And then if you go west, and when I say closer together, means the further east you go, the more close together than it should be it gets. It doesn't like stay the same. It increases the error. So as you go west, they get further apart. That means all the distances, right? So it's not like, it's like stretching a rubber band, right? So close to where it starts stretching, it's stretched a little, but at the ends, it's stretched a lot. So this systemic error exists going from base, like I said, from the Ohio River out going west. So the point is when they used the ground as their spatial reference and compared it to using the sky as a spatial reference, they didn't match each other. And they've known this since the 1400s. It's not new. And I'll give you the reference for how we know they've known this. It's called Determination of the Figure of the Earth. It's a book. You can get it on archive.org, right? And it gives you the history, surveying, all the crap. Determination of the Figure of the Earth. It's exactly what it says. And all the different techniques and methods and errors and fuck-ups and all the problems they had, yada, yada, yada. But they've known since way back when, and the reason was they surveyed Italy or something, and they started at like the end of the boot, and then they surveyed up until like up the boot of fucking Italy. And then when they got there, and then they took their celestial coordinates, they were off by something like 1.5 miles or something. And they're like, what the fuck, you know? And back then they used chains and shit. So they knew the distances because they actually used a physical fucking chain to measure the distance. But the distance wasn't right. So this celestial sphere, it doesn't actually match the contours of the Earth, right? But this is hidden by interpolating data points. So when you do the double projection, the celestial sphere to the plane to the reference ellipsoid, the first one is a straight projection of rays. The next one are curved rays. So it's like one is a projection, the next one's a mapping. So a projection is a type of mapping, but it's not the only type of mapping. You can map one surface to any other arbitrary surface, but you just make some rule. And their rule is it's got to intersect the reference ellipsoid at a particular point to maintain the coordinate system. Now this seems like all fucking mumbo jumbo esoterica, and I guarantee the surveyor from X don't know any of this shit. I've talked to plenty of surveyors, and they don't know any of this shit. In my experience, surveyors are basically end users, right? They're like cab drivers, right? You wouldn't have a cab driver build a car. They know how to drive a car. They know how a car operates, all that shit. But they're like end users of the car, right? Like they don't really know how anything actually works. He might have taken a test, and he can do the formulas, the Haverside formula, sine, cosine. He might be able to find the orthometric height by subtracting the frickin' geoid from the reference ellipsoid, right? He might be able to find all that, which is actually simple addition and subtraction. I don't know who couldn't fucking find that. But the point is that if it's a globe, why don't they just go measure curvature? Why isn't it just straightforward? Just go out and measure curvature. Why does the books, the first books on geodesy, why are they like 2 volumes of total volume? There's like 1,700 fucking pages among 2 volumes, all fucking formulas. Like, why isn't it I just take a theodolite and I just do measurements and measure the curve and that's what it is? Why is there all these fudge factors? That's the elephant in the room, is why are there all these ad hoc fudge factors? Because they have a bias. They said, Earth's a globe because the sky's a globe and we have to make them fit. We're going to fucking do anything possible to make them fit together. And in case you weren't looking, I'll post it again. This is from a geodetic, I think it's called, where I got this from was, can't remember the name of the book. But see, if you look in the chat, right, Big Tech, if you look in the chat, the image I just posted, the diagram. If you drew horizontal lines along the actual plumb line, this dotted line is the plumb line. If you drew horizontals, like 90 degrees to this plumb line in a bunch of different spots, level would be in all sorts of different directions. And where it says ellipsoid normal, so if I set my theodolite like right there on the ellipsoid normal, that's where I should see the star right above me as zenith, but I'm actually seeing it away from that, or I'm tilted away from that where the star should be. And like I said, their excuse is, fucking lumpy gravity or whatever. There's no evidence or any of that. And have to say things, absurdities like plumb lines are curved. That's an absurdity. I dare you to build a fucking building thinking plumb lines are curved, dude. That shit will tip right over. That's probably how the frickin' Leaning Tower of Pisa was made. They're like, plumb lines are curved, build the Leaning Tower of Pisa.
What's the number on it?
Dude, you're unmuted, Alpha. See, and like, you know, all the shit we just did and all the crap we've been going through, the fucking down every rabbit hole, minutia. This is why people cling to the goal, because they don't want to, like, because the amount of effort it takes to examine it is beyond what they want to do. So they would rather just default to that because it's simpler. Just say, oh, this Earth's a globe, fuck it. I don't care. Fucking, I'll just believe the space pics. It's just easier. Too much baggage comes with flat Earth. You gotta care about truth and critical thinking and shit like that. Like you can't just like. It's not for the weak of heart.
I just heard back from my friend. He's on Discord. He's trying to join. He had his VPN on, and that's making him verify his email. And it said he tried too many times. So I don't think.
Oh yeah, that's okay.
You're introducing me to some new concept. I've never heard of. I mean, it's very interesting, this idea of a curved plumb and lumpy gravity, and that's all. It's all sort of wild. I'm not sure.
It is sort of wild. It is wild, but like, I mean, just think about it practically. Just like we as human beings, right, we could have said the Earth was anything. And we could sit here, we had 500 years, we could make mathematical models to make anything work. There's an arbitrary number of mathematical models that'll work for any number of arbitrary data sets. Like, it's not difficult. Like, we do this all the time. We do it in engineering primarily. Like, I'll put it this way. If you're an engineer, you'll make a model to get some result for your product, whatever. But, so they use models of, like, that time is flowing in a negative direction. They don't think any of that shit's real, but it works, right? Their model works, and it makes their fucking electronics work. So it's like, fine. It's only like in physics and science where they reify their models and think that their models are the reality. And this is actually, if you really want to go back, this is actually a philosophical viewpoint. So the viewpoint where you reify your model is Platonism, right? So it's a Platonic worldview, right? Where you presuppose that, the idealized forms exist in reality. These abstractions are actually real and shit. But because they work, right? Because if it didn't work, it wouldn't be real, right? So we say, oh, our model works, therefore that must be how nature is. I'm sure you've heard it. The mathematical universe and all this crap, right? That is actually a philosophical, metaphysical viewpoint, but they don't present it like that. I'd have no problem if a scientist says, well, it's not really real. But, I'm a Platonist, so that's how I think of it, as if, like, my mathematical model is reality. But they don't say that because it's just because they wouldn't get any funding. I mean, just to keep it real.
Can I ask you, I want to ask more questions about surveying, but also, I guess I should leave it as a follow-up question, because I asked how you measure the Earth is flat and you reference lasers. Is there any other one?
I mean,
the Earth is flat.
I mean, LiDAR. There's some LiDAR data, though I'd have to find it. I mean, people have done all sorts of... As far as direct measurement, lasers is really the only way that's been done as far as directly measuring it. There's other things which you could infer a flat Earth, which I wouldn't call direct measurement. So there's 10,000-mile radio transmissions, 800-mile frickin' chirped radio. There's NATO had a frickin' VHF system that frickin' went at 600 miles. That was just declassified like a month ago. So, like, there's all these other indicators. There's frickin' 340 kilometer Wi-Fi connections, 2.4 gigahertz microwave. I mean, long distance observations from fucking airplanes of 500 miles, of mountains, which would be like 11 miles under the curve of the earth. Like, there's lots of them, right? And that would be done in infrared. And then there's there's been tests done in multiple ways: visible light, infrared, mirrors, lasers, fucking microwave, radio wave.
So those are all light tests, actually.
Yeah, they're all electromagnetic radiation. Yeah.
So we're it's all basically inferring off of light, so like optics.
Yeah, but there's ships at the bottom of the sea, and there's plane wreckage right now, and there's dead people, based upon the idea that laser targeting, the laser goes straight, and that's where the bomb goes. Right. So as a practical matter, the military uses this technology. Pencil beam radar for the fucking, what is it? Mark 7 Sea Sparrow missiles, a pencil radar beam. So, like, we don't, as a practical matter, as far as we assume that they're going straight, we can hit fucking targets, right? So, and then there's actual testing. So they've done tests. One test was, so the Air Force wanted to know, they were trying to quantify Because the one thing about lasers that have fucked them up, targeting system, isn't refraction. I mean, it's refraction in a way, but it's not like the bendy around the curve refraction. It's turbulence. So it's basically turbulence or moving air or pockets of warm and cold air, right? So they're basically bubbles or pockets or what they call them inhomogeneities or discontinuities in the air will cause the laser to shimmer. You know, twinkle, twinkle, little star and all that shit. So they wanted to quantify this. So they did a 3 laser test from one Hawaiian island to the other, and they tried to pick it up in a telescope that was 3.4 meters wide. Well, if you use the model of refraction, because of this dispersion effect I was talking about earlier, the lasers, because there are 3 different frequencies, they should have been separated at the telescope by 20 meters, right? So the lowest laser should have been under the top laser 20 meters. But when they actually did this experiment, so the funny thing is they did the experiment first, and then, well, I should back up. So this experiment was done by the United States Air Force, Boeing, and the University of Dayton. 2 of the people from the University of Dayton were participating in the experiment and writing the results as part of their master's thesis, right? So they could get their degree. So they did the experiment. Then when he wrote his master's thesis, a guy that participated in it, they didn't do this beforehand. They did this after the fact. He did the calculation for refraction, how much the laser should have been separated, and realized this experiment should not have worked. If refraction was a thing, he used the U.S. standard model of refraction, 1976, U.S. standard atmosphere, modeled it all out, got the ray tracer, all that shit, said, hey, this beam should be 20 meters higher than this beam. This experiment should not have worked because the telescope's only 3 meters wide. How can you get a 20-meter stick through a 3-meter wide door? Right? It doesn't happen. But they did do the experiment. They picked up all 3 lasers in the telescope. They ran them through fiber optic cables, and they measured all the speckle pattern of all 3 lasers simultaneously. So they did the experiment, but they never thought, oh, we got to take refraction into account. If they did, they probably wouldn't have done the experiment. Probably would have fucked all up. Anyway, the point is that the idea that lasers aren't going straight, that's just an idea. The only time I've ever seen any experiment, right, any of these laser tests that have been done with the laser not going straight, it actually bent up, right? And the reason it bends up, and I actually saw this, I also saw this during, they had wildfires. They had forest fires in Singapore, in Malaysia. So a dude in Singapore was like, it was like a video on the internet. It wasn't a flat Earth video or anything like that. It was just a dude. He's just shining a fucking laser, like a blue laser, off his balcony, and the laser was going straight up. He was shining it horizontal, and it literally just did like a 45-degree angle.
Wrong.
Up. What do you mean wrong? What's wrong? Okay. Anyway, the point is that they've also done it at the Salton Sea. They like John Dees, who's he has a PhD in physics, teaches at the University of Brighton in the UK. He's done a bunch of tests. He got the same thing before he was a flat earther because he was doing like laser tests. So it's like there's a claim on the table that lasers bend down around the curve or whatever, dude. That's just like I said before. There's no evidence for that. There's no evidence lasers are bending around. Yeah, there are conditions where they can bend, but the thing is, you have to believe that it's the general case. You know what I mean? It's happening all the time. It isn't happening like one up. Otherwise, like flat earthers just happen to be going out under the perfect conditions every fucking time, right? Every time. Flat earth, oh, we're gonna do a laser test today. Good thing the weather's just fucking right. We can see over fucking 600 feet of curve. Good thing, because we did it last week. 2 weeks before, it was the same thing, even though the weather was completely different, even though we got the same result. So that's the thing. You have to you can't just make generalized claims. It has to be nuanced. The nuance is that you actually have to say that the general condition of nature is that when I shine a laser, it bends down around a curve. Not sometimes, all the time. And that there's or no, not that it bends down around the curve, that it bends around the curve and makes the Earth seem flat all the time. And that it never, whenever you take a laser out, it never shows any curvature, ever. Because there's no globe earther laser tests. I'm sure some globe earthers tried it. I remember, this is a few years ago now, we had a guy, he was a university professor at the University of Washington. He came into the Discord, the other one, and he said, hey, I'm going to get a couple guys from the university. We're going to go out and we're going to do some tests. And they're in Washington State, so I guess they can shine them across fucking Puget Sound or something. He never came back. But you think he's going to come back and say, oh, yeah, we measured it and the Earth was flat or fraction or something, right? They're never going to tell us if they go do a laser test. They'll tell us if they got the result they wanted, but they're never going to tell us if they get the contrary result.
Because they can't have the contrary result. They won't allow it. That'll be called a mess up or pseudoscience if they actually measure something. They call that pseudoscience. But if they hope and dream and calculate, then they're good to go. We're good.
I mean, do you really believe, Demok, or anybody, any flat earther in this chat, or anybody in this chat, that no glober ever has gone out and done a laser test in the last 10 years? Ever? Come on, man. One of them's tried it. Someone's tried it.
I bet a lot of people sillily like it. Builders, architects, and all kinds of people have tried all kinds of weird shit that wouldn't work, but would if you were on a ball. You see what I'm saying?
So big tech, check out. This is like the ultimate experiment. This isn't mine. This didn't come from me, so I can't take credit for it. And the person that came up with it, he's not around. I mean, he's alive, but he's not around anymore. So this is the experiment. You make a bathtub that's a mile long. So the top of this bathtub, right, from the bottom, right, the top curves the same way the Earth is supposed to curve, right, like 8 inches per mile squared. So the lip is not straight. The lip is curved, the lip of this bathtub. So what you do is you fill up this bathtub, and if water is conforming to gravity and forming a ball, then the water, when you fill it up, won't spill out. But if it's flat and the water's flat, when you fill it up, the water will spill up the sides before it reaches the top of the center, right? Because in the center, there'll be a hump. Right? So you'll never be able to fill it up to the top of the center. It'll always pour out the sides.
Yep.
Is there an image for this I'm supposed to look at?
Yeah, it's a cup.
No. I can post the video where the dude proposed it. But it's got a 3D graphic. No one's ever done this test. But this could be I think would be definitive. I mean, a mile might not be long enough to be definitive. They could just pull that lumpy gravity shit. So I don't know. That's a flat spot. I mean, I don't know how many times I heard that's a flat spot.
Well, you have the horizontal wall, and then you have the earth curve material inside the horizontal square that's perfectly horizontal, and you sit one in the other, then you fill the earth curve one up, right? And when that one doesn't work, you see the horizontal line versus the earth curve, so you can say, yes, this is not a horizontal line. In fact, it's the earth curve. And then when the water doesn't conform to it, you'll say, see, this water didn't conform, in fact, to that, and it, in fact, matches this horizontal as you fill the pool up afterwards and match the horizontal with it. And then it doesn't spill out. See, gravity doesn't need that fourth wall. You remember that fourth wall secret? That fourth wall in the aquarium? That 8-inch wall at the end?
The fourth wall, yeah.
Yeah, you don't need it. You only need 8 inches worth. Yeah, you don't need a fourth wall.
So hey, I posted a video. The video of that proposal for a test, which would actually be a final experiment. But so it's pretty cool. It only lasts like 4 minutes. But I disavow the cringy music and cringy narration. So a dude in the chat just asked Majan, I don't know if he's a flat earther or a glober, any reason why celestial navigation isn't at the forefront of your mind when citing flat earth proofs? Because it doesn't prove anything fundamentally, because it's inferential, just like the sun. Looking up, dude, is the wrong direction. Any conclusion you reach would just be inference, like a inductive inference. So it won't prove anything, and you just have a bunch of affirming consequence. I mean, I could bring some up. The navigation without the celestial sphere. So it was reported by the Royal Meteorological Society that there was a dust storm across the Atlantic that covered nearly the entire Atlantic, and no sea captain could see the sky or even the horizon. The entire Atlantic was covered in fine powdery dust. So the HMS Britain navigated, by dead reckoning, 2,000 miles. Now, if the Earth was a globe, this would be impossible, because that's dead reckoning uses planar triangles. And if you had a bunch of planar triangles, you tried to navigate on a curved surface, you'd end up fucking lost. You couldn't get to where you wanted to go. You would have to use spherical triangles. There's no way you could use it. If the distance was short, I'd say, hey, no problem. But if you look in any nautical instructions or motorboating, whatever, it says, yeah, you can use dead reckoning. But if you use it for more than 300 miles, you're going to get lost, because the Earth's a globe. Well, how do you do it for 2,000 miles?
Earlier, India, I don't know if you were listening or not, or if you were in the chat, but our friend here, what's his name?
Some friend you know, you don't even know his name.
Big Chum or something like that. He was saying when they do their surveying, right, they apply the formula to account for the Earth curvature, and they get the correct distances between 2 points. And asked, how do they know the distance? He said, well, they measure it out with a wheel, whatever, you know.
Wheel?
So really? Argument. Okay, so that confirms that applying the radius value to your measurements is correct, because you get the correct distance. And I said, compared to what? But anyway.
Wouldn't the ground have to be pretty smooth for your little wheel to work?
You got all this topography, right?
Yeah,
so
dude. Like, what? A wheel? Dude, like, you know how they got like the measuring things for like football fields and shit, where they measure out the lines? They got their little wheel. Like, is that what he's talking about? They got a little freaking.
I think so. Yeah, I
was being a bit pedantic with that answer, but I mean, like, we could get sophisticated. We could triangulate. We could secure the distance between the base of an object and the measuring point of the theodolite, right? And then if it's
need to know something first, like if you just got an angle, then you can't figure out height or distance. You need a distance or a height.
So what we would do is, angle. So if we were, if we established, level plumb at one point and the other, and we had a vertical object, let's say it's a tower, it's like a couple 100 feet tall. and the tower is 3 miles from my location. I have a vantage point on the base and the top. I'm going to expect one distance at the base and one distance at the top if the Earth's flat, and then I'm going to expect a different distance if the Earth's curved, because that perfectly plumb vertical tall tower is going to be tilted away from me if it's curved. You follow?
We follow, but like, okay. See, the thing is, we have to. We'll always come back to this. Things get compressed in the distance. So as you look further through more and more air, objects get compressed vertically, and like it's like you guys say, oh, some made up flat Earth or bullshit. No, it's not. Something called flattening of the sun. When the sun sets, it appears to flatten and turn into a line. Right. So this is observed all the time.
It's refraction.
Well, I mean refraction, but that's not But it's not. Look, I think you misunderstand when I rail on refraction. Yes, there's refraction in the air. No, it don't work the way y'all think. It don't work bending shit over the curve as a spherically symmetric atmosphere. It don't work like that in reality.
It squishes and widens as it goes through the denser layers of the atmosphere when it gets low.
Yeah, I mean, squishes and widens, but the air isn't like that. That's the thing. The air isn't just a gradient. There's pockets of air. That's like, this is what you guys like aren't comprehend. Why do the stars twinkle? Think about it. Why do the stars twinkle? Why do they say the stars twinkle? Because there's turbulence in the air.
Yeah, it's turbulence in the air. Yeah.
Yeah, because you're looking through discontinuities, as I would call it, or inhomogeneities of the air.
But so say you'll have the sun. Because the sun only gets squished at the last moment.
It's wibbling and wobbling. It's not uniformly curving. It's wibbling and wobbling, right?
But the sun stays nice and perfectly round until it gets right at the horizon, then it squishes because it's going through a dense gradient of atmosphere. That's the idea.
Okay, that's no. It's not the density of the gradient. It's that where you're going to have the most amount of convection is going to be near the surface of the Earth. So you're going to have the most amount of turbulent air. No, because it's not density as in like spherically symmetric, where it's just a vertical density. The density is also going to be horizontal. This is what you guys aren't getting. There is a horizontal. It's not a gradient. It's random fucking pockets of air. This is in the literature, you know. This is in the peer-reviewed academic literature for surveying and everything, dude. It's in the literature.
No, I'm not disputing that. I'm just saying when I watch the sun go down over the coast, I'm in California. I've seen it 100 times over the West Coast. It right at the last moments, it gets all contorted. Not until then, though.
Yeah, but in your model, you're not even looking at the sun. You realize that you're not even looking at the sun in the globe model.
It's not even there.
Do you realize that you're not even seeing the sun?
Well, yeah, in the last moments, yeah, exactly.
No,
it slows down.
Way before that.
Okay, fine. Yeah, well, the light's
so the sun is supposed to be like when the top of the sun, right? Say the top of the sun, where you can see the sun, touches the horizon. The sun is supposed to be 0.83 degrees under the horizon, which is bigger than the sun. But that's bigger than the sun.
Okay.
Right. So that's a sun and a half. Right. So when you see the sun at the horizon, the sun's not there. The sun's under the horizon already. You're seeing the projected image of the sun up around a spherically symmetric Earth caused by a spherically symmetric density gradient.
Yeah.
That's absurd.
Why?
Okay, because you would see other optical effects. You would see dispersion. You would see magnification. You would see shit getting smaller, shit getting bigger, not just swishing into a line.
It also gets bigger.
Well, I mean, every glober's been saying the sun doesn't change angular size at fucking sunset for, I don't know how long now.
Well, it doesn't change angular size in the way that you would expect if it was going far away. That's what we're saying.
Oh, okay. No, they say it doesn't change at all.
Well,
which is horseshit, because that's actual horseshit. It actually does shrink. But anyway, All the whenever some Globers posted a video saying, "Hey, why doesn't just fucking change an angle or size of this video?" Then I go in the video and I freaking measure the pixels. It does, like every time. So before we got off on the sun, Steve, there's more evidence of this vertical compression than just the sun, right? So there's a couple of pictures that have been taken, right? So one is across taken in infrared. So it's infrared. They take a picture across the Gulf. It's called the Gulf of Leon, 140 something miles to this mountain called Mount Ventoux. They took a picture in visible light. They take a picture in infrared. You can see in visible light, the mountain is compressed compared to the picture in infrared. Then on top of that, right? On top of that, you can see features on the seashore. Specifically, there's windmills, right? A row of like 20 windmills. And you can go onto a Google Earth or Google Maps or whatever, right? And you can say, hey, from one end, from this viewpoint, the windmill farthest on the left, the farthest on the right. You take you take the radius of the circle. You say, okay, what angle is this, right? So this distance between these two should subtend, like fucking say half a degree. How many pixels? Count the pixels. Oh, it's 200 pixels. And then you can take that, right, that distance, that pixel distance, and then you compare it to the vertical. There's something like a 15% difference, right? So if you take, this is a mile horizontal, is 200 pixels, and then I flip it and go, well, 200 pixels should be a mile vertical. Well, they're not. Then when you look at the mountain, like this mountain isn't even a mile tall. Like why? Like this is not a mile. It's not an equivalent, right? So that's the point. We know from other reasons, right? Other things other than just the sun, that things get compressed in the distance. And that's not consistent with a spherically symmetric atmosphere either. And that's just one off the top of my head. The other one is San Jacinto. So San Jacinto is a 137-mile observation in infrared. And then if you take the picture in visible light, you can't even see the mountain at all. Whip out the infrared, boom, there it is, right? And if you measure, there's a bunch of different peaks all around. And if you measure the vertical versus the horizontal, it doesn't match. Like that's off by 10%. And even on the same mountain, it isn't even consistent on the same mountain. So we know things get vertically compressed just from the air. But it isn't because things are being lifted up over the curve of the earth. That's something that's like that claim. There's no evidence for that. There's no even in the literature, like you can look at the academic literature, like there's nothing. It's just like shit they put in textbooks, right? They put in textbooks, they put it on websites. But if you look at the literature, it doesn't say any of that shit. The only way you'll find any reference to it is like in astronomical journals where they have their models for how far stars are displaced because of refraction. And like that's just a consequence of the model. It actually goes infinite at frickin' 90 degrees.
India.
When I say 90 degrees, oh yeah, go ahead. Sorry, I was fucking ranting forever, dude.
So if you were gonna make an easterly path, and come back to the same point, what kind of shape would that path have to be?
What?
So,
if I was going to make any path and come back to the same point,
like an easterly or westerly path, and you arrive at the same point.
Yeah, I mean, depends on what your spatial reference is. Depends on what you're using as your spatial reference.
And in this case, we're just like imagining that you have a central point, and that every single you have to make a consistent 90-degree angle to that point, all the way consistently. That's what consistent means here in this context. All the way around, back to the same point you were at. I can only imagine there's one shape that would fit that description. And that would be a circle, right?
Yeah, a circle.
And if if that's possible, all the way from the Drake's Passage to, I don't know, like Greenland, North Pole, or whatever, then to me that sounds like the known world can only be described as circular, right? The known world.
Not necessarily, dude. Not necessarily true. I'm not actually one of the people that believes that Earth is necessarily symmetric with the celestial sphere. I'm not even convinced it's a celestial sphere, quite honestly, because of the declination of the magnetic declination, right? So you get a compass and it doesn't match the celestial sphere.
Yeah, but I can't imagine what else it would be if that path always has to take the form of a circle, and it will always be consistent from Drake's Passage to the North Pole. I mean, it only sounds like between those 2 points can only be described as circular.
Hey, sorry to interrupt, but my buddy who's the surveyor made his way into the server, and he can see the VC, but he can't join. It says it's locked for him. Do you know what he needs to do?
He probably needs to pick a role, maybe, or something like that.
Is there a mod in here who can?
Or there might not be. He might not it might. Well, listen. He might have to be here a certain amount of time. I don't know.
Right.
Has he got his?
We're mods, but we're only mods in this chat. We're not mods on the server. I don't come to this server super often, so I don't fucking know how shit operates over here.
Can he type in the text chat and stuff like that?
Let me see. It's just literally it's his first day.
Heretic is here, so Heretic knows what's up. Ask him.
If you can't,
Heretic's in text chat, so you have to talk to him in there.
If you can't type in chat, it might be that he's not mobile phone verified, which you have to be.
Needs rank 2 is the word on the street. I don't know what that means.
He's on PC, and he had to put in his email to register. Rank 2.
He needs rank 2 to talk in this chat, so he's probably got to go spam some text channel.
Okay.
I don't mean literally spam. Don't do that. Probably get kicked out of here.
I think you can also sit in one of the public VCs, and that'll get your rank up as well.
Oh, I don't know how that shit works, dude.
Anyway, before he gets here, which will be imminent, I imagine, right? I can only imagine that sort of relationship could be described as a circle from between those 2 points everywhere on the surface of the Earth for every person.
Yeah, if you have a central point and you freaking keep it 90 degrees from you have to trace a circle. I mean, that's not really mysterious.
Now,
assuming you're equidistant, right? I mean,
yeah. So I don't mind where that central point is. It could be Antarctica, Brazil, wherever, right? But all I wanted to establish that this would have to take some sort of form of a perfect circle for the known world. Whatever is beyond that point could be rectangular, triangle, whatever you want, right? Now, the next stage is if the known world is going to take some sort of circular dimension to allow for bearings, easterly, westerly direction to the same point, then I imagine that the only way, and this is going to sound similar to a previous argument I made, the only way Earth could be configured in terms of its land masses is radially, right?
Relatively asymmetric.
I mean, that preserves the most amounts of distances between land masses.
I mean, how do you know the distances?
Oh, flight
This is a recurring problem. Don't ask me, you don't think we can measure distances? Because it's a typical response. I go, how do we know the distances? You don't think we can measure distances? Well, we don't.
Yeah, okay. Well,
we don't, right? So we have a radius, right? We go, okay, I'm at this latitude longitude, I'm at this latitude longitude, do the Habersign calculation. Oh, I'm 2,000 miles apart. You don't know you're 2,000 miles apart.
Okay, right.
Right? Well, you don't really know that, right?
That's fine, because if you're going to take the position that we don't know distances, the distances may
You don't, dude. It's not. This is objectively true. It's not like my opinion.
Yeah, that's fine. I actually
who measured from New York to France?
It doesn't matter. Like, I agree that distances may be incorrect, right? But on that basis alone, okay, so it's different. I've got to go down the whole thing because I expect someone to say yes. We do know that there's a similar path between South Africa and Chile as there is between Europe and Central America, right? And that flight paths confirm that, and shipping confirms that, and all those sorts of things confirm.
Yeah, that's cherry picking shit, though.
It's just an example.
When you say flight paths confirm it, how do they confirm it?
Well,
when they projected a spherical coordinate system onto a freaking Mercator map, was that the confirmation?
Forget projections of the Earth. It's just the idea that
how did they confirm it?
Traveling at the same speed will be able to reach different locations at similar times, right?
Okay, and if they turn around and they go in the other direction, what happens?
It might knock an hour off or so.
Dude, the differences are huge.
What, between North America and Europe?
So, okay, say the Sydney to Santiago flight. It's 11 hours 45 in one direction and 15 hours in the other direction. But if you look at the bigger values, right? So the lowest I've ever seen the Sydney Santiago in one direction was something like 11 hours and 30 minutes. But the other way was like 17 hours and fucking 50 minutes or something.
Yeah, but
right. So that's a huge difference, dude. And if you're going to infer your distance based upon the speed, right? Speed and time, then you're like, what the fuck, dude? This is a huge difference. How far are they apart? But then there's other factors, right? You can't just use the time because when you're taxiing in on a runway, your orientation relative to the runway, right? So you have your approach, right? It's not like there's it takes 30 minutes to approach at every fucking airport. Some is 20 minutes, some is 10 minutes, some is fucking hour and 15 minutes. You can't. This is not a legitimate method to get a distance.
Okay, right. I'm just gonna skip past this because I know this guy's gonna join soon, so I want to get to the crux of what my argument is, right? So, first of all, with the Haversine formula and GPS and knowing distances between landmasses, I have a friend who knows more about that. I don't think I'm the best situated to do that, but my argument basically says that with the circular Earth and the radial landmasses and distances that are known, you're forced into a contradiction based on what you're the first flat earther who's denied that we know distances between landmasses, like I spoke to you so far, right? But most of them do say.
I've also deny radial landmass. That's shit too.
Well, I mean, it preserves the most. It doesn't have to be, but it would preserve the most distances, right? Which is what I'm trying to I'm trying to give flat earth the best.
No. The only thing you're trying to preserve is a celestial sphere. That's literally the only thing you're trying to preserve.
Ignore celestial sphere. All I'm saying is that
how do you know the Earth's landmasses are radial? How did you come to that conclusion? You can't come to that conclusion from the compass readings. Yeah. You can't come to that conclusion from the motion of the sun. So how did you come to the conclusion that the landmasses are radial?
But if the Earth is circular, right, and we can get... Well, hold on. If the Earth is circular...
If you come to that conclusion.
We did that at the beginning with the bearings, right? Being able to go around in a circular path, right?
Yeah, but that was a hypothetical. But that doesn't mean that the Earth is circle, because in some hypothetical situation you could do that.
Yeah, but that's fine. It doesn't mean that. But I'm gonna get to the point, right, very quickly. So if that's the case, that bearings have to follow a circular path, which I think they do, and from Drake's Passage to the North Pole, that's true for everyone everywhere, that they can make this circular path. Then if you're imagining Earth now as a circle, the only sort of configuration of that circle of the known Earth, at least, would have to be radial to preserve the most distances. It can't be any other way, otherwise you're going to have big swathes of water when you're going in your easterly direction. You don't touch a landmass for an absurd amount of time, which would make it even more dumber, right? So I'm trying to make the most sense with radial, right? And then what happens from there is that you're forced into a contradiction, which is that either
bearings.
Go on.
Sorry.
I'm about to land it. Either so this.
No, he was hot mic. That was a problem.
Yeah, no worries. So this is the where I land it, which is that if distances are consistent and coherent, then bearings must be incoherent, and then if bearings are coherent, then distances would be inconsistent and incoherent. And by reductio ad absurdum, the Earth cannot be flat. That assumes, obviously, that you acknowledge that there's only one path. Just to wrap it up, there's only one path that an easterly or westerly direction could take all the way to the same point, which would be a perfect circle, and that could be true for anyone from Drake's Passage to the North Pole, and that we know our distances, which you would need someone who can do the whole Haversine formula, GPS, and flight paths, and so on argument. But that's the argument.
Okay, I don't know how you got from bearings to Earth can't be flat. I don't get that part.
So it sets up a true dichotomy, which is that
I don't understand the logical connection between your bearing and the shape of the Earth.
So, okay, the bearing is just to establish that there's only one type of shape that the Earth could be, right? Like the known Earth.
Yeah, but by bearing you mean north, south, east, west, right?
The two cardinal directions, north and south, and then a 90-degree angle off north, being your bearing, easterly, westerly direction.
Okay. So, the cardinal direction. But it all comes back in what coordinate system? That's what it always is.
Yeah,
there's three sets of cardinal directions.
Yeah, but in this sense...
Which one are we using?
You're using, just say north for simplicity's sake.
Yeah, in what coordinate system?
Off north. Does it matter?
In what coordinate system? It does matter.
Why would it matter?
Okay, because north, east, west, and south on a compass are not the same as in the celestial sphere, latitude and longitude, which is also not the same as the sun. And it's easy to show this. You can go on time and date, look at the sunrise on the equinox, 2 locations, Greenland and Tierra del Fuego, and look at the sunrise direction, right? It's not 90 degrees. It's 91 and like 86, right? Yeah, it's not 90 degrees to north on the equinox, okay? But east is defined, if you look up east in the Oxford Dictionary, it's defined as the direction the sun rises on the equinox. If you go on Google Earth and try to draw a line east, right? What you'll see is the east line will actually deviate from the latitude and longitude east and try to intersect with the equator. So, and that's just that. That's just the sun's cardinal directions. That's one set. Then if I whip out the compass, then it's all over the fucking place. Yeah. Then I'm in the east, and then I'm in the South Pacific looking at my compass thinking I'm going north, and I'm going fucking east.
Yeah. So
there's three sets of cardinal directions. When you say, hey, man, our bearing will tell us the Earth is not flat. What? Like, I don't get it, man, because your bearing depends on what coordinate system you're in.
It doesn't do that. The only thing that the bearing part of the argument is supposed to establish is, one, that
direction,
the sort of direction, obviously, like direction of travel, being able to go to the same point if you're going in a consistent easterly direction, 90-degree angle from north consistently. And so to be able to return to the same point, basically circumnavigation, right? And then the other point is that it establishes or eliminates a lot of different shapes a known Earth can be. And then when it eliminates that, it can establish what we can move on to what kind of configuration the landmasses on Earth must take to preserve the most distances. And even still, with all of those things, you arrive at a contradiction that that can be used in a reductio to basically flatten flat Earth.
Well, I'm not following the logic, quite honestly. I'm gonna be honest.
I'll write out.
Yeah, that would be better. Because I'm not following like how you get from the premises to the conclusion, like how that can't be a flat Earth by reductio. I mean, I'm not seeing it. But, I mean, it could just be because it's late and my brain's kind of fucking fried from being on here for 3 hours.
Yeah, no worries. Is that new guy got here yet, or? Big Tech?
Yeah, I think he. I mean, but he's working out his voice connections.
Yeah, Discord, especially the first time, the voice can be a pain in the ass setting up your mic.
Yep, that's what he's doing.
So that gives me a good segue to. I'll be back in like 5 minutes.
All right.
Anybody else want to jump in the fucking fire, dude? Feel free.
So what was your globe proof, Big Tech? I guess he doesn't have any.
Sorry, I was just I was deafened for a second on my side, but I heard my name at the last split second when I undeafened. Did I miss something?
Yeah, so what was your globe proof?
Oh, I was presenting the idea that surveyors, when measuring distances, factor in a curve correction equation. And if that's true and their projects are being built true, meaning that they're working out and not failing, then that is a test that we could then say verifies the radius value, because the radius value is part of the equation. And if the radius value is anything other than the correct radius, then their projects would fail. That was my idea.
I see. So you're a globe prover, not a flat earth falsifier.
Right. That's what everybody's been saying. Stop trying to debunk us, show us some proof. So I thought I found some. Thought I'd bring it in.
The thing is, like, with proving the globe, in my view, is because it's always like confirmation. So it's, you got this other evidence you're going to add to the pile and whatever. You never actually, establish without a shadow, with absolute certainty that the Earth's a sphere. There's always that slight possibility it could be some other alien object. Obviously,
well, that's why I thought mine was good, because if this works in every direction, if the curve correction formula is working in their projects and they do it in any direction, any cardinal direction, any azimuthal angle, if it works at 360 degrees continually, then that makes a sphere. It can't be anything other than a sphere.
Yeah. No, that's true, but I don't think that data exists, right? So there's always ways out, right? On that basis, for me, the only thing that you can do is absolutely eliminate a possibility, right? Rather than absolutely confirm the globe. And so I'm more of a flat earth disprover.
Mm. Yeah, for me, I've always it's fun to try to find the smoking gun. I was looking at Coriolis effect with snipers and things like this last week, and this week I'm looking at the surveyors. But it seems to me that the case is that we have a preponderance of evidence rather than just one. I mean, the one that would be the perfect one would be that we can take a picture of it from 1 million miles away and it's a globe, and we have that. But then we have to, of course, we can always call into question the credibility of an image. So that doesn't work, and we all can't just go into spaces. We can't just go up in elevation high enough to see it ourselves. So absent that as an option, what we're looking at is piecing together evidence on the ground. And what it seems to me is that we have like this big old basket full of tons of corroborating evidences. And then we paint a picture of like, okay, since all of these things, A, B, C, D, all the way through Z, then therefore we can infer that what we are in fact dealing with is a globe. And then maybe also we can trust those images that reify that story we're telling ourselves. But what I find when I talk to a flat earther, they're like, okay, give me one thing that's absolute as a physical measurement. How did you measure the curve physically? Did you like stretch out a chain over the ocean and then measure the angle of or something? It's like, oh, how would I do that? And they go, aha, you can't. And I go, shit, you kind of got me. So then I have to appeal to all sorts of, all right, well, here's the maths and here's the optics and here's the, here's the weather patterns. Here's the way that the bullet deflects. It seems to be rotating. Oh, it could be something else though that's causing that. Like, oh shit. So every
it's funny how you guys interpret our point. I just think it's interesting how you interpret what our arguments are, and they're not our actual arguments. So the problem with images isn't that they could be faked or anything like that. Fundamentally, they're not testable.
Well, isn't that two ways of saying the same thing? Distinction without a difference?
No.
Like the problem with them not being testable is that they could be faked.
Look, they could be real photographs, but they're not photographs of what they purport to show. Okay, and I'll give you an example. I make a painting of a globe, and I take a photograph. I have a real photograph. It's 100% real photograph.
Gotcha. Right. Gotcha.
Okay? So we know from hyper-realistic painting, we know from hyper-realistic painting that people do. I can show you right now.
But that's just
pictures
another way of
people
saying
painted that look like photographs, but are not photographs.
Yeah, but you just told me just another method of faking.
But it's not faking. It's a real photograph.
Yeah,
it's miscaption, right? It's miscaption.
Right.
Oh,
exactly.
So lying. So the evidence that it's authentic is the word of a person,
right?
Which is also not testable,
right? Yeah. So we're discounting testimony. We're
nobody has ever testified the Earth is a globe, ever.
I think testimony is the weakest.
Okay.
So
but nobody's ever testified that nobody has ever swore under the penalty of perjury that the Earth's a globe. Period. Ever.
Okay, that's sworn. That's sworn test. That's sworn.
Well,
testimony.
sacrifice is the measure of credibility, dude. If there's nothing, anybody can say anything if there's no penalty for lying.
I think, there's not been a situation.
There has to be a penalty for lying for your word to mean
So
anything.
this is one of the things I find interesting is sometimes I talk to flat earthers and they say, we're not making any claims, but the inherent claim is you are claiming that all these people are lying.
Who's these people?
These people who say that the Earth is a globe.
No, they don't know. They don't know anything. They just, like all fucking 27 of them? Yeah, all 27 Apollo astronauts are lying. I'll say it.
No, not just the Apollo. I mean, all the
No, they're the only ones that No, they don't see the Earth as a globe. They're not high enough. Yeah, what? How much of the Earth how much of the... Okay, so when Chris Hadfield went on ABC, Good Morning America, and said, the Earth looks flat and beautiful, was he telling the truth or lying?
I don't know. So you're saying, I don't know what you're talking about.
He went on ABC and said, the Earth looks flat and beautiful from the ISS.
Okay. Do you think that means he was saying that the Earth doesn't look like a sphere to him?
Yes. Because it shouldn't.
So you think that astronaut...
Because it shouldn't, dude. It shouldn't. It's not high enough.
Okay.
Do you not understand not high enough? The ISS, from its altitude, would only see 3% of the Earth's surface area. That's if you could see the entire circle, right? From where you are, right? If you could see the whole 360-degree view, that would be 3%. But you don't see that. You're only going to see whatever your field of view is. Some small subsection, some small fraction of that. So what do you see the Earth? 1% of the Earth? 0.5% of the Earth? Think about it for a second.
So let me ask you this.
And then if you just do the math, you can just do the math.
Well, wait. Do you think that they are actually going up to a space station that's flying around in the sky?
No.
So you think they're lying about that too?
Yes.
So you think they're lying about going to the space station, but telling the truth that it looked flat from there?
No, what I'm saying is...
We got the echo going again. You might have to rejoin. I know you can't.
Yeah, no, it's... Yeah.
So it doesn't make sense to me that an astronaut would lie about going to the space station, but then he would on the news say it looked flat from up there. Like what are we doing? What's going on?
Hostile witnesses.
Sorry?
He's using it in the sense of a hostile witness. So it's like someone from your side saying, so now you're going to have conflicting statements from people on your own side. That's all it's doing. It's not some kind of argument for for a pro position that he has, right? For the Earth being flat. He's discussing what you're saying astronauts and other people are saying about having viewed the Earth from space. And there's actually a couple. There's actually maybe 3 or 4 that they've made statements similar to that, right?
Yeah.
Inside, so it's like...
So if they're part of an elaborate scheme to fool us into thinking that there's a space station up there, why would they then come down and do an interview and say it looked flat from up there?
Look, dude, you don't understand. Like, you're not getting it. You said... We have all this testimony from these people that said the Earth looks round.
Right.
You don't have actually any evidence of that because when I've heard them talk, they say it looks flat. The reason you think they would say that, despite not ever hearing them say that, is because you've seen images. So the images you saw, you drew the conclusion that they would say, hey, I saw the Earth from ISS and it looks round.
Wait, so you're saying that when these fake astronauts who don't go to the ISS do interviews, they tell us that the Earth's flat?
Look, they have to maintain the story. If they look at the mathematics, it says, hey, from 250 miles up, it has to look flat. They can't say it looks round because that's not high enough.
So,
because it's a provable lie. If they said, yes, I saw Earth curve from ISS, it's a provable fucking lie, dude. That's not possible. Because, okay, the Earth's supposed to be 8,000 miles in diameter. They're claiming they're 250 miles above it. Right? That's 1/32 of the diameter. They're barely above it.
I'd like to see that video. I just so I could examine it for myself and see what you're talking about. Do you happen to have that? I'm not calling. I
got a screenshot of him saying it. I mean,
I'd like
do I have the video to Good Morning America? I mean,
yeah, it's always like in context.
You'll probably find it.
Yeah, what's his name?
Oh, I did have it on my old SD card. I don't have it on this one. Damn it.
Good.
Yeah. Sorry, I did.
Sorry, you spoke at the same time.
Wait,
what was
I might
the
be
name
able
of
to
this guy?
find it in the home server.
His name is
Chris Hatfield.
Isn't that the singer from Metallica?
Oh wait, I think I've got it saved.
No, that's James Hatfield.
YouTube list.
James Hatfield. Good morning.
Not James Hatfield. James Hatfield's from Metallica. Chris Hatfield is the astronaut. Hatfield, something like that. Anyway, you'll get all sorts of different stories from these so-called witnesses. That's our point. They're not reliable witnesses. And are they lying? Of course they're fucking lying. Now, maybe they went up onto something. I don't know. Who cares? I'm not basing my worldview on the claims of 600 fucking people when there's fucking 9 billion people on the goddamn planet. That's like relying on a bunch of priests in the Vatican.
Yes. Well,
more people claim they've seen fucking aliens. And you realize that there's in 1 year more people will claim to have seen fucking aliens than claim in all of human history to have seen the Earth as a ball.
I find it tiresome when there's a thing. I'm sure you could probably maybe put yourself in my shoes, but when I talk to flat earthers, many times the conversation veers into this meta of like, here's how you should think about this. You're thinking this, and you should think this way. it's like trying to get me to like reframe my psychology in order to be able to, see your worldview.
No,
I get it.
You're just not thinking critically about it.
Right, exactly. You're trying to make me think critically, and
not make you.
You're saying that I'm not, and you're trying to persuade
Well,
me
yeah,
into a more
because
critical
if you think about the consequences, the logical consequences of basing your worldview off the word, your perceived word, that there's 600 eyewitnesses to around Earth, and that's where you're gonna stick your eggs are going in that basket. Yeah, the 600 people, they swear to God. Well, they didn't swear to God. They went on TV and said that they saw a ball Earth. I'm going to believe them. I'm going to reject my own experience and the experience of the other 9 billion people on Earth. And when I say 600, I mean 600 over a period of like, what is it, 60 years now, 70 years? It's not like it's 600 people today. 600 people over a long period of time, right?
600 people did what?
Claim to have been to outer space.
Oh, so they're all lying.
Yeah, all of them.
Okay. Yeah, so you believe that they're
just
all
like
lying.
The 10,000 people that claim they saw aliens. They're all lying too.
Well,
I don't need to disprove all 10,000 people wrong.
I've seen aliens, but I don't know if that was real.
God!
I could tell you my story.
Was it on the southern border, like those kind of aliens?
No, I was on LSD and I had a very bizarre experience.
Oh, Jesus Christ! Dad, what? How do you know you're not on LSD now?
Well, that's what I'm saying. I can't say that was real, but I can tell you what I saw. That's all. But it wouldn't be a lie if I told you the story. It would be a real story that was of a hallucination, potentially.
Maybe.
But yeah.
But you see my point, right? It's like they're making a fantastic claim. They don't get auto belief because they're saying, hey, we went to a place where physics is totally different and we float around and when I let something go, it don't fall to the ground. And, it's a fucking near fucking infinite vacuum, blah, blah, blah. They make this crazy, fantastic claim, right?
Yeah, see that.
I'm not required to believe that without like very good evidence. And just I said so isn't good enough.
Yeah, I don't.
I mean, it might be good enough for you, but
yeah, it's good
I
enough
have
for
the
me.
feeling
I don't
you
think that was
want
a
to
good
believe
faith
this.
framing. Even the way you said it, like, physics works all different. It doesn't. It's like
it does.
What part of physics works different up there? I'm not
the physics that you experience, right? When you let, okay, when I'm talking about the physics you experience, when you let something go. Oh, go ahead, T-Dub. Sorry.
Just letting you know, I found a short clip of that interview where he actually says that, and it's just clipped out 12 seconds. I don't know. From there, you could find out the information you need to watch the whole interview. Sorry, continue on.
Cool, perfect.
Okay, so what I'm saying is the physics that you and everyone you've ever met and everyone they've ever met experiences, right? It's things like when I let something go, it falls to the ground. That don't happen there. They're saying that this is a special place where that don't happen. Contrary to the experience of every human being who's ever fucking lived. They're saying they had a special experience that was different than that.
Well, we can recreate.
How is that not a fantastic claim?
We can recreate that experience in parabolic airplanes.
No, the object is falling.
Well, so is the ISS.
You're just. I mean, that's the claim, right?
Right. That's what.
It's not in a parabolic airplane, we know the airplane is just falling. So you could take the airplane away and let something go. Or if the plane was transparent, right? It wouldn't be floating. You would see that you're falling with the plane. It's not floating, right? So
my point is the physics aren't different. The physics are the same. It's just to a different degree. It's just scaled up.
I'm talking about in the experiential way. Yes, you can create a scenario where the physics is fucking consistent with the physics that you experience on Earth because you created some imaginary fucking framework from which, yes, this is what we would observe. But the point is, for all of human history, when you let something go, it falls to the fucking ground. Okay? Where they go, it doesn't happen. But there's other problems. That's not just it. That's just one. The other problem is there's material, right? Supposedly, where they are, That's 250 degrees Fahrenheit on one side and negative 250 degrees Fahrenheit on the other side.
Okay, I just listened to the Chris Hadfield thing, and I can't even believe that you're saying that he was saying the world looks flat. He's talking about photography, and he said it's flat gorgeous. That's an expression. That's a turn of phrase. Like
flat and gorgeous.
Let me hear that again.
Flat gorgeous.
Listen closely.
Yeah, it's flat and gorgeous, dude. I just listened to it again.
No, he says it's just flat gorgeous to see.
Yeah, flat and gorgeous
flat
to
and
see.
No, it's not flat and. Even the title
and
of the clip that you just gave me, it says "flat gorgeous" in quotes in the clip. Like that's how.
Yeah, so what? But that's not what he says. Yeah, dude, are you like? You were just complaining. We have to tell you how to think, critically think. So someone titled something. What if it said, supercalifragilistic? Does that mean he said that?
So you're thinking that in terms of photography,
no, dude,
and how beautiful it is, when you think he's saying flat and gorgeous.
Just because someone titled something doesn't mean he said that thing that they titled it as.
I'm not saying that that's the reason why. I'm saying that's also what they titled it. So apparently that's also what they heard. Oh, they're idiots, and I'm an idiot because I heard flat gorgeous.
Well,
and also in context, flat gorgeous makes sense. Flat and gorgeous doesn't even make sense in context of what he's saying.
Yeah, he's taking a picture of the Earth, and it's just flat and gorgeous.
It's just flat and gorgeous to see. He just slipped that in there. Flat and gorgeous to see. Why would that?
He's not the only one that said
that's not even coherent to speak that way.
How is that not? How is that not coherent? He's describing what he saw.
It's just flat and gorgeous to see. Who would say that?
Yeah.
No, that's just like a boomerism. That's just what people. It was just like flat out amazing. That's just flat wrong. People say that all the time. It's just flat gorgeous to see. Flat meaning like just straight up, just like locked in, absolute, flat. It's a synonym for absolute or total.
I just turned on closed caption. The closed caption says flat and gorgeous.
Okay. Let me see if that works for me.
So apparently AI is retarded too. A bunch of AI flat earthers fucking transcribing YouTube videos now.
Well, it works. It did it on mine too. I guess that's hearing and. But either way, I still don't even think it makes sense that he's saying it's
AI doesn't hear, dude.
It's flat shape and gorgeous to see.
Others too. There's a I can't remember his exact name. He was clipped in an interview saying it's flat. I assure you, it's flat, just as many suspect. And then there's Glenn. What's his name? The senator guy, Glenn. John
Glenn.
Fucking bald, ugly fella. Astronaut from the ISS. He mentions in an interview too that I don't know if he's talking about the Earth or the cloud layer or something, but he says he refers to it as being looking flat. Then you've got Picard, who was the first guy to reach the stratosphere or something like that. Back in way back, India would know more than me. He describes what he saw as being flat. So you got quite a few. We could dig out more if you want.
There's the Polish astronaut, and then there's the other astronaut. There's another Soviet era astronaut, and then there's you look at the Chinese. Their so-called space station that they say exists. All their imagery is flat. It doesn't show a baller because the Chinese can actually do math. Right, so you just got to do the math. It's really simple. If you have a horizon that's equidistant in every direction, right, it'll look the same across that whole image, right? So when you see this curvature, is the top part of the curve and the sides of the curve, are those the same distance away? Well, they have to be because you're looking at a ball, so they have to be the same distance. They have to be the 1,400 miles that they say. Well, if we go, okay, that there should be some dip angle that horizon is. Well, that dip angle is going to be the same in every direction because we don't see in absolute sizes, we see in angles. So you would see from your eye level, it dip from your eye level. But that dip has to be the same across the entire image. So the only way you would see curvature is if you're far enough away and saw the Earth as a circle, right? But you would have to be way above it and looking straight down. You couldn't see it from looking across. There's all sorts of problems, dude. Like, look, there's the problem with stars. Dude's been trying to get a straight answer at NASA about stars since the 1970s. Dude said he saw no stars. Dude said it was all white. Dude said it was all black. Dude said it was they were fucking brilliant. It was like being out in the desert. Like, there's all sorts of stories about the stars. None of these people have a consistent story. None of them.
What do you mean?
I just gave you examples.
Nobody can explain a star?
A star. They don't. When they say they're in space and they look at the stars, every one of them tells a different story about what they see.
Okay. What's the problem with that?
Oh, are you a retard?
Everyone just describes it slightly different?
No. Not slightly different. Not slightly. One dude says, no stars. I saw no stars. Another guy says, there were so many stars it was blindingly white, like Olber's paradox. But you have no idea what the fuck it is, Blue. So tell me what Olber's paradox is, Blue.
I don't know.
Okay. Well, then we don't.
But the one you're referring to, I would think is probably the one where they're asking them, "Hey, when you were looking at the sun, were you able to see stars?" I remember that interview after the Apollo mission. They go, "No, I don't remember seeing stars."
I mean, there's that. They didn't say anything about the sun, though.
Well, that's a question that they were being asked. Was particularly about.
No, they weren't. They didn't ask anything about the sun. They didn't ask anything about the sun.
I just reviewed that on my stream.
And then Neil Armstrong gave an interview where he also said the sky was quite black. And then, like, there's actually a video on my YouTube channel. This guy's not a flat earther, but he started years ago in the 70s writing NASA, asking them, you know, what's the deal with the stars? What do the astronauts see about stars? Blah, blah, blah. What do they look like? And like he's been writing, like I said, writing NASA since the 1970s, and he still hasn't got a fucking straight answer about the shit. For 40 years. 600 witnesses, right? You got 600 witnesses. They don't know what the stars look like from outer space. They say stupid shit like space smells like burnt steak. Then another guy saying it smells like metallic it smells like metal. Then another person, them saying they found seaweed on the International Space Station. Like there's so much bullshit that comes out of there. Fucking Don Pettit says, "Oh, if there's a hole, what if you have a leak in that?" And he goes, "Well, if there's a leak in it, well then there's a leak, and you probably seal off the cupola. I don't know right now, but there's probably some safety manual." How the fuck do they not know what to do if there's a leak? Don Pettit was a safety officer. He spent more time before the fucking other guy, the bald dude. He spent more time in space than anybody else, according to them. But he doesn't know how to fucking what to do if there's a leak. And then there's other problems. The seals. The gaskets. Who's doing maintenance on the ISS? There'd be something like 30,000 fucking gaskets and washers on the International Space Station. And they'd have to be changed regularly. They'd be doing nothing else but plumbing. You'd send up a bunch of fucking plumbers. You wouldn't send up astronauts. There's so many problems. It's endless. I can just think of endless shit. How does it radiate heat? We know because we make fucking, like, I make a thermos. I make a vacuum. There's a vacuum fucking cavity, right, to keep my water hot or cold. Well, space is a vacuum. Well, how does the ISS radiate heat? It would just keep getting hotter and hotter and hotter and hotter and hotter until they all fucking spontaneously combust inside. Because it can't dissipate heat because they're in a vacuum. They can radiate it off infrared, but how are they going to radiate out more heat, right? Because they're absorbing heat from the sun, right? they have to radiate out that same amount that they're absorbing at the same time. They have to radiate it out. So the ISS should be as fucking bright as the sun, as bright as the sun is from ISS. The ISS would have to radiate that same amount of brightness off of itself in infrared, not in visible light. But you get the point. Like there's an infinite amount of problems, dude. It's like it's just a story, man.
Can't radiate heat in space?
Not through a vacuum. There's only one way. Infrared radiation. That's the only way you can radiate heat. There's no convection and there's no conduction.
Mm-hmm.
Right? So you know what a thermos is, right? And how a thermos works? There's a vacuum inside the thermos.
Mm-hmm. Yeah.
Yeah. So the heat can't jump across the vacuum.
Gotcha.
There's no medium from which to transfer the energy.
Right.
Now, the energy can be transferred through infrared, and eventually your thermos will get cold because of this. The infrared radiation on the inner fucking bladder will radiate to the outer bladder, and then that'll cool out, and so on and so forth. But the ISS is like, it's constantly being heated. Every 45 minutes, it's in the sun for 45 minutes. So, and it's getting something like 30% more solar radiation, and then there's the fucking friction from, because they all are in low Earth orbit, so they're getting smashed with fucking particles, right? Energetic particles. So there's like so many problems. It's like Apollo. When somebody asks me, what do you mean the moon landing was fake? Like, prove it's fake. It's like, where do you want me to start? It's like literally so many goddamn things. I don't even know what to pick.
What do you
Just
think is what's their answer for how they cool the station?
Oh, it just works.
For a second,
it just works. It's obviously it just works. It has to work because they're up there. Like that's their answer. Sorry, Platsky, go ahead.
No, I was saying for a second there, it sounded like you were talking about a black body, but then I realized you were talking about what you were talking about, the ISS and how it would need to radiate heat.
If I remember correctly.
Have you thought about this? Oh, go ahead, Naya. Sorry.
Remember correctly, they pump ammonia through the thing in liquid form or whatever, and then it turns to gas or whatever the heck. And then it goes through the panels, and then from there, it loses its heat through infrared radiation. It's their claim. Now, that type of methodology is very, very heavy in the loss area, in the non-efficiency area. And we did the math on it a long time ago, but it didn't seem practicable in any sense that they were able to dump enough heat. Because their claim is that they rotate in and out of the cold. So the one side is hot during part of the day, and the one side is cold during the part of the day, so they don't actually get a lot of net gain. The problem with that is that net gain proposition assumes radiative loss. But the problem is that you need conductive loss in order to really take away that much heat that fast. Like, you put a tool out in the sun and you can't even touch it. And these guys are thinking that it's going to radiate out from infrared. It doesn't even make sense.
Hey, Indio?
Yeah, there you go.
Now this makes sense on that video. I just remember the one I sent you with the water outside. Are they trying to come up with a new narrative?
Oh, dude, it's constantly being updated. Like, oh man, what was the recent one I seen for Apollo? They invented some new shit. Oh, they changed the amount of fucking. So someone figured out that there's no way they had enough transmit power to talk back to Earth, so they just fucking updated the paperwork, and now they all of a sudden find some old fucking documents that showed that the actual values of the actual power of the fucking radio was this other fucking value. Like, yeah, okay. They update this shit in real time, man. And that sounds like conspiratory bullshit, but it's like, even people, Globers, even back in the day that investigated NASA, I know everyone here's seen it, right? The moon photo that had the black box. That was going around on the internet for fucking half a decade until Flat Earth came out, and Flat Earth was used as evidence that the moon landing's fake, and then they fixed it.
Yeah, all of this, this feels like I don't know. It's a lot of I don't believe it type of speculation, which I get. I get being skeptical.
It isn't just I don't believe it. We're not hand waving this. We're giving you reasons. There are reasons. We're telling you.
Yeah, I know, but these are reasons to be skeptical, and they boil down to I don't believe they could do that without being constantly replacing gaskets, and I don't believe they could radiate that much heat away.
It's not a belief. They can't.
Well, did you prove that?
Okay, it's pretty easy to prove. You absorb a certain amount of energy, and you had to maintain your temperature. You have to radiate that energy away.
Right, and you don't believe.
How do you radiate it away?
Well, they've got explanations for it, and you're saying I don't believe it.
What is the explanation?
They literally have radiators built in that have an ammonia pump that pumps it all out for infrared radiation.
Yeah, it pumps out infrared radiation. That would be a light source that you would be able to see.
Okay.
It would have to be as bright as the energy to dissipate, right? So whatever it is, you have energy coming in. You have that same amount of energy has to go out. The energy coming in is the sun, right? So basically, as bright as the sun has to come out.
No,
right?
Wrong. No.
Oh, where does the extra energy go?
Well, you're assuming that they're absorbing as much energy that's as bright as the sun, but no, they are a reflective surface. Number one, so most of the sun's energy is being reflected. They're not absorbing every bit of energy that hits them; it's reflected off. So there is though a remnant of energy that doesn't get reflected away, and that gets radiated away by the radiation system.
Okay, the efficiency of any reflective surface is going to be low.
Any reflective surface is going to be low?
Yes, it's not. Look, we're talking about solar radiation. Okay, I'll just give you an example. You could take a fucking chrome wrench or a chrome bumper, right? Pretty shiny. In the sunlight, stick your hand on it. You'll burn your hand.
Yeah, but that's a completely different material.
How is that different? It's a reflective surface. Steel. You're seeing aluminum? Here's a question for you. How did they pressurize the ISS? Where'd all the air that's inside come from? Did they send it up with air in it and then built it together and then put it together and then pop the steel like a freaking Coke can and then the air just flowed from one side to the other? Or like, how did they pressurize it all in the first place? Any idea? Yeah,
probably with some compressed air tanks.
Probably. Okay, it's the size of a football field, dude. How big is that compressed fucking air tank?
Well, it came up piece by piece, and you're delivering a lot of oxygen up there, right?
Yeah, piece by piece. That's a story. There's no film of it. There's no video of it. There's no video of them building the fucking International Space Station for some reason. There is one video.
I just looked it up. Has about as far. Sorry, I'm just reading about the reflectivity. ISS is coated with a specific Z93 white thermal control paint, which is designed to diffusely reflect sunlight across a wide range of angles.
Of course, magic paint, dude. Really good engineering.
Keep in mind, look, let's settle this real quick. You have to have greater than 100%.
Did he chop up for everybody else or just me?
Said you had to have greater than 90%.
No, 100%.
Greater than 100% over unity? Yeah.
Yeah, exactly. Otherwise, if you leave any heat,
Well, the ISS, it spends half of its time in the dark.
Then you're not
in the night.
But if you leave any heat at all, you're gaining heat constantly.
Right. So it has so it's keeping it at zero. It's keeping it neutral. Whatever it's taking in, it's letting go of, including the body heat of the passengers. It has to maintain it at net zero, or else it's going to heat up or cool down. But it's spending half of its lifetime in the shade of the Earth, supposedly, and even in the time that it's in the sun, only half of it's being hit by the sun. The other half's in its own shade, and it's got a cooling system. It's coated with this literal space grade thermal control paint. And so that allows a certain amount of radiated heat to hit it and be absorbed, and then that gets radiated away.
Mm-hmm. Yeah, that's awesome. Magic paint, dude. Awesome. I mean,
magic paint. All right.
Yeah, it is magic paint because it can't, like, their claim, right, that we have magic paint on the International Space Station that can do things that are impossible generally, right, that nobody's doing on Earth. It's a bunch of horse shit, okay? Because you missed the key part. The part what I first mentioned, one of the first things I mentioned was the side that's in the sun is 250 degrees, and the side that's in the shade, according to them, is negative 250. So you'll have a surface. On one side of the surface, 250. Other side of the surface, negative 250. Now, what material can take that type of temperature differential without fucking shattering into a million pieces? Like this, really good engineering. They must have magic fucking metal too, and then they also have magic gaskets, right? They also have magic fucking gaskets. So we on Earth we make vacuum chambers that go down to freaking 10 to the negative 6 torr, and if you open the vacuum chamber, now mind you, the gaskets on these vacuum chambers, they're metal seals. They're not, and like the vacuum chamber has to be specially prepared. Needs special material. All has to be outgassed, cooked beforehand before you even apply the vacuum. And then when you do the seal and you shut the door, that seal is only single use. As soon as you open the door, you got to scrape the seal off with a tool and use a new seal to shut the door again, or you won't have a vacuum, or you won't have a seal. Okay. Every time they open the door on the ISS, they should have to do this. A fucking giant 3-foot diameter fucking door. They should have to replace the metal seal. It would even be worse than a small fucking scale vacuum. Because the door, right? So if you have a small container, right? And I have a little teeny door, right? I can make my latch very fucking strong. I can put a lot of pressure to push the fucking door into the housing. Now, when you have a fucking giant fucking door, you have the connector, like whatever latch you're going to have to frickin' lock it into place. There's no way you can apply as much torque on that as you can a smaller door. So you're going to need an even better seal. There's no way you can do it without a seal. This is a huge problem. This is a problem with Apollo, any space shit, where they say that they're opening the door and going outside. You have to replace the seal. This isn't my opinion. You can just go on anywhere. Go on YouTube, look up ultra-high vacuum seals or ultra-high vacuums or anything like that. They literally have instructions and tutorials on what you have to do on how to operate the vacuum chambers. It's not like our bullshit, right? So there is a flat earther who's a physicist. He calls himself the I can't remember the name. It's UAP. Underrated, amazing physicist or something like that. Anyway, his job as a physicist is to make gaskets and seals. It's literally his job, is design and engineer gaskets and seals. He said the ISS would require 30,000 seals, and they would have to be like on a 1-year rotation. Means every seal would have to be replaced after 1 year. They would literally be doing nothing else but doing plumbing.
That seems like overestimated to me. I have like a maintenance and engineering background. I've worked in a lot of different types of industrial environments. Certain systems, you can design systems to be very simple. Like
Yeah,
you would eliminate all those seals so that you don't have to replace them all the time.
What would you use other than a seal?
Dude, what the heck, dude?
What do you mean other than a seal? Are
Yeah,
you
what
talking
would you
about
do?
which ones are we 30,000 seals? What seals are we talking about? You talking about the door, the hatch seal?
Well, that's one seal. You got seals for all the plumbing, right?
What plumbing seals are we talking about? Why don't they
They
just
have
hard
water. Okay, they have air scrubbers. They have like all sorts of stuff to maintain their life in space, right?
Yeah. So where are the seals?
All that hardware typically will have gaskets and seals that go along with it.
Typically, this isn't a typical scenario.
So what are they going to do?
But also, I just searched, do they have to maintain seals on the space station? And the answer is yes. There's routine maintenance, including replacing seals, that happens all the time. They live up there for months at a time. You think they don't have time to replace some seals? The ones that wear out?
Where's the evidence? Where's the evidence for the claim that actually occurred and it wasn't just stated that it occurred?
Yeah, that's another
Where's the evidence that it doesn't occur?
Shit.
He's saying they would have to replace seals. I look it up and they're like, yep, we do. Like, nah, I doubt. I don't believe it, is what you're saying. Again, it boils down to I don't believe it all the time.
No, it's how many seals they would have to replace.
Well, how many?
You got to remember, it's the size of a football field.
Okay,
and it also has
seals per square foot or something? There's some rule I'm missing.
It also has this huge ammonia system supposedly running through it. It's got the
it's all hard
integrated
piped, what's the need for a seal?
Trickulated system. Well, that might even be worse.
It's all hard piped. How the fuck did they do that?
I don't know. Threaded couplings?
Yeah. Who threaded them together?
Oh my goodness, dude.
The people doing the assembly, the astronauts in space?
Dude. No, nobody talk. Hold on.
They have a machine shop up there, man.
Hold on, dude. any threaded pipe, anybody who knows anything, it is useless. You have to use a seal or a paste, for goodness sakes.
That's not true. Well, okay, what's wrong with the paste? I mean, okay,
yeah, it is.
Paste? The paste lasts forever. I've worked with threaded pipe a billion times. You don't have to like unthread it and replace the paste once in a while. It's forever.
No, that's fair, but that's fair. But we're talking about a vacuum, dude, not ambient air, dude. Good grief!
What's wrong with the okay, if I build a pressure system, a pneumatic system, where there's a whole bunch of air pressure, and I got a turbine, 120 psi, pneumatic system through my whole factory, I can have like a million outlets. I never have to replace any seals on that unless I'm replacing a piece, like an apparatus or something like that. But once I hook it all together,
is it a vacuum system that is constantly changing temperature by hundreds of degrees?
Well, that's not what's going on inside the system. Are we talking about seals inside the space station, or are these? Or do you think there's outside? They have to go float around in space and replace seals on the outside? Like that would be a retarded design.
Goddamn right, they're always going outside.
Oh, dude, the whole system that
but
we're talking about.
Their plumbing is not on the outside.
Is outside.
Vehicle. The plumbing is outside the vehicle, is what you're saying.
Oh, dude, the retriculating. What's it called? What the heck is that? Oh yeah, the ammonia system and all that. Yeah, that's on the outside, dude.
Yeah, but also they're going and replacing seals on the radiation system outside.
Dude, what we're telling you is that if something's changing from hundreds of degrees throughout the day, that the mating surface is not going to be consistent, dude.
Yeah, but all right.
I'll be outcast when that happens.
Again, I'm having a situation where it's like, I can't comprehend how they could have designed it so this wouldn't be a problem.
No, you're just making up like non-realistic scenarios to say, yeah, this is possible because
no, these aerospace
some other fucking
engineers
thing that never happened.
these NASA scientists, engineers, the top engineers couldn't have designed a system that doesn't need a maintenance on the outside for the cooling system. They couldn't have designed it that way. They would have to go replace seals outside in the vacuum. It's like,
do you understand what's outgassing?
He has no fucking clue, dude.
Yeah, that
you know what outgassing is?
Dude, if there exists,
that would require what?
Hold on. If there exists a system of valves and seals that can take hundreds of degrees of temperature change without having to be
the
replaced,
valves could be inside.
Good grief.
The valves don't have to heat up and cool off. Only the surface on the outside would have to experience that. Everything could be thermally insulated from that.
Could be.
Yeah.
I feel like you're like the lawyer trying to construct a defense for an indefensible position.
I'm just going like, look, I'm not even a rocket scientist or an ESH engineer, and I'm going like, no, I could imagine ways that I would design that so I wouldn't have that problem that you're saying. And you're going, no, they would have to have that problem.
Like, there's things that you're not taking into account, I would pretty sure.
Who?
But it's just sort of just like a FUD posting. It's like, nah, I don't think they could do that. I don't believe it. I think they would have problems. I'm going, well, why wouldn't they just design it so they don't have that problem? Nah, they could.
Because there's no such thing as magic.
It's not magic.
You can't design your way around impossibilities, dude.
It's not impossible. It's just difficult.
Okay, you tell. Oh, really? So how do you make a vacuum chamber that opens and closes but doesn't have a seal? They can just open and close it willy-nilly.
Wait, where do they have a vacuum chamber?
The outside of the International Space Station is a vacuum.
But it's not a vacuum chamber.
What's the difference? 15 degrees on one side of the door, 0 on the other side of the door. What does it matter which side of the door the vacuum's on?
Are we worried about the pressure or the temperature? Let's stay in one.
We're worried about the door shutting and fucking keeping the air inside the ISS.
Okay, so the door
cupola
shuts.
itself will be a problem.
So the door shuts and seals, and then they put the pressure into it. What's the problem?
The problem is the door shut, it seals. The seals part.
The
Why is
pressure
that a
seals
problem?
the door even more.
Yeah.
Oh, you guys are fucking legit. Did you just really say that? Okay. So dude, cut the shit, you loser. Anyway, that's the problem. It won't
The
seal.
pressure. He's right that the pressure
It won't
itself
seal. We
literally
know
can
this
create the
because
seal.
of vacuum chambers that we have here.
But you're dealing with literally like the reverse issue with a vacuum chamber.
What's the difference?
Well, the difference is one of them's dealing with positive pressure and one of them's dealing with negative pressure.
Okay, so the positive pressure is pushing the door closed. Who cares? What does it matter?
Well, you just answered it.
Okay, you have a out-facing door that closes in 15 psi outside vacuum chamber, 0 in. The 15 psi pushes the door shut. And according to you, we'll make a seal. But we know from reality it doesn't make a seal. In the ISS, the door is an inward door, right? So when it shuts, you think the 15 psi that's inside the chamber, and they even say it's not actually 15 psi, it's less than that. So you think that 15 psi is pushing the door shut to seal it, even though the reverse doesn't happen on Earth.
The reverse does. No, that literally does happen. You can demonstrate that.
No, not with an ultra high vacuum. It doesn't.
Why?
Because the vacuum is so high that you can't make a seal, right? Where the surfaces mesh to a point where they don't leak through. Okay, that's why they have to use metal seals. This isn't you can look this up. I literally told you where to look.
So they don't have good enough seals at NASA.
They do, but they're single use. No, they do. They're single use seals. They're single use of a malleable metal, typical copper that's been pre-outgassed. So as soon as they open the door, when they want to shut the door again, they have to affix the seal. The seal has to be perfectly aligned, and then when they shut the door, they have to apply even pressure because the metal actually deforms, right? and fits the shape of the opening, right? Wherever it connects, right? Whatever the freaking rim shape is, the copper will deform to fit that and form a seal. But every time you open it, you need a new one. This is the problem. This is what I'm trying to tell you.
That doesn't make any sense.
Your inability to comprehend
a door
not
that's,
evidence against it.
The door is maintaining 15 psi.
Yes,
that's very low. That's lower than a bike tire. That's lower than a golf
fine.
Tire.
But it's the relative value that matters.
Relative value to what?
The relative value to what's on the other side.
There's nothing.
Listen, I'm just going to post a video from a company that makes ultra high vacuums, and they tell you what you have to do to seal the fucking thing.
Yep, now, one more time. The ultra high vacuum exists on the Earth, in which the pressure that they're attempting to mediate with inside and outside is again what? The ambient air pressure, which is what? Is it not 15 psi?
Yeah, they're trying to keep that out.
I mean, am I smoking crack or something? Or is my memory broken? I'm unsure. So yeah, the ambient air pressure, where these vacuum systems exist, to which they need these seals, is separating an ultra high vacuum from what? 15 psi.
I'm gonna check out your video now. I'm gonna educate myself.
Yeah, dude, and you can also go to Wikipedia. They have a entry on vacuums, right? If you go down the ultra high vacuum, it gives you a list of all the things you have to do to prep to even get an ultra high vacuum. To even make an ultra high vacuum, you need a 2-stage process. You need a vacuum chamber inside of a vacuum chamber. But the point is, it tells you all, like, you need special materials. The materials that you can use have to be specially treated. You can't use certain types of metals. Like, you can't use any type of polymer, plastic, anything like that.
Yeah, so they said don't use the elastomeric seal because it's permeable by the atmosphere. If you're going to
now that you said that, I just want to read it at this point. So the argument seems to be that, 15 psi isn't that much to contain when you're talking about containing it from a vacuum. Yet when practical demonstration on the Earth, when you have an ultra high vacuum and 15 psi on the other side, you need all of these seals. So the argument fails.
Well, I didn't say they don't need a seal. It's just they said use a metal seal. What's the problem?
Yeah, the problem is
it's a compression.
There's no inventory for metal seals on the ISS or Apollo or anything. There's no record of them ever doing any type of fucking seal replacement. As far as going in and outside from outer space, done to the spacewalks or ventures or whatever. What about the space shuttle fucking doors? Who fucking put the seal back on those? Right? So space shuttle had the big bay doors.
Between the two docking of the spacecraft to prevent air from leaking out, NASA has developed advanced space-rated elastomeric seals.
Man, more magic seals. More magic seals, man. It's crazy, dude. Now we got magic seals.
Magic.
Why don't they use that in the industry?
Why is it with flat earthers that when an engineer does something, magic?
No, that's a claim. You don't know what engineer did anything, right? They just wrote magic fucking seal, and you're like, look, magic seal. Because they didn't use the word magic, they said special space, right? They didn't say magic, they said space elastomers. They're just like elastomers, but they're for space. And because they're for space, they're better. And they can do shit.
Okay,
why don't they just use that on Earth, man? Why don't they just
Why?
We
Yeah.
make vacuums. Hold on a second. We make vacuums
What?
for all sorts of manufacturing processes, for computer chips, to sputtering, to everything. We have these vacuums. Why aren't they just using the space frickin' shit?
Yeah, why aren't all these, and especially elite
Why don't they just
uses
use
of
the metal seal
vacuums,
that costs a
They don't
nickel?
use any of this alleged
Because
space
they keep-
nonsense.
Because
They have
then
to
it's
use
just
the actual methods that actually work.
Because in industry they can use a metal.
They
seal that
they
costs
certainly
a
have enough money.
Yeah,
in
and
industry,
the
they're not
isomer
metal
seals
seal that
are
costs a nickel.
reusable. That's the whole point. They're reusable. That's why you don't get the metal seal. You get the other seal that you just put in place and it just stays there. You can open and shut the door all fucking day long, no problem, right? Why go through the trouble of, oh, we're going to put the metal in and fuck shit, it didn't seal right, it was a little fucking off, got to try it again. Like, why go through all that when you can just get your little space elastomer and stick it in the fucking door and open and close it all you want? You have a lot of credulity, man. I mean, you've been saying we're incredulous, but you're credulous. Like, I mean, I already figured this out a while ago. You're defending, you want to believe this stuff. This is more than just like, it's the evidence. It's like, you want this shit to be real. So let me ask you, do you think that you're going to go to space someday?
No.
You're not going to Mars, dude? You're not hanging out? Elon Musk says the fucking dude, like anyone will be able to go to Mars. It'd be like 10,000, 100,000 or something.
No, I think he's lying.
Yeah.
I think he's lying about that.
You think he's lying about that? He's lying about a lot of shit.
Yeah, I think he knows what to tell people to get them to go along with what he's doing.
So do you think they just all lie about everything? All the space people and the fake space people and the space people that are just doing more than NASA ever thought they could. So NASA loses all the math and the telemetry and all the data and doesn't know fuck all. But then Elon Musk goes, hey man, I'm going to start sending these rockets to the moon because I feel good and I'm rich. So if you're just a rich guy and you're ignorant, you can just send rockets however you want. Isn't that weird? You can outdo all of science, all of physics, all the scientists, just if your name's Elon and you got a couple dollars. Isn't that crazy?
I'm learning about the seals. I never looked into this before.
Oh, Elon must have better seals than the government. He must have seal technology.
Yeah, then when you start thinking about the spacesuits and then like walking around and them going like in and out of the fucking Apollo doors. And
Yep. So
yeah.
let's talk about the spacesuit. So daydreams. You can talk about spacesuits up in the air all day long. The spacesuits tested on the ground. The evidence of humans in the suits are that they immediately began experiencing pain. Immediately. Not 5 minutes later. Immediately. In fact, the one guy said he felt like his tongue was boiling off. So if they can't even get it right on the Earth in a controlled environment to make the astronauts safe in the spacesuit, how are you going to trust them? Like there's no ground-based successful demonstrable testing of this technology. Nowhere. Okay, one more time.
Believe there's
no ground-based. Hold on a second. Ground-based successful testing of this technology.
100%.
And on the ground, it doesn't work. On the ground, in order to create these environments, you need metal seals, etc. Yet they want you to believe that they can't test it on the ground, and it's not practically demonstrable on the ground, but somehow it works in space once you get there.
That's how it all works. Somehow in space. So big. I'm sorry.
Yeah, Big Tech, want to know when the first time they tested the LEM? The very first time they tested it? When they went to the moon. It was never tested at all. The LEM, the lunar lander. They just winged it.
It's supposed to be vacuum tested and mother approved, but it wasn't. Damn it.
In fact, there's testimony, quote unquote, alleged testimony. Actually, it's just an anecdote. Okay. That supposedly the surface of some of the surfaces in that machine were so fragile that if they dropped a tool, it could puncture it. So this is an untested technology, so fragile that you could puncture it with your just hanging out in there, and you're supposed to, survive in this most deadliest of environments that humans have ever been in. And then you just happen to succeed on your first try.
Worse than the ocean.
I mean, it's like, so the suits aren't tested, the machine ain't tested. And we're just supposed to believe that they can't demonstrate this stuff on the Earth in any type of environment that it has a vacuum and seals and all this, and then it's just supposed to magically have worked.
I mean, I've never heard this claim that they don't test the suits on the ground and their tongues boil. I mean, they do tons and tons of testing. They have vacuum chambers that they spend time in.
Where's the guys?
Look, watch the video I posted a minute ago.
You feel good about putting a suit on and getting in a vacuum chamber for us for science?
Yeah, dude, go ahead and post your source of what you found.
Dude,
all right.
Wasn't that a challenge for Adam Scott Beach, man? People were saying he died in a vacuum chamber. It was fucking fun.
No, I challenged all of them every time since day one. They won't do any challenges that I've offered, any of them. Especially the one with where they got these special suits they all trust and believe in. But the guys talking to us right now won't put one on and go live and get in a vacuum chamber. Isn't that weird? They believe it, though. But for science or for truth and to prove their own fucking belief, they won't do it.
I remember the one, I think it was Smarter Every Day, where he put a glove on and he put his hand in a vacuum chamber and the glove blew up.
Right.
Was it a glove? I thought he put his hand in there, like in a vacuum
inside of a glove. Inside of you put your hand inside the thing, inside of a vacuum thing.
The one that might be a separate one.
There's a lot of
one about the glove. Hold on, Demic. The one about the glove is that the glove, because it's not rigid, it expands and gets tight. Like the air pressure within the suit
Dante.
presses against the outside of the suit and creates a rigid suit that you can't your fingers can't move.
That's all good and done, but Dante likes 13-year-old kids.
Yeah, Dante is an advocated pedophile.
Yeah, that's cool. Yeah, cool story. So you can all get banned. Thanks.
I'm still here, and he's still a pedophile. Fuck you.
All right. Well, you're not going to be here for long, sucker.
Oh my god.
All right, so let me just get some. Get some IDs here, so you can get banned. There you go, get banned, fool.
I got one of them.
All right, so when is this test you're sending me? It's like black and white video. It's in the 60s or 70s. It looks like some of it's color. So this is from one test they were doing in a vacuum chamber to get ready for the space that they're not going to go to, and this guy's hose came disconnected, and he had an accident. That doesn't. Does this prove that they don't test their suits?
Are you ready to test their suit?
Dude, what hose, dude? What hose, man? Like what hose is in space suits?
No, the hose that was pressurizing his suit for this
Where do you go to test them at? Where do you go to test the suits?
I'm watching the video. I'm watching the video that...
No, I know, but you said there's one video, black and white. I know, listen, though, your critique was you don't like this one video, black and white, and it's shitty, right? I'm with you. Where's the one done today, right now, in 2024? Where's the 10 of them you can pick for us?
No, the real question is where's the pressure hoses in the spacesuits of the alleged astronauts, dude?
I want
when they're actually in the field.
No.
So that's not analogous.
Here's the real question.
I'm watching the video.
Well, just let me finish this. Let me finish this claim. Let me finish this claim here. Having your suit connected to a hose to an outside pressure source could be depressuring the suit. So this wouldn't be analogous to the spacesuits in space.
So here's the real question:
So what?
The Artemis mission. Why is the Artemis mission being canceled again? Delayed. Because for the third time they can't get the spacesuits right.
Well, that's the mission that they just did with SpaceX, where they sent
We were there in 1969.
the Isaacson's guy up with the new suits. Where he bounced up and down, and everybody said he was a mannequin. He was moving his arm. He's testing.
What suit video of them all in a suit? Not just fucking the whole human.
How is it hard to make suits? They already did it in 1969.
Don Nance is his name. Look him up. He was one of the first guys that designed the suits. The first one he designed had gold embroidered material, and it was scuba gear. Now, how do you not know this?
What?
Don Nance. DONNANCE. Don Nance.
What's going
on? It's fucking hard.
TTS?
Yeah, you have PTS syndrome for looking up stuff.
PTSD. That's almost as good as like the memory of their computers was made by frickin' sewers and seamstresses and weavers. They literally weaved memory. Yeah, their computer memory was actually just fucking weaved string on metal iron rods, and then if you look at the schematic, it actually shorted itself out when they fucking read it out. Fucking hilarious, dude.
I mean, why isn't he looking up Don Nance? A person I used to work with, their grandmother, not married, but took care of him. Funny story is that Don Nance messed around with the lady that took care of him, and because his woman, whatever, him and his woman were getting taken care of by a lady, then he messed with the lady, paid for her to live on his property for a long ass time. The lady that took care of him paid for a trailer to be on his property for her. So he had his wife in one house, and the lady that took care of him that he messed with in the trailer on the property. And the lady was the lady in the trailer's daughter, and I worked with her. And she was telling me, because she found that I was a flat earther at a certain time, and she's like, "You want to know something funny?" I was like, "I don't know, tell me." You know, because she'd always mess with me and like give me like little conundrums to try to solve for or whatever, and I'd solve them, and she was tickled by it. So she came in and she goes, "You know what? That stuff you say about this," she goes, "You know what's something funny?" She goes, "You know, my grandma messed with that guy." I was like, "What guy? What are you talking about?" She's like, "The guy that designed suits." I was like, "Get the fuck out of here." She said, "No, his basement was designed like a museum of NASA." So when she got to, as a little girl, she got to do tours in his basement. They didn't let her in the house much because she had just got to go in the trailer house. You know, nice trailer, don't get me wrong. But she got to go in the house, and it had all the suits he designed, from the first one to the last one to the one he was working on. And it looked like a museum, she said, for NASA, where all the stuff was meticulously kept, you know, temperature, whatever, this and that. All the stuff was kept nice. Now, the moral part of the story was, this is the funny part. As soon as the lady passed away, a little while later, the guy passed away. The lady on the property in the trailer got whatever she got, but before it was all said and done, a group of people pulled up, whoever they are, they all pulled up, and the family didn't get the material and the stuff in the basement. The group of people did. They pulled up in vehicles, vans, and went in there and meticulously cleared every fucking thing out of the big ass house in the basement. Cleared it all out.
Wow, that's crazy.
But one of the main parts, beside that crazy shit that some dudes just came and took all the shit that wasn't theirs, supposedly, right? Wasn't the family didn't get their dads and their father and their husband and their brother's shit? Is the government took it. So anyway, the suit that he made was made for going underwater. It was scuba gear embroidered with gold. That was the shit they used to go to wherever. It was the space shit. tested in water to go to space. That's the main moral of the story right there. And then if you work for NASA, when you pass, they're going to take everything you had that even connected you to them. Remember that also.
Man.
That means the family don't have none of those suits now. So you can't go visit the daughter, can't go visit anybody and say, hey, let me see one of those suits you got. Can I see some of the stuff? Hell no. We don't have it.
Good thing that guy didn't rat him out and tell anybody it was a scam before he
Well,
died.
he did.
He'd be screwed.
Well, he did.
Oh, he did?
Yeah. He said, the suit I designed to go to space was only made to go underwater.
Who did he tell that to?
It was the scuba gear. His name was Don Nance, dude. Fucking look it up.
Who did he tell that to?
Who did he tell it to? Everybody. He let tours in his basement when he was alive of kids and people. He'd let them come down and see the fucking suit. The fucking national news, dude. What do you mean? The news people had to tell the suit was being made and had to say they had a guy working on the suit. Maybe they didn't tell his name at the time, of course. But,
So he was trying to expose NASA for a fraud and he told kids?
Dude, are you fucking slow?
Maybe. I don't know.
Listen, man, if fucking Dr. Seuss comes on TV and says, "Gah, I got this suit that'll take you to fucking space in a vacuum," and it won't work in a vacuum. You'll unalive yourself in it, and then it's for diving in water. That tells you right there.
How do you know it was for diving in water?
That's what he said. It's a fucking scuba
Who did he
gear.
say it to? Who did he say it to?
Everybody who asked him what it was designed for. You stupid fucker.
Who? Everybody?
Oh my fucking God.
How do you know that? Who told you that?
Go back and look at the fucking suit, you idiot son of a bitch. The specs it's designed for fucking underwater.
Why do I gotta go?
Son of a bitch, why are you so dumb? If I show you a horizontal line, you're like, who told you that line was horizontal? Who told you this ruler's horizontal? Everybody.
Everybody?
Before I was alive, somebody handed me the ruler. When I became alive and old enough to realize what a ruler was when they handed it to me, that existed.
What the hell are you talking about rulers for?
The same as the suit. The suit existed before me, so does the ruler.
So how do you know it was made for water? Trust me, bro? Trust me, bro. He told kids. It's made for water. Gold thread.
Why are there 2 server mutes? What's going on?
I don't know.
Did someone else take over the channel?
No idea.
Because that guy's a flat earther, right?
Yeah, I think so.
And the other guy's a flat earther, right?
Alpha server muted. I don't know who server muted them up. The Alpha server muted because he was hot mic'd.
Oh, fair enough. Interesting. Yeah,
he was at work and like his machines are going. He was hot mic'd. I don't think he realized he on-mic'd himself.
It's worse than that. Okay, let's be clear here and fair. The real story is he possesses what's known as an iPhone. And they have a glitch where if you're doing things, it'll automatically unmute you when you switch between apps or whatever with Discord. And so he can't trust his machine to keep him muted. When he puts Discord on mute, it'll actually unmute him because the iPhone said, I'm going to unmute your ass because I want to, because I'm an iPhone.
Well, only idiots buy iPhones. Smart people use Androids.
Ah.
They try to deny it.
Red flag. I've actually heard girls say that freaking having an Android's a red flag, dude. It's crazy.
Yeah, that's because girls don't know how to use fucking technology.
No, it's because they want to FaceTime. That's why. And if you can't FaceTime them, then that's a red flag.
Yeah, because see, it's a problem. It's a problem with iPhone users. They think that limitations are benefits.
Yeah, pretty much.
Like seriously, like any Android device can do a streaming directly to another device on an app. Just because it's not integrated into the platform, think that is a benefit. But limiting yourself to an integrated platform method of video communication only is actually a limitation. And so iPhone and Apple products are excellent at marketing limitations and making people think that they're somehow a benefit. Now, speaking of limitations and benefits, if food is losing pressure and it causes your tongue to boil, how is a zipper in front of your dick going to keep the tip of your dick from not boiling off in the vacuum of space? And keep in mind, we're dealing with the same pressures here. Because the ambient atmosphere that a human is supposed to be in is 15 pounds per square inch approximately. So they're trying to maintain a 15 psi inside the suit, right? But we know that when it comes to vacuums, that you need specialized seals to stop and barrier an ultra-high vacuum from 15 psi. Not only that, but why do you need a constant flow of hose pressure? Like where is that in the actual suits that they're employed? Like they don't have this savior system that's going to keep the pressure or try to pump pressure or try to negate pressure. They only have their suit to rely on once they're out and about.
Depressurized.
No, nobody said it can't be. The difference is, can it withstand the difference between 15 psi and an ultra-high vacuum?
Isn't there no pressure in a vacuum?
No, there's no such thing as a zero pressure vacuum. But you bring up another good point, which is that on Earth,
next to zero.
They can't reproduce anywhere near the kind of vacuum that would be in space.
Yes, because you're on
Earth, I think. Yeah, so that means you can't actually test the equipment at the actual vacuum that it's supposed to be operating in. And if they can't even replicate on Earth, then with a vacuum that's not even the strength that the space is supposed to be, right? And you need valves and seals that are a certain type to get 15 psi separated from an ultra-high vacuum. Then how are they expecting us to believe they can do it up in space? They can't even do it on Earth. So why should we believe they can do it in space? It makes no sense.
Plus, we can't go to space because gas pressure requires a container.
Pissed.
False.
You say so.
Requires a barrier to press against. That's all.
What the heck? What the heck just happened, dude?
Pressure comes from pressing. It's in the name.
The thing about what you said, Big Tech, I heard you mention it earlier on with the sort of different nature of gases in the is it the ionosphere you mentioned?
Yeah.
Okay, right. Does it have to be the ionosphere, or could we go at, let's say, 31 kilometers in altitude?
What's at 31? What layer of the atmosphere would that be?
I'm not sure, but it's something that can be verified with, because you can get weather balloons right on Amazon for a nice price of £80, so it's not too expensive, and it's something that a flat earther could verify about what's going on at that altitude, that you could then sell your point, right? Assuming that we're not talking about an ideal gas at that altitude.
Well, I don't think you're going to get a balloon that high. Yeah, the ionosphere, we're talking like 20 kilometers past 30, like 40.
Yeah. But I'm just saying, that's why I asked: are we still talking ideal gas at 31 kilometers?
I'm not sure what the PSI is.
It's about 1 kilopascal. just a little bit less.
What was your question going to be, though? I'm interested.
What is my question? Like, there's two questions. One, is it an ideal gas at altitude? And two, if it's not an ideal gas, would it be possible for a flat earther to then use a weather balloon that you can buy off Amazon and send it up 32 kilometers to test what kind of atmosphere we're talking about at that altitude? The type of gases we're talking about, and what the nature of gases are.
Interesting. Yeah, I don't know I wonder what kind of test, like, even if you could get to 50 or 60 kilometers, what test would you be able to do? What would you be looking for?
Well, we could do pressure and temperature. That much we can do. Pretty easily. Stuff that's a bit more technical, I don't know. There must be some way to like investigate a bit more deeper at 31 kilometers that the average person can do. Don't have to rely on scientific paper or anything like that.
You know, I feel it's so bizarre. Now that we're back to the gas question, it's like when I talk to somebody, they tell me, you know, in the flat earth, they tell me you can't have gas pressure without a container. And then they tell me that gas is always equalizing, finding equilibrium within the container.
Except when it isn't, yeah.
Except when it isn't. But wait, so isn't there always a constant? So there's not always a constant pressure within the container at all points.
There's the way I deal with container. Got a little thing I'm just gonna get.
I mean, can you get a container with like 30 psi at one side and 5 psi at the other side?
Yeah, I don't even think you need to think in terms of like whether gas is.
Oh, hold on a second before we go on. You already believe that if you're a glober.
Yeah.
But if you are a glober that believes in the standard glober paradigm, you believe that a container would necessarily have a pressure gradient in it. Period. You already believe that.
Yeah. That's not what. But I was just going to say that that I don't think.
What? Well, hold on. Before we go on, I just want to clarify that. What I mean by that is that the idea that gas pressure gradients can't exist within a container would be antithetical to the standard globe paradigm. So a container most certainly would have a gas pressure gradient in the globe paradigm.
Can you tell me why you're saying that? What's your evidence of that?
Well, I mean, it's contingent within your paradigm.
In what way?
In that your paradigm, if you're a glober, and I'm not saying you are, I'm just saying if you are one, is that the gas pressure gradient or any gradient of pressure or column of, what's that called? Specific gravity distribution, which would be density and buoyancy would distribute, right? So if you take a chunk of atmosphere, let's just say 3 miles tall, and you build a container around it, and it's contained, it would have a gradient in it. So as a glober, you believe that a container would have a gas pressure gradient in it. It's that simple.
Yeah, like
you believe it wouldn't.
If you made the,
do you believe it wouldn't? Is that different than a flat earther?
No, the point I'm making is that there's many globers who will say a container must have equal pressure. Wouldn't have a gradient.
I mean, yeah, if you built a container all the way up.
Yeah, and so all you need is a dynamic system of energy distribution for whatever reason. And then you can have differential pressures within a container. It's that simple.
I said something funny earlier. I said that the sun is an entropy spoon.
Let him speak his piece.
Yeah,
'cause
let me
it'll
hang
just
myself.
hang him. Yeah, it's all it's going to do. Let him do.
So there's force being applied to the molecules that are striking the walls of the propellers in the turbine. That's what's creating the positive pressure. It's the force of the molecules striking the walls of the propeller. Do you understand that?
That's so much like the globe, bro. Nice.
So there's a wall
The globe does that
that's
too.
striking the molecules and creating positive pressure.
Yeah.
So where's the propellers on your globe, dude? That's so sick.
Oh, thank you for asking. So there's this thing we've referred to, it's heaviness or gravity.
What? That's a propeller? Okay.
Yeah, which is propelling the gas.
You still trying to sound cool?
Have you heard of, things fall?
You're now saying that a sphere.
There's an acceleration downward.
It's a leaf blower, bro.
There's an acceleration downward, and then the gas molecules strike the wall.
Can I clarify your analogy? So now you're saying that the leaf blower is analogous to a sphere ball Earth in a vacuum. It's going to be creating positive pressure on its surface just by virtue of being there as a ball.
By virtue of the gas molecules striking the wall.
Yeah, why would it be doing that?
Because the molecules are heavy.
So number one, that goes against your prior analogy where you said that the Earth is analogous to a propane tank as far as the gas containment goes. Now you're saying that you just have one outside surface, one continuous surface of a sphere, and that's now analogous to a leaf blower.
Yep.
Okay, so you're discarding the propane thing that you said you had a big W on before because this goes completely against that. So I guess we'll throw that in the garbage.
It
now you're saying, yeah, it does because the Earth. Yeah, because
all of them have a wall striking the
propane
gas.
tank is a continuous enclosure all the way
It's
around.
a continuous single wall.
Yeah, and the gas is
where the
confined.
gas is striking the wall.
The gas is confined to that volume where you have this continuous enclosure. Whereas in this scenario, you're saying that it's acting
Makes no
more like a
difference.
leaf blower. Yeah, that's not a continuous enclosure.
You're pointing out a distinction without
and
a
saying
difference.
you have a force. It is a difference because you
distinction, not a difference.
There is a fucking difference. It's not like an enclosure all the way around for a leaf blower, bro.
It's gas pressing against a wall.
You have a force causing it to do that. It's not just gas. Yeah, you've got a force. Yeah. Okay, so now you're going with something else. It's not just the gas being contained by the walls surrounding it, enclosing
it's the interaction of the gas and the wall.
You have a force.
Is the Earth moving into the gas? Because the propeller is moving into the gas, like you explained, right? And colliding
the gas
with it.
Is moving into the Earth.
Is the Earth colliding with the gas?
Indeed.
Make it analogous.
Yes, it is.
The leaf blower.
Yes,
it's not analogous to the propane tank.
The gas is colliding with the surface of the Earth.
Yeah, but bro, you need to pick. Look, what I'm trying to get you to do is pick a lane because you have to. It's not analogous to both a propane tank that's containing gas because it's enclosed all the way around, and a fucking leaf blower, which obviously isn't. So pick one and discard the other, please.
No, they work perfectly.
No, they don't.
Yes, they do. They both create a scenario where the gas is pressing against a wall. It's the gas pressing against the wall. In every scenario I've mentioned, they all have that ingredient.
Take the horse blinders off, dude. Take the horse blinders off. You're not looking at this clearly.
No, that's literally
Putting
you.
Gas inside of a tank is not the same as a leaf blower.
The same thing is happening.
No, it's not. You've got pre-existing air pressure contained by a greater volume for the leaf blower example. With the propane tank, that is a closed system. And the enclosure is the tank and the walls of it itself, which are continuous and surrounding the gas all the way around. So it's got nowhere fucking else to go. That's
and
not.
And then I gave you another one that's not enclosed.
It does exactly, and that's why I'm saying they're not.
So it works in all these scenarios.
They're not analogous with one another. If you're going to say the Earth is like one, it's not necessarily like the other.
See, I didn't say to you that the Earth is like a propane tank.
Yes,
what
you
happened
did.
is what happened is I was asked for an example of a single wall where gas builds up pressure.
Yeah, if you want to call that a single wall where you've got it all the way around enclosing the gas so it has no further volume to expand into, then that just supports our point because that's exactly what we're saying it needs. If you want to call that semantically a single wall, that defeats you while you rely on semantics to try to make some kind of argument against our actual point.
The difference is I don't mind biting the bullet. Look, if I get asked for an example of a single wall where there's gas pressure and I say tank, I've given you what you've asked for, and if you want to like chimp out and do a big
I know, but
and you acknowledged it wasn't analogous.
I wasn't asked for an analogy,
saying, bro.
That's not
you
what I was asked.
You want to call it a
That's
single
what we're here
wall.
talking about.
But I wasn't asked for an analogy. I was asked for an example. I gave an example, and you said it's not an analogy.
Now you're being a bullshit artist.
Yeah, it's an example that supports what we're saying, though, which is how gas needs to be contained.
Except then I've given you another example, which is this leaf blower where there's not a container.
There is pre-existing gas pressure, and they're asking you where you got that from to begin with in order to manipulate it.
Well, that's just escaping my example, though.
Oh, is
I'm
it?
showing-
Okay, so are you
yes.
saying the Earth acts as a giant leaf blower in outer space where it forces gas to its surface, but by the same mechanisms that a leaf blower does?
I'm saying my answer to your insistence.
Well, could you just give me a yes or a no instead of the bullshit artistry, please, to what I just
Well, you
said?
did. You just asked me like a loaded bad faith weird question about the.
No, I didn't. Just give me a yes or a no, dude. Just it's not a loaded bad faith question. You can answer it either way because you're either saying what I
It
asked
is bad
you to
faith.
say.
Do you think that I'm
No,
saying
bro,
that the Earth
you're
is a leaf
either
blower?
Saying, yeah, you're either saying it is.
Do you think
or
that
it
I'm
isn't.
saying that the Earth is a leaf blower?
You're tap dancing.
You're either saying it acts like one or it doesn't. Just tell us which one it is.
Is he? Are you? Let me see if I can help this out. Are you? He's saying that the propellers on the turbine is the Earth.
So it's an example of a wall building gas pressure
Yes or no,
without
buddy?
a container.
Yes
it's
or
an
no?
Example. It's an
yes
example.
or listen.
Yes or no
he
to what?
asked you a separate question.
You didn't ask me a question.
Yes, he did. We both asked you.
There wasn't a question
yes
mark on
or
that.
no question.
Shut the fuck up, bitch.
Yeah, we've both asked you yes or no questions, closed ended, and you keep tap dancing around them. Just give a yes or
Bro,
no.
are you a fucking femboy? Shut your ugly ass. What's up, bitch?
Yeah, you're not gonna last long. See ya.
What the fuck is that?
Bottom of the panel.
Hurry, ask the question again. We just need yes or no, man.
So what's the question?
That's someone trying to bail you out, Big Tech.
What's the question?
Okay, so you're thinking, if I got this right, so yes or no, do I got this right? The propeller blade inside the leaf blower is the Earth.
What?
No. Not exactly.
Congrats, I appreciate that.
The turbine is the Earth.
No, not exactly. I'm not saying the Earth is a turbine.
The whole leaf
Very
blower as a
uncool.
whole is the Earth.
No, I'm not saying that. I'm not saying that the Earth is in any way a leaf blower.
I mean, technically that would work.
Why are you
He's spiraling?
Play out.
Why invoke it?
Technically, that could hypothetically work. If we had a flat Earth that had enough like drag on like the rise of the surface.
Who's talking suddenly? Yeah, there's a comment.
Sorry, my bad. I'll shut up.
Laughing Bird's coming to bail him out. Too.
I apologize. No, I apologize.
Why not ask me to just tell you what I meant by the leaf blower?
You should give us examples that are more analogous to the Earth.
Yeah, the leaf blower's out. We're good. So we're good now.
Yeah, so I'm not trying to give an analogy for the Earth. I'm giving an example.
That's what we're here for. That's what we do here.
But okay, but you're saying that so far I gave an analogy, and your problem with, or I gave an example, and you said that's a bad example, Big Tech, because that's an enclosed
doesn't relate
container.
to your Earth.
And I said, okay, so here's one that's not enclosed, where there's building of gas pressure. There's a
And that
difference
doesn't
between-
relate to your Earth either.
When you talk at the same time as me, it really fucks it up.
But you could
need
do
to give us examples that are relatable to the Earth.
But you could do the same thing within a man-made enclosed volume for gas. You could manipulate the gas pressure that's there. So that's why it's not telling us exactly how you can get gas pressure in the first place.
Gas pressure, as defined by the way I've given it to you several times, is a force of molecules striking a wall.
Yeah.
In both in the propane tank and in the leaf blower and in the Earth, there is gas striking a wall.
Yeah.
A big container and not
a
enclosed.
wall. Can a gas molecule strike more than
containers.
one wall? Can a gas molecule strike more than one wall? It will strike the wall of its container, not more than one wall. It will just strike one wall at a time.
Right.
So no, not one wall container. The gas molecules will strike a wall of a container.
Just
you understand?
Wall and container are synonyms.
The gas pressure in the canister, the gas is going in all directions, up, down, sideways, goes in all directions.
A gas
so it needs to be completely contained.
Ugh.
Yeah. So can we have a square canister? We can have you can have a square gas canister, propane canister. So can we have that with just one wall?
Yes.
Yes, so you can have a square propane tank with just one wall holding the gas pressure. Is that what you're claiming?
Then you've got a square wall.
No, you got one wall of a square box of a square propane tank. Is that right?
Those propane tanks are
or
not
do you need
square.
four
That'd
walls?
be an
Do you
odd
need four
propane tank.
do you need 4 walls, a roof, and a floor to hold the gas of the propane tank?
Most
or
tanks
just
are
one wall.
cylindrical or spherical.
No, get a square one. I got a square one. A square propane tank. Yes, bro. You can buy them. There's one in the chat.
Not necessarily the issue.
Moron.
So what distinction without a difference are we making here? I don't get it.
You just don't understand that your example needs to go on the outside. Your ball is the outside of the object, and that's where the gas goes. So when we ask you for an example, we need something like that. But you can't give it to us because it doesn't exist. So we might as well just move on.
Well, the Earth is the example.
Well, you can't use the example as the proof.
I know.
That's why
And
we
since
need
I
an
can't-
example.
So you're creating an unfalsifiable scenario.
No, this is your claim.
So I've given you an
did that,
example
dude.
with.
Circular
So I've
claim.
given you with
Passing the buck
with
with
the
the-
leaf. So you're unwilling to accept the leaf blower example as building
Hell
gas
no, you
pressure
just threw
without
it
a
out
container.
yourself. You yourself
it's
said
an
it
ex-
doesn't relate to the Earth.
I'm saying it's an example of building gas pressure without a container.
We don't need just random examples like that.
You're using the pre-existing
So
gas
I'm
pressure in
establishing
order
that
to have
gas
that
pressure
happen.
can be built outside of a container.
Yes, if you have the gas pressure pre-existing, and we're asking how it got there to begin with.
How did gas get into the atmosphere?
Yes,
To begin
how
with?
did you have the gas pressure within the volume in order to be able to use a leaf blower to manipulate it at all? That pre-existing gas that the leaf blower is acting on, how is that there?
Well, we all know that gas falls down when it's heavy.
Okay, take it away. Guys, take it away.
Down, doesn't it go in all directions?
No, it goes down.
Can you show us that?
Yeah.
Go ahead.
So the atmosphere is built of layers pressing down upon each other, creating more pressure at the bottom, less pressure at the top because of a downward pressing.
Where is the gas produced?
So the topmost layer, why does that not just disperse into the adjacent void?
It does absolutely as far as it can.
Okay, so it does. So what about the layer beneath it after it's dispersed? How is it not dispersing?
Well, it's blocked by the layer above, of course.
Which dispersed, so it's not blocked anymore.
As far as it could.
Yeah, so now it's exposed to the vacuum, so why didn't it just fuck off?
Well, it would if it had a force causing it to.
Well, it doesn't need to, it's just entropy.
What do you mean? Entropy?
Yeah, the gas.
Entropy would
pressure-
cause gas to go away from forces acting against that?
Well, it's going to cause it to try to equalize with the surrounding lower pressure environment.
Well, it absolutely equalizes by spreading out evenly and on 360 degrees, spherically.
You said down, now you're saying it's going every which way. All right, another contradiction.
Well, no, it's
So you
all
got
going
top
down
layer
as
of
far
the
as it can.
So you've got a layer
Goes
of
down
gas,
as far as it can.
thin, tiny layer of gas, just the lightest elements that we have, pressing down on the rest of all this gas, and it disperses, you just said, so it's not pressing down on all that gas, so your mechanism
is.
payment is already blown. How is it when it's dispersed into the adjacent void?
You just said a bunch of things that don't make sense and then asked me a question of the other.
we go.
No, I mean, you just don't know enough about the conversation to actually...
No, I do, and you're really trying to like confound it.
No, I'm not. You just don't understand what
You're trying your best to confound it.
No, I'm not, dude. You're trying your best to do that exactly. But
So
you
I'm
don't.
answering you straight up.
Yeah,
and you're
that's straight up
convoluting
projection.
your questions.
It is projection. So, like the topmost layer, that's going to be the lightest gas. You say it's all pressing down. I asked you why it wouldn't disperse. You said it will. It does. Okay,
It would
it's
if
gone.
it could,
Oh, it
is what I
can't. Why
said.
can't? Why can't it?
because it's heavy.
It's light, dude. It's going to be the lightest
Well-
gas. It's going to be the
well,
thinnest
that's-
layer. The last bit of your
compared to what? Compared to heavier
Yeah.
things, it's less heavy than the heavier ones, but it's still heavy.
Okay, it's still heavy, but it's the lightest gas that there is, and therefore it doesn't
Right.
disperse.
It's the least heavy, but still heavy.
And
the
that
least
therefore
heavy.
doesn't disperse.
That's
into
what light means. It's the least heaviness.
Right. So yeah, but heavy still. Cool double speak. Therefore, it doesn't disperse into the adjacent vacuum.
Not double speak.
Therefore, it doesn't disperse into the adjacent vacuum.
Right, because it's heavy.
Okay, demonstrate that. Demonstrate that stuff that's heavy because it's actually lighter than all the heavier stuff.
Less
will
heavy
contain
than the
stuff
heavier
that's
stuff.
heavier. Yeah.
These are the others, kids.
Demonstrate
No, I
what?
need the other ones.
What?
Keep cooking.
Was Alpha
I don't know
just
what that was.
hot micing?
Yeah, he's back on
so
mute.
demonstrate that the lightest stuff, which is heavy because it's the
Less
lightest of the heavy stuff. Yeah. Demonstrate that you can use light stuff to contain heavier stuff, specifically with gas. Go ahead.
Demonstrate that you can.
This is what you said. You shouldn't be confounded by it. It is what you said.
I'm thinking out your question. That's fine.
You're going to take a bunch of heavy gas and you're going to take light gas and use that as a container. You're going to form a container with light gas and you're going to
No.
heavier
You're
elements.
mistaking me. The container is not the gas.
Oh, okay. Then you shouldn't have said any of what you just said.
No, the container is the floor.
Oh boy, now we're back to this. The floor, which is analogous
It's
to
always
a propane
been there.
tank,
That's
which is
the
analogous-
wall. The
which is
container has to be a wall.
Which is analogous
Wall
to a
is the
propane-
floor.
Which is analogous to a propane tank, right?
Well, not exactly analogous, but it's the wall.
You
Just like
offered
the
and you handed it to us as a big win earlier.
We can go with exactly. Yeah, we can go
It
with
can't
exactly.
be that you don't understand what I'm saying.
Well, I mean, the propane tank is the
You
analogy.
understand what I'm saying?
Either you chose the wrong analogy.
No, but I think you don't understand what I'm saying because you said to me that you think my position is that the least heavy gas is the container. But that's not what I'm saying.
Yeah, that is what you said. Because you said that you had
It is not.
gas getting lighter and lighter in a gradient, and all that gas above the heaviest gas at the surface is pressing down on it to enclose it here. That is what you said, essentially.
Well, that's what's creating the downward.
Yeah, but then when we parsed that out, you went, no, it wouldn't work like that. And then you started accusing me of not understanding what you were saying when that's what you said. So now you've gone back to your
No. I
propane.
didn't say that it's the
You've gone back to
container.
your propane surface.
You said that and I corrected you.
Well, that's what was asked for. That's
The
what
least-
you
the
were
least
supposed to be answering for, Einstein.
The
That is
least
what you
heavy
said, essentially.
You've got a pattern of this.
The least heavy gas is floating on the heavier gas.
It's floating on it, and then adjacent to that is a vacuum or a container analogous to a propane tank.
Well, it's a near vacuum. Near
Okay,
absolute,
so
but not absolute. It's not an absolute. So absolute vacuum means
Okay, I got it.
less
That's
matter.
fine. You don't have to continue on.
You're in a big hurry. Wow. Let's slow it down a little bit. We don't need to
No,
hurry
let's
so much.
not. Let's not. Let's get right to it.
Too slow.
I know you need more time to think about your next excuse. So
I know that
not,
you think that if you make it really rapid, you're going to catch me and then catch 22, and then you're going to get alone and you get to
I
clap.
just did. I just did, and you're not letting me
Spiral.
get it out. So it's not analogous to a propane tank then, because a propane tank wouldn't have the topmost layer of gas just adjacent to a void. So now you got a problem.
Ooh.
That's not the claim that I was making.
It is, and now you just lie.
Okay, well.
All right, cool story, bro, with the claim I'm not making is irrelevant. Your claim's irrelevant? Let me tell you why. You said that the gassing against the wall, which is the ground.
Is he cutting out for everybody else?
Obviously said it's
just me.
Hold on. There we go. That's better. Hold on. I had to destroy a couple Russian servers real quick so my internet could be better. So now I'm back on. All right. So you said that the gas is pressing down against the wall, which is the surface of the Earth. You then said that the gas is wrapping around spherically. Okay, that's the contingent point. Because otherwise, you're just going to be going back and forth, not conceding to what Mr. Heretic is saying, right? And you could argue till you're blue in the face. He could argue till he's blue in the face. However, we already agreed that an infinite amount of permutations of shape can fit inside of a container or fit without a container. So then that brings us down to the surface that supposedly the gas is pressing on. Okay, cool. You claimed it was spherical. That's your real claim. So where's the proof for that?
Okay, so we're leaving the gas talk. Now we're going down to what's the shape of the ground.
I mean, you're going around in circles with the gas talk, right? So there's no progress being made. So let's just table that. And let me tell you why. Because it's a non-contingent. It doesn't decide what the shape of the Earth is in any way, shape, or form. But you did claim that your gas is wrapped around a spherical shape. So go ahead and prove that.
No.
Bro, what?
Sounds good.
Yeah, I think we're done here.
Yeah, little tech.
All right, that was easy.
Test. Yeah, your scoreboard keeping skills are awful, Big Tech.
Test, Big Tech.
Who's saying test? All right.
Why'd you bail out, Big Tech? All that big talk for what? For you to bail out?
Phantom Thoughts. Yeah, I heard you. Yeah, he was saying test.
Oh, why did you bail out, Big Tech?
Who's saying that? Hold on. Say that again. I didn't see your name.
Tis I.
Oh, hello, old hoss.
Yeah, why did you bail out?
Because I was enjoying the conversation about gas, and then the fellow.
Yeah, but in your conversation about gas, you inserted that claim about the Earth being a ball.
Right.
So it was important to you then, when you were trying to win, but when you realized you were lost, you didn't want to talk about it?
No, I was asked to.
You just wasted everyone's time?
I was asked to entertain another conversation that I've already had.
Yeah, but you had that sewed into your last argument. You hemmed it into your last argument. You're the one talking about catch-22s. You're the one that's doing it to yourself.
Okay.
So why did you bail out?
Because I'm not interested in entertaining that argument.
But that is the crux of the discussion.
Well, no, we were having discussion about the nature of gas and pressure.
Yeah, that you're insisting is occurring around a ball, you told us. You want it both ways. You're telling us the gas pressure, when the Earth's ground is the floor, you're talking about a concave Earth. And then when you want to talk about, when we bring up the ball in the textbooks, you run.
Concave Earth.
Not a good look.
Well, I don't have an ego.
For the record, scorekeeper.
Okay, well, I'm the only reason I brought scores to try to get under your skin, because I know you guys have big egos.
No, don't try do. Now you're projecting. You're the one that ran away from it. You ran away from the argument.
You guys are really invested in winning this argument. You like,
dude, you were the one that was telling us what the score was for the last hour.
Yeah, only because I know it gets under your skin.
Well, you're a bad scorekeeper.
All right. Well, I only say
it turns out you're a bad scorekeeper, correct?
I only say it because I know it matters to you guys. It doesn't matter to me.
That makes absolutely no sense.
Well, fine. It's a rhetorical device. Look up the word.
I guess that's what you're left with. It's better than listening to you tap dance. So yeah, it's good. It's good for the audience to hear that your gas pressure evidence, you somehow sewed in globe Earth, but now you don't want to talk about globe Earth.
The gas pressure gaslight has concluded.
Well, because I wasn't done talking about the gas pressure, and the fella asked me to pivot to a different discussion, and I said no.
Well, every time you talked about gas pressure, once we got to ran the string, you said, well, that wasn't analogous to the Earth. That's not analogous to the gas pressure on the Earth. It was just an example.
Well, it's an absurd request to show me something on the Earth that's just like the Earth.
Well, then it's an absurd claim, brother.
Wrong.
Yeah, if the standard of evidence is absurd to request, then the claim itself is the problem. Re-examine it.
No, it's an absurd claim. Show me something in the Earth that's just like the Earth, which is not on an Earth.
I'm going to flip it on us. Show me something else like this thing that I'm claiming.
I don't know, worm?
Or demonstrating anyway. That's your problem, man.
Show me something in your body that's just like your body.
Liver, a heart, there's all sorts.
A liver doesn't have legs. Your body has legs. That's not a good analogy.
Oh, yeah, sorry, maybe I misheard.
That's not what happened.
I mean, I was just thinking like a liver.
No, show me something in your body that's just like your body.
Well, hold on.
You can't do it? Then I guess your body doesn't.
Wine has legs, and wine gets processed through the liver.
We don't have to take the bait, guys. Yeah, we don't have to take the bait.
Come on. You can't show me something inside your body that's analogous to your body?
If I have to keep on talking.
The guy who ran away from proving the globe or even talking about it is now going into a Slim Goodbody episode.
Are you talking about D-Muck?
Not cool.
I know someone who can. A pregnant lady.
That'll trigger him.
Ooh, that was actually pretty good.
Got him.
You got a baby inside your body?
Yeah, so there are other things like your body that you can point to. Anything else like the Earth that you can point to? Or just another failed analogy attempt?
Sorry, what was that?
Never mind.
Okay.
Classic. So
he bailed out because he's not interested.
So have we talked about curvature with him yet, or
bailed out?
Yeah, he just for like 7 hours. We already did that like a long time ago. And I was asked to come back and do it again with another person. So I said, nah.
Damn. So that's you're on fumes right now.
Yeah.
You flamed out, Big Tech.
Why do you keep trying to get under my skin, guy?
Sounds like I haven't tried. Sounds like I did.
Why do you keep trying to do that? You're obviously trying
Dude,
to do
I just do what I do.
Okay.
I don't
You're just a guy who does
come
what
up
he
with
does.
a list of things to try to do today. I just did it, I guess. I don't know.
Do what I do, and I just do it.
Why does it get so under your skin that I'm pointing out that you ran away from the crux of this discussion?
That's just distracting and annoying.
You had what's distracting and annoying?
You and what you're doing. Your insertions into this conversation are distracting and annoying.
Okay, putting up with you has also been equally annoying. But let's get back on track here, brother. We talk about the Earth, so let's focus, please. Heretic.
Well, it's just funny that he's trying to distract away from him being called out on his distraction efforts. Anyhow, any further claims, sir? Big Tech?
Further claims. No, I think I'm good. No, hey, forgive if I got it wrong. I got it wrong, but I thought that you guys like when somebody comes in to try to talk about this stuff with you, and then you get to like fight. So I thought I was doing a service to the group.
Yeah, it's appreciated. Thanks.
Yeah, but you said you didn't want to talk about it.
Yeah, W content.
Nice. So thank you, Big Tech.
How many times have you done this before? Is this your first time?
Thanking yourself.
He's been here before.
Yeah, I've been in this one before. One time in here.
One time.
Yeah.
Okay.
But I've talked with flat earthers plenty. I'm fascinated by flat earthers. I'm not actually interested in flat Earth itself, more the flat earthers as the people.
Yeah,
what is it? You're fascinated or you're irritated?
Analysis.
Yeah, I'm fascinated with it as a phenomenon.
What is it? What is that, a flat earther?
A person who is entertaining the idea that the world as presented to us is a big lie.
That's atheist, dude. That's not flat earther.
We're entertaining that as well, apparently.
Yeah, that's you got your definitions. An atheist is the one who thinks that the whole world, all presenting some sort of supernatural deity, they're all wrong. Every single one of them is wrong. Only they know that there is no supernatural world. There's only a physical world. There's no spiritual realm. There's no metaphysical world. None of it exists. Everybody else is completely delusional. That's you got your definitions crossed there.
But I wasn't talking about God. I was talking about the Earth.
Yeah, you're talking about people.
Okay, let's talk about it then. Let's talk about it. So
flat earthers are somebody who rejects X, the majority.
Globe is the obvious de facto place. So everything else.
So flat Earth is like a globe atheist.
No, it ain't. Hold on.
Fine, obvious.
Hold on. We said the world we've been presented was a big lie. Okay, so the world that we've been presented is a turn of a phrase, sure, but the world as it presents itself as flat and stationary. So that is what's being claimed as a deception, and the actual truth is something else that you don't perceive in the first order. Now, we know this is a fact, and it's written about in psychological literature in the childhood development stages. The children operate in the world as if it's flat and stationary. Old at a particular time it isn't. Then they have a dual system of interpretation of the phenomenological world for a while, until they finally concede to what they're being taught, that the Earth is a globe, even though it contradicts their previous experience. So it's actually the case that the people who are thinking that the world is a deception they've been told is the globers.
Okay. Well, surely you know that, we are presented, like you said, we're presented at an age with the idea that when the sun goes down, it's not actually going into the water, it's going around the curve. Because it looks like it goes in the water. Daddy, why did the sun go in the water? It didn't go into the water, son. It went over the edge. It went around the horizon.
So now he wants to talk about the curve of the Earth.
So it looks like it goes in the water, but then we're told it doesn't go in the water. It goes somewhere else. And then the story that we're told about that is that it's a globe, and then we went to the moon and things like that.
I agree with you.
Flat Earthers believe that that's all.
I agree with you. No, I agree with you. I agree with you 100% that it's a story.
Yeah. So flat Earthers believe that the story is
it's a lie. Yeah, it's a fib.
You believe that it's a fib.
No.
You believe that rockets go nowhere.
Yeah, I know that what they've presented on TV as a moonwalk is a fib.
And you believe that was a big deception.
Well, you don't need flat Earth for that. The vast majority of people who think the moon mission was a hoax hate flat Earthers more than you do.
Yeah,
like Bart
the official
Michelle, Alex Jones. These guys are disgusted, literally disgusted by flat Earthers.
In fact, I'm a member of one such organization that debunks the moon missions very easily, by the way. However, if I mention flat Earth there, I'll be banned.
Nice. Yeah, so there's factions, there's levels to it, right? So I'm interested in all sorts of different types of. Do you take offense to calling it a conspiracy theory?
Well, no. Let me tell you. The Earth is flat.
I don't want to be offensive.
The Earth is flat. Therefore, the claims that are being put out there as truths that it's not would either be misrepresentations of the facts, or they could rise to a lie, depending on the nature of the person who has the information and what they're saying about it.
It's not conspiracy theorizing, it's conspiracy identifying.
Yeah, so the nature of secret conspiracy is that it's hard to expose, and then you theorize the nature of who's conspiring.
No,
it's not hard to expose. It's not hard to expose. Hold on. I can put you an article right now with parallaxal stereography applied to the moon images, proving that the mountains that they claim were a certain distance from the crater area in which they landed are actually so close that it's impossible for them to have been taken on the topography of the moon.
Yeah, but who conspired?
Guessing.
Who conspired to present that false evidence? Who was it?
It doesn't matter. The evidence itself is
that's
false.
My
so
point,
who conspired is irrelevant.
That's what's hard to.
Let me tell you. If the astronauts are in if the astronauts are in a location that doesn't have the topography range necessary, proven by stereography.
No, I agree. If I grant you all that, you're still not. That doesn't address what I said, though.
What is it? You want to know who's responsible? Is that your point?
You don't have to know who exactly
what I said
told the lie for the lie to be identified.
I know that, but I said the conspiracy.
Well, no, you don't. Apparently, you don't know that.
Okay,
because you're like, you're theorizing that the.
Can you settle down? The conspiracy is not the lie. The conspiracy is the liars, the conspirators.
No,
correct.
That's the conspiracy.
What's the question you want to know? You want to know who they are?
Conspiracy
why they
is the
did
people who conspired.
Okay, so what do you want to know about it? Do you want to know who they are, or do you want to know why they did it? Which one?
I'm just addressing the term. Conspiracy theory is we're theorizing that there has been conspiring. People have been whispering together to code.
No, dude, you're watering it down.
There had to have been.
Right.
Had to have been.
And the nature of uncovering that is difficult, which is what I said. And you said,
that's
no, it's
fine.
easy.
That's fine.
But then you said to the moon.
No, it's easy to understand that there had to be conspiring.
Right.
If the moon mission was fake and the evidence that they presented was fake, that means at least more than one person, because we know that more than multiple people were involved. That is the presenters from the government, the actual
Armstrong
agents who did the task.
Yeah, listen, stop waiting to talk, dude, because you're lost in this whole thing.
I'm really not. Like I get.
Yeah, you don't listen. You just wait to talk. There is no theorizing that a conspiracy has been perpetrated.
No, you literally are theorizing. You could just
dude.
No, yes.
If the Earth
it's deduction. No, it's not a theory. It's not a theory. If you demonstrate that the evidence presented is false, and the people who presented the evidence that are on multiple levels are presenting it as true, and they must have had prima facie knowledge in the first instance because they're direct actors involved. By actor, I don't mean like a movie actor. I just mean agents, actors, whatever. Then you know by deductive necessity that they worked together to perpetrate something that was untrue. It's a conspiracy, and that's not a theory. That's deductive fact.
Yeah, and it's hinged on a premise that started with the word if.
What word if?
If this is fake, then
yes, true.
Logic. Yeah.
So the premise is not a theory.
I've convinced myself. We have convinced ourselves that was fake.
Wow, dude, you're really coping hard.
That's fine. Fine. If it's shown that it's fake, then all the other things follow. Correct?
Yes.
Okay.
If you guys are right about
there you
that,
go.
then the other things do follow. I agree with you.
Then it's not a conspiracy theory at that point.
The very fact that you won't talk about the crux of this entire conversation proves that you need it to just be in some foggy unknown. But these guys are theorizing still.
Well, look,
for example,
you're taking it. I think if I could say, I think you're taking it further than I mean it. I mean, like you're using logic, and I agree with you. So logically, you can deduce these things. But logic itself is a theory. It's like a theoretical framework for assessing the correctness of
brain in a jar.
So I'm saying you're using logic, and that's what I mean by theorizing. So you're doing a logical deduction. That is a theorizing.
Yeah, but the word you use is a compound word, conspiracy theory. And
so if I said you're conspiracy logicking, I'm doing conspiracy.
No, conspiracy identifying.
Okay, I mean you're acting like theory means like we don't know. It's like I'm
well, the term conspiracy theory and conspiracy theorist is a classic poisoning the well.
Which is why I
trying to denigrate those who have identified the conspiracy.
I'm not.
Well, the term conspiracy theorist showed up when people were able to see that the narrative that was presented was bollocks.
Listen, I'm just.
I am listening. I'm Fraser Crane.
It's a fine term. I don't mean it in a derogatory or denigrating way.
Fine. All right, we agree. We agree that words are token meaning pairs, and they have connotative and denotative senses depending on the context. So now that you've parsed out your context, we can move on, for goodness sakes.
Yeah. Yeah, so yeah, that's why I'm here. I'm interested in flat earthers and the theorizing, the logicking, the deductions, and the investigating.
Yet you won't examine the metrics of this ball Earth that they've told us is spinning and hurtling through outer space.
No, I examine it a lot. But what I find is that oftentimes, here's what
you just ran away from it 20 minutes ago.
I know that you'll agree with this. I know that you know this for sure. Is that when I hear the question, "What's your proof that the Earth's round?" The next thing that I say out of my mouth is going to be met with, "Aha! Here's why that's fucking garbage," and blah 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 blah. And I'm going to get a
no, dude. You're the one that's been taking back everything. Every claim you've made tonight, you've taken it back. So I would suspect you would continue the pattern and do it yourself.
All right, no worries. We'll solve this. It's very simple. Okay. Crux of the issue is whether the Earth is flat or not. Everything else flows from that. So if you, it's not even so much that you can't prove your globe, which you can't. It's that the Earth is flat. So Earth, right, measured with laser transit, demonstrates that the alleged curved water doesn't exist because of Pascal's principle in hydrostatic equilibrium. That water is flat and level on the surface. Once you measure a segment of water and you apply the physics throughout the territory, you end up with 70% is flat, therefore it's flat. So now that we know the Earth is flat, all the other premises which follow by deduction follow. Yeah, laser transit measurements, correct.
Mm-hmm. All right.
Laser transit is an efficient methodology. It's also a targeting methodology used by the military. It's a very validated methodology.
Can't be any problems with that.
And we are live.
The main issue for you is that if you don't understand flat Earth, you have no way of getting back to your globe.
Earth is flat.
You couldn't start, if you think it's science, you've got no way of starting off with the first model that people used and slowly changing it over the years to get to the first heliocentric models to then get to the current heliocentric models. You've burnt the church, being deeply confused about what you should have observed yourself. So you could slap a conspiracy sticker on it for reasons you can't explain or take questions on.
I'll tell you, my biggest hang up is when the sun goes down over the horizon, it doesn't look like it's going far away.
Yeah, it does.
It literally does not look like that.
That's the best part.
I've seen things go far away a lot of times, and it doesn't look like it's going far
away. If you roll the clock back, these observations predate all heliocentric models.
Like what it really looks like is that it's going into the water over the coast. It looks like,
I mean, that's cool, dude.
Looks like it's going.
That's cool. So your hang up is what it looks like. Okay.
Yeah.
When I told you the water's measured flat.
Yeah, but I don't know if you did that right.
Yeah, sure, dude.
But I don't. I mean, how could I validate?
Well, I don't know. I certainly don't know if your claim of what it looks like is right.
Yeah,
we all know for a fact that there could be misinterpretation of optical information in your field of view, correct?
I know, but you're telling me there's optics involved in your laser test. Maybe you're misinterpreting.
Those are different, dude. One is perspective and the way things are in your field of view, and the other is a correlated light beam.
It's just like I got these issues. Like it doesn't look like it's going far away, and when I look at the moon, it looks like a sphere. To me, it just looks like a ball.
Okay, that's great. So let's say I agree with you that the moon is a ball. What does that have to do with the shape of the Earth?
I don't know how Flat Earth explains that there's a big ball in the sky.
Yeah, well, the water looks flat.
Oh, it's very simple. It's very simple, dude. What you just said, dude, I just want to be frank with you. What you just said is completely stupid. Let me explain it to you.
Okay.
Let me explain it to you.
Okay.
How does another object that's not the object explain the other object? Does that make any sense?
No, that's not the connection I'm making.
Okay, then why don't you parse it out a little better?
Because in the story, and we agree that it's a story, the story of the Earth being a globe, when I see the sun do what it does on the sunset, and when I see that other ball in the sky, and they tell me, oh, the sun is disappearing over the horizon because the Earth is a ball spinning, and the moon is a ball in the sky that's orbiting around this ball, that all makes sense to me. And what you're telling me doesn't make sense. So it's hard for me to like give credence.
Okay, so
you're lost in mythology.
The moon not being the Earth, does that make sense?
Yes.
Absolutely. So if the Earth is a square and the moon is not the Earth, does the Earth being a square change what the moon is?
Nope.
Correct. So the only incongruence here is that it's incongruent with a presuppositional bias towards a story. Because if the Earth is flat and the moon is a sphere, right, then they're two separate things. I mean, it's really that simple. It's not any more complicated than that.
But so what's your story about why there's a big ball up there?
I don't need a story. There is one. There is a moon. Yeah, see, that's the difference between you and me. I don't.
Yeah, you don't need to know why. I wanna.
Dude, your story is that some asteroid blasted off a quarter of Earth and turned it.
I have an answer.
Into a dust cloud that turned into a moon.
I have an answer.
Cool
so,
story.
At a long time, I'll tell you a cool story, man. A long time in the distant past, an intelligence visited the Earth and put the moon in the sky. There you go.
How does it stay up there?
How does it stay up there? Very simple. There's no reason why it wouldn't. Problem solved.
Yeah, that's not a good answer.
Oh, really? Why not?
Yeah, you don't tell me a positive with a negative.
Oh, no, I'm serious. Like, how does it stay up there connotes the idea that it would be doing something other than what it's doing, like going somewhere else or falling down. Why would it do any of those things?
Yeah, why does it do what it do?
Because the intelligence that put it there programmed it to be there and gave it what it needed to do what it needed. Problem solved.
By what means? Programmed it?
Well, I'll tell you what. When I
story's got a lot of moving
there,
parts.
No, it's actually quite elegant.
You're invoking an ancient intelligence that programmed the thing to do stuff.
Yeah, what's wrong with that? What's wrong with that, dude? The globe model invokes ancient singularities that have no reason for first motion that all of a sudden cause everything. You think that my story's more fantastical than that garbage?
Yes. In my estimation.
Yeah, so you're in your estimation, something that's not moving and begin moving, violating the laws of motion, but my story is crazy.
Well, like my story has
I thought you were bad at keeping score earlier.
No, my story, like in the present though, just has like a dynamic system that I can wrap my head around. And yours doesn't.
And that's cool.
I don't understand the dynamics of how the ball
Yeah, that's cool, dude. Yep, that's cool. So kinematic equivalence doesn't mean reality because that would be a reification fallacy, okay?
Right, but I'm wrapping my head around the dynamics at play in the system.
I mean, that's cool.
They told me.
I mean, that's great.
But your system doesn't.
You need to
wrap my head around that. Like, why was there a 24-hour sun in Antarctica? I can't really wrap my head around that.
There's simpleton.
Well, that's fine.
I guess I'm just too stupid.
It's fine that you can't.
The big brain.
It's fine that you can't, and that's fine. Problem is, what you got to wrap your head around is contingents and non-contingents. What the sun is doing and what the moon is doing are not contingent upon the shape of the Earth.
Yeah, I'm not claiming.
If the Earth measures flat, it's flat. If the Earth measures to be a globe, it's a globe, regardless of the models of interpretation about the cosmos. For example, epicycles.
I agree with you that if
are
the
most
are correct, then it's flat.
Yeah.
Well,
yeah, exactly.
This guy can't even wrap his mind around a water-seeking level. He's in denial of that.
Yeah, well, water doesn't seek.
Now you're splitting hairs that aren't there.
Well, why
you know
don't
damn well what I mean.
Why don't you say what you mean?
Takes one to know one.
Bizarre. Why don't you say something normal instead of bizarre?
Well, how were you able to respond if it was so bizarre?
I would respond it by.
You're the one that's unable to wrap your mind around this simple concept of water's surface being flat and level. That's you. Maybe you did it wrong.
Well, level doesn't mean flat.
That's a cope.
It's not flat and level. It's curved and level.
Cool story.
I think it's cooler than yours.
Delirious, dude.
Like mine makes sense, and I can.
You're denying the simplicity of water right in front of your face to save this water ball mythology. It's kind of sad.
You're denying the simplicity of a circle, a sphere, a ball. It's the simplest thing in the world.
What?
I thought it was an oblate spheroid.
Oh my goodness, dude.
You ever seen a ball?
Yeah, have you ever seen a ball that wasn't created?
Here comes his ball chant.
No, I'm being serious. Have you ever seen a ball?
Yeah.
That was not created.
I've never seen anything that was not created.
Okay.
I'm not claiming no creation.
Okay, perfect. So, but I'm talking about natural processes. Show me a bunch of balls.
Pause.
You broke them. Finally.
You want me to show you a bunch of balls? Wait, are you serious?
I'm serious.
You want me to show you some balls in nature?
Dude, you're an idiot.
Because I mean, like, if I said that there's a ball in the sky called the moon, you said that was created by an unnatural process. It was created by ancient intelligences.
Yeah, okay, cool story. I said I would concede to you that it was a ball and it would have nothing to do with the earth. Okay.
But then you told me an unnatural story.
No, it was perfectly natural. Why?
Well, you got some super intelligence that we've never seen that came and parked it and programmed it by some unknown means or dynamics. And
well, you are. I thought you were. I thought you just told me you're a creationist.
Yeah, but I don't know how that works. I didn't invoke a supernatural power that programs things.
Oh, really? So a creator of everything would be supernatural causation, would it not?
I don't know.
Holy dude. If a creator created the natural world, then he would be supernatural, right?
He?
Yeah, pronouns are demarcations. What do you want me to say? It, to make your feelings... I don't know. Let's just call it an it. There we go.
Yeah, I guess. No, but I think creation is natural, and the creator, as such, might also be natural. I don't know if it has to be supernatural.
Okay, so then we still end up with that it's perfectly rational, even with that view you just said, that a superintelligence who's capable of creating things created the moon. Good grief.
No, but I mean, it's like a super intelligence is like.
It sounds equally complicated.
Never seen one of those. I mean, I would say like an apple tree creates apples. Is it a super intelligence?
Well,
is it unnatural?
Here, I got one for you. The super intelligence that Newton talked about. Newton said that the model is so mathematically perfect, like the moon, the sun, the earth, so mathematically perfect that it could have only been created by a supernatural being, because nature's too chaotic, too random. There's nothing in nature is that mathematically perfect. It's all a bunch of averages. And then he said the only supernatural being that he knows of with that much power, splendor, and glory is the Heavenly Father of the Bible, and this cannot be denied. His read of physics and calculus perfectly demonstrate God of the Bible. So that is what you'd be looking at. Why is Newton wrong and right at exactly the same time? Or Copernicus. Copernicus said that the model has perfect circles in perfect circular orbits. It is contained by a firmament, right outside of Saturn. Then he said that all these things are so perfect that they couldn't have been created naturally. A perfect circle doesn't exist in nature. Therefore, God of the Bible made the heliocentric model for humans. This is a human environment that God made, and God made it this way. So either way, if you disagree with flat earthers telling you that it's created by a creator, you're also disagreeing with heliocentric. This is why CB told you earlier, when you come in here with bring your own cosmology day, no one really gives a shit. Because at that point, you're saying everybody in the whole world is lying to you. You're the only one with your own individual cosmology that's correct. Everybody else is wrong. Even people who kind of seem like they agree with you or people who disagree with you, they all got it wrong. You've got some secret king knowledge that you've cracked the deeper questions of why we're here using your own epistemology that you never explained or took questions on.
Yeah, I disagree with Newton saying that it was the God of the Bible that created everything. I think that's absurd.
Well,
really, how is it absurd? How is it absurd?
Well, the Bible was invented by ancient Jews, and it's bullshit.
Care about that. I'm talking about the concept. How is the concept absurd?
The concept of the God of the Bible creating the universe? Well, starting with the premise I just gave you.
So describe for me, yep. Yeah, that's a cool story. Describe for me the qualities of the agent known as the God of the Bible.
He's the jealous lawgiver who chose the Hebrews to heal the world.
Okay, that's irrelevant to the ability to create a world or not. Okay, I'm talking about qualities that are relevant to being able to create a universe.
Oh. I know nothing of those qualities. They're not revealed, even in the Bible.
Yeah, they are.
By what means was he able to create the universe?
Yeah, it says.
He said, "Let there be."
Yeah.
So he spoke with his mouth.
Oh, okay. So let's say you say that that's a literalism. Yeah, exactly.
Air?
The idea that it's exactly. Now you're starting to get it.
Yeah, so it's obviously, even if it was real, it's obviously something.
No. You're missing it. He doesn't need air or a tongue to create.
But he spoke. How do you speak without a mouth?
Oh my goodness, dude.
He said, "Let there be light."
You don't understand literature, do you, bro?
That's what I was saying, and you told me to stop, and you said I don't get it. I was saying, even if it's true, it's obviously some sort of metaphor.
They're using anthropomorphic language, dude. Exactly.
Right, to describe something that is not actually literally described, so I don't actually know his qualities. Which is what I said.
Yes, you do. The qualities of being pure spirit. That's one quality.
What's that?
Exactly. What is it?
I don't know, so I can't claim knowledge of that.
It's not rocks. Right? It's something greater than material. Yes. What the point is that it's greater than material.
What? And what do we even mean?
You tell me, dude. You're the guy that believes that something that's not moving can start moving in violation of the laws of motion. And then you want to tell me that a moon. You just said it earlier.
You put a straw man on me.
You said it earlier, dude. Hold on.
Who's hot micing like crazy?
Is that Alpha again? He might have timed back. The timeout's is 20 to 40 minutes.
40 minutes. Yeah. Yeah. So if you believe in do you believe in the Big Bang?
I don't know. I don't even know how to describe that accurately. I don't know if anybody even knows what that means. So how do you believe in it? It's like some sort of
right. So we have no idea to be able to describe what it means for the inception of the universe. But then the idea that a being that's greater than the universe created the universe is somehow crazy. I mean, are you kidding me?
I'm not saying it's crazy. I'm just saying it's like a different category of story.
Right. So it's called supernatural causation.
Yeah.
Okay. Natural causation is insufficient to get the world in which we live, right? Because it violates the laws of physics and the laws of entropy and the laws of motion.
I don't know if I buy that.
Well, I mean, what's the first law of motion? An object at rest stays at rest until acted on by an outside force.
Right. Just because we don't know what the force was doesn't mean it was God.
Okay, at this point, I didn't say it definitely was.
Okay, good.
Hey, what I said is it requires what? An outside force. So if the natural world isn't describing that force, then the force must come from the supernatural.
Well, no, the thing is, like, just because we can't see what the force was doesn't mean it was outside. If everything emerged from a single point, the size of the...
If there's no motion in the natural world, in order for there to begin motion, it must be acted on by an outside force.
If there's no motion. So when was that?
Hey, you bring up a good point. It either was or it wasn't. If it wasn't, then that means there was motion in perpetuity. A first cause fallacy and an infinite regression.
Yeah, I mean, just like, did the fourth dimensional unicorn fart and then the universe blasted out of its ass? Like, I don't know. But that would have caused...
So you're already... Exactly. So you're already agreeing to extra-dimensional agency that is supernatural is the most logical reason for the natural things that occur in violation of natural law.
So my point is that if there's an unknown, we can't claim knowledge based on that.
Right. So in other words, I don't need to make up a bullshit story about what the moon is doing. If the earth is flat, it's flat, and it has no bearing on any story I make up about whether the moon is a sentient agent with a giant alien living inside.
Well, yeah, if you like that story, I'm interested in you. I told you.
It's not about liking. It's not about liking it, though.
No, but you do like it. You like it better than I do. I don't like it, so I don't buy it. Because I don't like it.
No. I don't buy that story. No, bro. I don't need a story. The moral of the story is I don't need a story about what the moon is doing. I know
You're
that.
You're a flat earther. You don't need a story.
Bro.
I'm a glober. I need a story. You're a flat earther. You don't need a story.
And I need to, and I know, and I need to clip out what you just said because it was comedy gold.
Well, there you go. I'm here to please. I am a glober. I like a good story. Globe has a good story. Your shit has shit story.
Man, dude, I agree with you. I agree with you 100% that globers desperately need a story. I agree.
Yeah. Well, we like a good story. I think that's very human of me. To like a good story.
But yeah, so you think that a rock's just floating in a vacuum is a cool story. I think that a sentient agent specifically designing a world for humans is a much better story.
So you like a story too. So we're both story enjoyers. I think your story is bizarre. You think mine's bizarre. And then we handshake and we...
So big tech, when's the moon going to get dragged into the earth?
I don't know.
What's your story? You like your story, don't you?
No, here I got a better story that the one of the astronauts had said when he went to the moon, he saw the universe as being fully created, engineered by a supremely intelligent being.
Oh, I looked it up. The answer Google tells me in the Google story, it's 65 billion years from now. That's when the moon will deorbit. 65 billion years.
Yeah, cool story.
Yeah.
65 billion years from now, huh?
So we got a minute. No hurry.
So you does that not give you a hint that perhaps you're lost and you were born into some sort of outer space mythology?
Like, what's that based on? What do you think they based that on?
Yeah, doesn't that sounds a lot like to me like priests shaking hands behind curtains? It's weird.
Okay. Sounds to me like.
I mean, how do you have
sounds
such
to me like
certainty of a story that will come to fruition in 65 billion years?
Sounds like astrophysics to me. If they're like, oh, it's this many inches away and it's coming closer to us this many inches.
So maybe you do sort of you do get a whiff of this whole fabric of story that you're enveloped in.
Yeah, I think it's cool.
Cool, dude.
But some stories are true. And I think this story is true also, which makes it extra cool.
Extra cool?
True because why?
Dude.
Well, it seems to correspond with...
You're sort of highlighting your naivety.
Okay.
Cool.
Which group of people took the Apollo program to court looking for proof of what they did? Was it American Atheist?
I don't know.
Look up that part of the story. This is why the controlled demolition of atheism was such a spectacular thing. That in the 1960s and 70s, atheists were the most powerful speakers in America, constantly punching up, prove it, holding government to account. And now, in the 2020s or 2000s, you've got atheists who can't figure out how government would even lie to them when government's first claim was, do not trust government, only trust God. You lost the plot, dude. Your story...
Are you calling me an atheist? Wait a minute. That's why I'm having trouble following you.
You called yourself an atheist earlier.
I never did that. I am not an atheist.
Oh, I guess I misheard you then.
Oh, okay.
It's okay to clear it up.
Yeah, I was wondering where that was coming from. I felt like you were talking to someone.
Wait, I was thinking the same thing as you, Craig. Like, what?
Maybe he just flips between atheist and non-atheist.
Well, he kind of hinted towards earlier that God was nature. The creator was nature. Nature created nature. God is nature. Nature is God. There is no God.
No, I'm very tapped in on believing in God. I just don't believe in the God the Jews invented.
Do you find it funny that most of your story is made up by Catholics? And here you, all you, I don't know what I would call you, 21st century wannabe intellects have no idea all this stuff you chant as science is just the creation of the Catholics?
Is it?
Yeah, the heliocentric model that's fully contained inside the Catholic Church.
Rather, more specifically, it's the Jesuits, which is like a derivative of Catholic Church of sorts.
Oh yeah, it's like a subcult or not cult.
Yeah,
culture.
Yeah, guys wearing collars nonetheless. All these pseudo-intellectuals are just chanting the edicts of dudes with a lot of time on their hands who wear collars.
It's like the rewriting of history, too. Like, when people think, oh, the Catholic Church was against Galileo. No, the Pope said, hey, keep this shit to ourselves. The plebs don't need to know this. The plebs just need to know what we tell them, and they'll comply. We'll control them. And Galileo's like, well, I think everyone should know about this. This is kind of important. This can change humanity if people really understand the vastness and greatness of the glory of God. And the Pope's like, you better keep your mouth shut. I'm telling you, I'm the word of God on earth. And Galileo's like, hold my beer. So then during the height of the Inquisition, Galileo disrespected the word of God on earth. He got sent to his room with dinner. I mean, even by today's standards, he lived lavishly, like an indoor and outdoor pool, like a maze, like a flower maze. I mean, this guy lived lavish, even if you were to say that your basic person today. So then he and other people were getting burnt at the stake for having a lazy eye. And then you fast forward a couple of years later, and the Catholic Church apologizes to Galileo. Sorry, we sent you to your room with dinner. But all the other people, the millions of people who were prosecuted for heresy, no, they're not pardoned at all. They were found guilty. Like, what the fuck? Like, that's really what they're... And then they're going to say, yeah, yay, Catholic Church. Thank you for bringing us the heliocentric model. That was really wrong that you didn't even slap Galileo on the hand. You could just go to any Catholic church and just ask.
Wait, what's your point? Was Galileo was a good guy in this story or a bad guy?
No, there really isn't any good or bad. It's just people doing the best they can with what they got.
Right. So
storytellers.
What are we getting at here, though?
We're getting at here is if you think the Catholic Church is wrong, use that. Don't run from it. Dive all the way into that motherfucker. The Catholic Church is wrong, therefore, why would you say they're also right about this sun-centric model?
Oh, I see. Well, it seems like that would be a slippery slope into a genetic fallacy right there, right? So if it came from the guys I disagree with, it must be wrong.
Because they added in supernatural claims to it. It's not a genetic fallacy. You're not saying they're wrong because they're Catholics. They're wrong because they tied in their creation myth with their religion.
Right. So I just take the good. I just don't throw out the baby with the bathwater. So I throw out their religion and I keep the heliocentrism,
which is incompatible. That's a disjointed, other garbage, nonsensical idea.
Yeah, you're the one. Listen, you're the one that's wanting to give the beginning of this thing nature. Well, you were kind of it sounds like you don't know. I mean, who does? But what happened at the beginning of everything? We weren't there. But you were saying it's nature, but these guys were deeply religious in how they came up with the story. So that's all I'm saying is what is thought to be science is based on people's who are long dead's religious preferences. How that's morphed over time. I just think that's ironic. That's all I'm saying. It's how strange is that's happened.
Well, it's had to morph because they start with a faulty premise, right? The faulty premise was God from the Old Testament made everything. And then they were extrapolating off of that, so they had to twist what they found to match that. But now we can go like, well,
yeah,
okay,
but you think
let's not do that.
You think everything is this ever expanding universe into the void with black holes.
I don't know if it's ever expanding or not.
Well, so. What are you? You're creating your own cosmology?
Well, no, I know they have questions about these things of like dark matter and dark energy, and they're grasping to sort of like understand the observations that they're making, and they made some predictions of what they'd find, and they found something else.
And you're wrapped up. You're wrapped up in a quote work of people's wishful thinking.
Yeah, but
without even realizing it. No, and when you do realize it, you just kind of like, well, so are you.
Well, no, I don't have to have an answer for everything. So it's like if I'm working on a car and if I can get a good idea how it works.
Well, how about whether or not the Earth's a ball?
But I don't have to.
How about start with that?
Well, hold on.
How about if this whole outer space story has any credence to begin with? Start with the ball.
Yeah. Okay. I have no problem with the ball.
So okay. Dude, fine. But you all you have are claims and wishful thinking that it's a ball.
Well, I could say the same thing about you saying it's flat.
Okay, so I'm exerting wishful thinking upon the surface of water?
Yeah.
No. Do you have any evidence of water that's contained having convexity at its surface? Because I do. I have the opposite. I don't have wishful thoughts. I have flat and level water. So do you have curved water?
Yeah, the ocean. And every lake.
Those are waves. Those are for surfers.
No, it's got convexity at the surface at scale. It's curved.
Oh.
The ships go over the horizon.
Can you demonstrate that, or are you just going to tell me the tale?
Yeah,
how far did you measure? How far did you measure in your measurement of flatness over water you're claiming? How far was that measurement?
Well, 80.
Well, who's speaking up now?
What do you mean any?
Are you talking to me?
Oh, it's Phantom Thought.
How long of a measurement did you take?
Oh, let's go.
Wait, are you confused? Are you thinking that water curves at its surface?
Let me introduce. This is my buddy. He made it in. He's a surveyor.
Yeah, he's been here before. So you have evidence, because I have evidence. Before we go to scales, I have evidence. He has claims. Do you have claims, or do you have evidence?
Okay, you said you have evidence, so I'm asking you about your evidence. Well, how far did you measure? How far did you measure over water?
Tank. Take a 40-gallon tank full of water.
How big is that 40-gallon tank?
If you're worried about meniscuses or anything, let the water evaporate and measure the salt line.
Hey, stop yelling.
Measure the salt line. So there it is.
Calm down a little bit.
Okay, you're not going to last long here. If you ask a question, then don't shut up.
Then talk over the answer?
Yeah. You will not last long here. I'll tell you straight up, you're already on the clock.
How big was the tank?
You better fix your shit.
Yeah, Phantom
Thoughts.
Talking to me? Yeah, Phantom Thoughts. You gotta, if you ask a question, you have to listen to the answer, and you have to be real patient before you speak.
Yeah, you giving advice on that is rich.
All right, no reason to escalate it further. Phantom Thoughts, you're muted because the mod was trying to tell you what's up, and you talk straight through him. Okay, so
I want to ask you guys.
Listen, Old Hoss, hold on. I'm speaking now.
Okay.
Okay, I'm clearly the guy with the biggest guns in the room. Okay, now, Mr. Phantom Thoughts, we'd love to hear what you have to say. Don't get us wrong. Old Hoss is an acquired taste. So just do your best to try not to overtalk so that the rest of the mods here won't end up muting you or kicking you, okay? Old Hoss, do your best to let him say what he says. Let's see if we can.
Okay, I'll speak to him in dulcet tones. The guy who sounds like a detuned banjo, I'll speak to him.
I don't care.
I'll speak to him in the sweetest of voices. No, I'm not.
Doesn't matter. Doesn't matter.
I get it.
I don't care about that. I just care about over talking because then nobody can hear what you guys are saying. All right, here we go, Phantom Thoughts. We're going to let Phantom Thoughts say a question, and he's going to stop talking, and the person answering can answer. Okay, cool?
What was the diameter or dimensions of the tank, not the gallons?
Like I said, it was a 40-gallon tank.
Diameter.
The diameter of it.
40 gallons is volume. I'm looking for
spatial dimension. Most 40, it was old-fashioned 40-gallon tank. I don't know, 4 or 5 feet.
How much curve are you expecting to see in 4 feet?
Well, what I'm showing you is flatness.
Yeah, but how much curve are you expecting to see?
Don't talk at the same time as him.
Phantom. He accused me that all I had was wishful thinking when I mentioned water being flat at its surface. You get that, right?
Yeah, but you gave an example of a 4.
No, I'm not talking to you, bro.
Repeat that.
He accused me of having wishful thoughts.
Yeah.
He said that was my wishful thinking that water is flat at its surface.
I agree with him.
Do you now understand it?
If you're using a 4-foot measurement,
Phantom,
prove flatness, that is wishful
Phantom. Okay, is it my wishful thoughts?
Yes.
Those are my wishful thoughts that the surface of that water is flat.
Yeah, if you're expecting to see Earth curve.
No, that's not what I'm asking you, bro. That's not what I'm asking you. He told me that all my claims of water not being convex in my claims that water is flat at its surface, he told me that that's wishful thinking. You can measure it.
It is wishful thinking.
With 4 feet.
Hold on.
How much curve are you expecting to see in 4 feet?
Phantom.
Yes.
I'm not showing you any curve. I'm showing you flat.
But how much curve would you expect to see?
Phantom. If you go get a 40-gallon tank and fill it up, and you measure the surface of it from the bottom of the tank to the top, will that be your wishful thinking?
This is absurd.
Well, it's absurd that you claim that my measurement's wishful thinking.
Yes, you're claiming that it was flat, and it's not.
Well, it's measured flat.
To what degree? Precise? Was that a precise?
Down to a salt crystal.
Oh, you measured down to the individual.
How did you measure that? How do you measure that precise?
Tape measure.
Yeah,
very imprecise.
So the amount of curve you would see in 4 feet.
Do you guys have any measurements of curvature? You don't like my measurement.
Yes. It's not
you guys want to say my measurement's wishful thinking. So do you have any measurements for your wishful thinking?
I'm a professional land surveyor.
Not possible.
That's great. That's fine.
Holding on to a bunch of curve.
No. We're not going to go any further than that. Your profession is not an evidence of anything. Okay.
Well, I'm just
don't just state that what you are.
I didn't state what that was, but we have to factor in curve to our survey measurements. So if we don't, we get predictable error.
Factor it in so you don't measure it, you just add it to it. Okay.
If you don't factor it in, the error is predictable. Yeah. And you can cross check it against other surveys, different types of instruments. It's always the same.
You get error on the already factored in measurement, or is it the addition of it, or just because
if you don't correct it, there's a predictable error.
So you have to correct your error.
No, you have to apply corrections in order to take flat measurements. No, correct curve into flat measurements, because we provide maps.
So what that means is
and measurements on a 2D grid.
So if you do surveying and you pretend that the Earth's flat, you get errors in the survey.
Right, you get errors on the model, of course.
No, so if you treat the world
reality,
like
on actual
reality, just it's self-evident. It's just
are you also a surveyor? Who's talking right now? Are you a surveyor?
I'm just taking what you're saying and applying it to what you're trying to say.
I mean, you're telling me what I'm doing for my job, though.
Well, I know a few surveyors.
Yeah, it's not your job, dude. You can stop the LARP. Experts in the field don't ask other people about their expertise. They don't even have to say that what they're an expert in. It's painfully obvious when someone is an expert in something.
Okay.
Yeah, I was just gonna say, if we.
I've been doing it for 25 years. I'm licensed in California. I can give you my license number, and you can look me up.
Not possible. It would be a LARP. It'd be fake. It'd be something. Some trick.
You're coping.
I don't like is fake.
You're coping.
That's fine. We've had numerous people in here that are surveyors. We have flat earthers that do surveying. In fact, we have a guy that was for a municipal, and he did all kinds of stuff, major long projects, right?
Yeah, there's no way he was licensed and a flat earther.
Really? Sure about that?
It's not possible.
You see how it is? This guy's complete LARP. Complete LARP.
I was just gonna say, sir, if we do want to give this guy the benefit of the doubt, he's talented. We not invite him back in here when APOC is in here? Let's see if they can duke it out.
It's worthless. This guy doesn't know anything about the topic. You know that because his first question was to ask about he does his own job. Inside his own worldview, he doesn't know what he's even talking about.
What are you saying?
I'm just saying if we
can
entertain,
I'll happily let you voir dire the witness. Go ahead and ask. I mean, what would convince you? I'm telling you, we have to correct for curve in our Lancer, we use GPS measurements. GPS measurements are all based on the globe. In order to survey at any site, you have to calibrate your GPS instrument to that site. All the measurements are globe based. We use a projection.
Okay, so showing curved water, showing the surface curving of water
This
should
guy
be no
has
problem.
No knowledge of survey prior to GPS, and you think this guy's some,
I have knowledge prior to GPS too, but yeah, last 25 years we've been using GPS, but we use other instruments too, not just GPS. We have to study old school, and you got to know more than just GPS to get licensed. So that's not true, what you're saying.
How do you know that you have an error?
How do we know that we have an error? Because we do closures and redundancy, and we can cross-check it with different instruments. So we can measure the same 2 points with GPS instruments, and then we can measure those same 2 points again with a total station, totally independent, and compare the measurements. We also do redundancy and closures.
Okay, so how do you know you have an error?
When you get a misclosure, when your redundant measurements don't match each other.
Yeah, nobody cares, dude. Nobody cares about your in-house jargon. You have to use layman terms if you're going to try to explain it to people who aren't in your field. Keep in mind, you said that your field is unique and flat earthers wouldn't know it. So why are you using in-house terms?
I'm not using in-house terms. Redundant is a simple term, man. It just means we shoot the same point more than one time. We shoot the same points more than one time. And we shoot the same points with different types of instruments.
Okay, so what do you mean by
if we don't get the same answer?
What do you mean by shoot the points?
That's how we detect an error.
Okay, yeah. What do you mean by shoot the points?
Make an observation or take a shot with a surveying instrument and a pole or a rod.
Wow, dude. So you basically, oh my God, dude. I could tell you definitely don't teach the stuff.
I train people all the time. It's not.
He's asking you to break it down to him like he's 5.
Yeah, it's a complex field. I mean, not everything can be simplified, but I train people all the time.
Yeah, let me ask you this question: Is 3 points connected by the line of sight a planar triangle?
3 points connected by a line of sight can define a plane and a triangle. Yeah.
All right, perfect.
That's you went to 9th grade geometry.
Yeah. So now that we know that, and you're talking about shooting shots, making observations, start coordinating this so you can actually make an explanation that anybody who's not in your field could understand. Otherwise, you're just talking a bunch of gobbledygook and just resting on your laurels.
Okay. Hey, I'm not a flat Earth debater. I just came in here to back up big tech because he asked me to. I don't.
Well, dude, why do we need you here? We could just Google. The mainstream status quo that
this
says.
This is why I was trying to speak up and introduce him, because earlier when I was in several hours ago, probably before some of you guys got in, I had brought up surveying as a globe proof, and then it was challenged. Have you ever talked to a surveyor? And I said yes. This is the guy I've talked to, and they said, "Well, can you get him in here?" So I invited him. Sorry, I was just.
Yeah, he's done this nighttime radio voice
that's why I brought him
before in here. He's done this act before.
It was to get a real surveyor, not a LARPer, dude.
He's not a LARPer. He's a real surveyor.
That's just cope.
He said, hold on, Fred. He said he's a real surveyor. I was just asking him how he knows that. That's a fair question.
Oh, I can't say that I know that for sure. I believe that he is. I believe it.
Not because my
established that you don't know.
Don't ask you about their expertise.
He didn't do that. He asked a sarcastic question. I don't know if you didn't pick up on the social cue, but he said, "Are you?"
You dragged him in here when you realized that water isn't convex at its surface. Way to go!
So I invited him hours ago. He's never been on Discord before. He's been trying to get in for the last few hours. He had to get like his roll up or whatever.
And he came in spurging out.
This is it. He's never been on Discord. He doesn't do voice calls. We've never spoken.
He's been here
except
before.
For DMs. No, he hasn't.
I'm not really spurging out, but it's funny. Like I hear everybody spurging out though, so I don't.
Big Tech, I got a question for you. How do you know, Big Tech? How do you know he's
except Big Tech? He's the only calm one.
Well, okay. The reason I'm assuming he's never been here before because when I invited him to join the server, he said, "I'm not on Discord. I have to create an account." So this is his first day on Discord, as far as I know.
Correct.
Look, it's not unreasonable for us to ask this question, Mr. Big Tech. Let me tell you why. Because we get plenty of trolls in here that come back numerous times, create numerous accounts, they get banned. We've been doing this for almost 10 years now, and our ban list is like bigger than most servers.
No, that's fine. No, if you want to vet him or whatever, I'm not trolling you. I only know him because I think he watches my stream or has heard me debating flat or like going over flat Earth content. Like I told you, I'm interested in flat earthers. I've been watching Witsit and the Final Experiment and Owen Benjamin and stuff like that. I'm a streamer. I do a stream on Kick. And then he's been DMing me on Twitter about some of the conversations I've been having with people about flat Earth. And he told me that he's a surveyor because I was arguing with Owen Benjamin. He said that surveyors don't use the curve. We found that that's not true. It's in the textbooks. They have a curve correction formula.
I mean, that's cool and all. Yeah, having a formula doesn't really mean anything.
But he started hitting me with a whole bunch of info about why Owen was wrong about surveyors. And he started telling me that he's a professional surveyor.
To be fair, Owen's wrong about a lot of things.
Yeah.
He's one of those guys that thinks he has something to say about every topic because he's really tall or something like that. You know, I was like, I'm tall, therefore I'm an expert.
Yeah, right.
Yeah, so I haven't heard any compelling evidence from Mr. Surveyor here, except a bunch of in-house jargon and just claims that are circular reasoning.
Well, how would I verbally prove that the Earth is round via surveying on a Discord, though? How would that be done?
Just a little bitch.
Just go. Yeah, you want to.
Dude, I don't even care about proof at this point. I'm waiting for you to even make a cogent argument that actually sounds good.
So he's new to Discord, but yes, he has 24/7 Flat Earth Discord, the original, second one, 2.0 on.
I'm just telling you,
servers. Come on, dude. What kind of lies is this shit?
I invited him in here. I sent him the invite.
You invited him to the old 24/7 Discord?
Oh, I don't know what you mean.
Yeah. He has. Have him on two mutual servers. One is this server, and the other one is a 24/7 Discord. So how is he new to Discord?
Oh, sounds like a liar.
No, hold on.
I've talked to this idiot before.
Hey, Big Tech. No, let's stop right now. Big Tech. If it's true that he has his account on another server, and this is the first time on Discord, then he lied to you, Mr. Big Tech.
Or there's an answer we haven't heard. Why are you in the other 24/7 Discord?
I don't know. I had two different invites.
No, wait. And this is his first time here. How does he has Old Dude as his friend?
I hooked him up with Old Dude earlier. Today. No, Old Dude was helping him get his levels up so that he could join the VC.
Yeah, there we go. Old Dude. So what do we all learn here?
Old Dude was showing me the ropes.
Check the chat history in the side chat. You'll see Old Dude was asking me for his screen name. I sent it to Old Dude. It's in the side chat. Old Dude started DMing him tonight because he was having trouble getting into the VC.
Right. So when you go to a Discord and you see that someone's there, you can check the account for how long. If the account was created today, it's entirely reasonable that it was created today. So there's no reason to even bring it up.
Well, check it.
Check it.
I mean, I didn't bring it up. It's not my burden to bear. There are other people that claimed you've been here before. It would be their burden to bear.
Yeah, go look it up then. Anybody who's suspicious.
However, him being here or not being here doesn't change the fact that he hasn't given any compelling argument, except other than just an Ipsy-Dixit claim and appeal to his credentials.
We would probably have to go out in the field and do field demonstration lab type work to prove it to you guys, especially you guys. I don't know what it would take to get you guys.
You don't have to prove. You don't have to prove to us that there's extensive
just telling you that
and mathematical transforms to get to the results. We already know all that.
Yeah. So Basically,
Listen,
I came on when I heard Witsit and some of these other guys claiming that surveyors not correct for curve, and then they go, well, only geodetic surveyors. It's like, okay, well then surveyors do correct. There's not really a classification of surveyor types of geodetic. You could say those are survey types of surveys, but surveyors do all different types of surveys. It just matters what the application is.
Yeah, exactly. So there's all kinds of claims about people have to quote unquote correct for curve, or people have to quote unquote for correct for Coriolis. And when you really get into the meat and potatoes of it, it's usually just model projections and correcting to pre-assumptions.
Well, that's how we correct for it, though. I mean, you're just saying just model corrections. That's what we use to do the correction.
Yeah, I know. You're transforming everything to a model. I understand that.
Okay. Well, what else do you want?
Well, I mean, I want the model to actually be real and not just a model.
That doesn't make any sense. So we need to make we need to make an Earth-sized replica. Is that what you mean?
Oh, you need to prove that your corrections to your model and your transforms are actually contingently necessary because of the surface, not because you're trying to equivocate the surface to a model.
I'm not following that.
Okay, so let me ask this question. Before we go on, let me ask this question. What do you know about the curved plumb lines?
Curved plumb lines. No such thing as a curved plumb lines. Wow.
Are you sure about that?
Depends where you're measuring, but a definition of a plumb line is a straight and it points towards the center of gravity or towards the center of Earth. Yeah.
Okay. Yeah. Well, what do you mean the center of Earth? The plumb lines don't point to the center of the Earth. Are you confused?
They point to the center of gravity.
Ah, that's a different story. That's not the center of Earth, is it?
Nope. It's not.
Correct.
It changes everywhere you go.
Yeah. Oh, there we go. So if the center and the vertical changes everywhere you go, then how do you preserve your radials to know whether or not that your shots are in coordinate with your model? How do you preserve them?
Use a geoid model.
Ah, right. So you have to have a second model on top of the model. So you have to have two models.
Right.
Right, and then you have the actual real-world measurements, and so now you have three things that you have to mitigate together into cohesive package, right?
Exactly, and if you don't mitigate them together, you get predictable errors.
Right, because you already have a model that you have to fit it to.
No, it's because if you're measuring on the Earth's surface and you don't apply these corrections, you're going to get errors.
What kind of errors?
Distance errors, vertical errors. Positional errors.
In relation to what? In relation to
other redundant measurements.
So when you try to mesh them all together into your triplicate model that's being sandwiched into one cohesive thing in the end, right?
Sandwiched.
Yeah, you have three things that you have to meld together, right?
Depending on what the type of measurement it is.
Real world measurements, whatever that is that you do. And then you got the other two models, which are the ellipsoid and the geoid, right?
Right.
So then how come you don't know? Then how come, I want to ask you a question. How come you don't know about curved plumb lines then?
Curved plumb lines. Only thing I can think of with a curved plumb line is, that doesn't exist. The plumb lines are straight.
You sure about that? You sure? No, I just want to be sure that you're sure about that.
I don't know. You guys come up with all kinds of stuff. I can't keep up. But
I'm going to ask you. Do you think I came up with it?
Probably not.
Right. So who do you think came up with it?
I have no idea and couldn't care less.
Interesting.
I'm interested to know who came up with it.
Well, I mean, are you aware of Helmert?
Helmert is see. I know there's a Helmert projection.
Helmert, considered by many to be the father of geodesy. The guy who wrote the 2-volume set, 1,200 pages. That guy. Just one of the key figureheads in the whole endeavor and enterprise.
We don't have... Yeah, sure. Yes, I heard of him.
So what's the curved plumb lines then?
I don't know. I haven't studied that far.
Okay, I'll give you the answer.
We don't need to know that.
The answer is to preserve the angles to the celestial sphere. That's the answer.
Okay. Well,
because they're reverse engineering the celestial sphere to equivocate with equalize with the geoid and the ellipsoid in the real world measurements, because their verticals aren't vertical. They're random. And so they have to have some benchmark to meld it all together. And so this is actually a 4-layer meld that has extensive mathematical transforms.
Right.
That's all well and good. The problem is, that you do all these shots optically, and then you say that you're measuring the Earth accurately with these optical shots, but then flat earthers take a laser to Lake Igsil and they measure that Lake Igsil is flat. Therefore, according to hydrostatic equilibrium and Pascal's principle, hold on, let me finish. According to Pascal's principle and hydrostatic equilibrium, since the surface of water is going to all behave the same way, and 70% of the Earth's surface is covered in water, then ipso facto, the Earth's flat in the end.
So how did they measure the flatness over the lake?
Yeah, laser transit.
Laser transit.
You don't know what that means?
Yeah, it's not really a common term we would use. We would use EDM.
Well, I could care less what surveyors use. I'm talking about what builders use.
Okay.
So laser transit is an effective methodology. Okay.
What was the refraction correction?
They took account the refraction. They have it all in their document that they listed out.
Okay.
Keep in mind, refraction is reality, not a model. Okay, so there is extensive experimental evidence upon the refractive effects against lasers, right? And the maximum deviation that they've validated through experimentation, not through fanciful ideas and models, that range would only. Hold on. Let me rephrase that. 25 miles. They shot the laser 25 miles. I may have forgot that part.
Yeah, I'd have to review the whole experiment there. But
yeah, so I'll give you the premise. I'll give you the premise. The premise is they set up the laser at about 6 feet on the one side of the lake.
Yeah.
Lake Igsil. And they set up the storyboard on the other side of the lake, about 6 feet tall. They had a camera right next to it. Received the beam centroid in the camera. Okay. If you know anything about any transit methods, you're talking about, you got the divergence of the laser at that range was about 2 to 3 feet.
Right.
And then you've got the actually experimentally validated possible deviation from any atmospheric conditions at about 8 feet. So you got about 11 feet. And you got 6 feet a hit there. So obviously the conical spread of the laser was within the target. So, and you got the beam centroid, which means lasers distribute Gaussian, and you can actually use computer software to tell you whether you're looking at the centroid or not, or whether the laser's pointed off in one direction or the other, based on the distribution of the intensity. So they received the beam in the camera. So if you look at the maximum differential swing, you're talking, probably, you got 3 and you got 8, so maybe, you got 6. So let's just be liberal and just say within 10. Now the problem is that...
Within 10 what? Within 10 what? What are we talking about? 10 feet. Okay.
Yeah.
So you're measuring it, your tolerance is plus or minus 10 feet?
No. No, because the divergence of the beam, you could say it was a maximum of 11 if you want to be very liberal.
Right.
Either way, you end up with 6 plus the 10, let's say. But the globe needs hundreds of feet of differentiation. Now, all factors being equal, that's pretty much sufficient to debunk the globe geometry by 2 orders of magnitude.
Yeah, I'd have to see the measurement. I mean, I was just here to help out with some survey.
Yeah, that's fair.
I'd have to see that whole experience. I can't just take people's word for it, because I just see pictures of the skylines across lakes with a third of the bottom of the building cut off, and what's in the way seems pretty obvious.
So check this out.
But I'm not here to debate all that. I was just here to debunk anybody trying to say that surveyors don't use curve in their measurements.
That's fine. Oh, dude just posted the video with actually the Google Drive and the video. So if you want to go check that out,
check it out. It's getting a little bit late, but I don't know. I told Big Tech I'd jump in here, so I finally got it.
Check this out. He posted the PDFs from the FE Corps, Field Engineer Corps. They did 17 tests at different lakes, and they improved the accuracy of their tests over time. The final lake culminating was 25 mile shot. They also panned the laser horizontally through different miles at the lake, so like 5 miles, 7 miles, and then either 5 or 7 and then 14. So it wasn't just that they did a single shot. They also did it 2 weeks separated and validated the results twice. And they also have here a little documentary about how they build a laser, some of their methodologies. But this is not the only laser, by the way. There was one recently done 36 miles in Utah on a salt lake. Same result. There was one done with a dual band laser because different frequencies refract at different rates by a PhD in optics who became a flat earther because he measured water with his lasers and his expertise, and he found that there's no Earth curve in the way.
I posted the 36 mile one if you want to see that one.
The military also did one in the Hawaiian Islands where they did a laser shot to test a tri-band targeting system to basically determine which is the best laser we want to use for a long-range targeting.
Why does military have curvature and Coriolis corrections in their aiming charts tables?
Oh, I'm glad you asked. You know why?
I'm not here to debate all this, like I said.
Yeah, I'm glad you asked.
We use curve corrections in survey, and if we don't, we get predictable errors. Simple as that.
Based on your 4 model thing that you have to merge together. I understand. We all understand that those are transforms.
It's irrelevant. We could go out.
Not irrelevant.
We could go out and duplicate the transcontinental traverse measurements too, and measure spherical curves if you wanted to. Kind of a big deal to do, but
which one is that? The transcontinental arc of the parallel? Is that what you're talking about?
Transcontinental traverse, yeah.
So we're on page 40 of the document. It refers to the Clark ellipsoid, which predated it.
Okay.
Yeah, so they had a model. They were assuming it has everything to do with it.
The angular measurements. Those weren't applied. You take the raw angular measurements.
Angles of what? Angles of what?
Measuring horizontal angles. Turning an angle, sighting on one distance.
How did you do it?
Target.
How did you
turn an angle to another target?
How did you accomplish it?
With the theodolite. I didn't accomplish that. That was done before.
The theodolite is the only. The theodolite is the only part of it. Isn't there a storyboard?
Oh yeah, there's a target. Yeah.
Oh, okay. So it's not just doing it with the theodolite, is it?
Well, you asked how to measure the angle. You measure the angle with a theodolite, not a storyboard.
Yeah, but what did I tell you? I said, how did you do it? You say, okay, so we set up a theodolite. We have a storyboard. We sight the storyboard in with the theodolite. We put the reticle on. Then we get the angle. Yada yada yada, dude. It's not just we put a theodolite.
Right.
Are you trained people in this?
Yeah.
I don't know. Yeah, I'm not really that convinced, dude. You don't seem to know a lot of the particulars.
This is your first day.
Okay, don't get me wrong.
We don't use storyboards. We don't measure. Yeah, we we build stuff. So we're
you build stuff now. So you build stuff. Yeah.
Yeah. We build.
No, dude, your story's falling apart, bro.
California. So.
Yeah, but how is it falling apart? It's
dude, you don't just take a theodolite and set it up.
Construction surveyor, you're not a land surveyor or boundary surveyor.
No, I'm a land surveyor, boundary surveyor.
You're a topographical surveyor as well.
There's no such thing, dude. You don't have these classifications.
Type of surveyors, bro.
Just land surveyors.
Are you freaking serious?
Yeah. There's land surveyors and there's projects, and the type of projects that you work on depends on the type of survey you use. They don't have like all these different little classifications of survey labels that they use. You guys are Googling and finding stuff online, and you think that's why I've been here, because I don't know, there's not accurate information being told out there, because most surveyors
you haven't really given any information that's greater than anything anyone could find on Google yet. So what are you talking about?
Okay.
Yeah, you haven't.
Well, all I'm here to say is that I'm a professional land surveyor. I could prove that if I had to, and we use Curve. So
we use Curve.
Simple as that.
Full story. Just like you said, there's accounting for Coriolis in the military tables.
Yep, there sure is. And
I know. Yeah, I know it's in the literature, dude. I know. You know why I know?
If they didn't apply that, they would miss.
Really? That's
same
what you
concept
think?
Of land survey.
Yeah, cool story. So let me ask you this question, friend. What is the round variability circle for a 16-inch gun off the side of a destroyer at 40,000 meters?
I don't know that one, man. You got me.
Exactly.
I'm not an artillery expert.
If you don't know that, then you have no way to be able to tell me whether they should or shouldn't have to take into account Coriolis. Now, Mr. Big Tech's all hemming and hawing because he thinks, hold on, friend.
So you think that...
Hold on. I didn't say hold on for you to keep going. Thanks. Mr. Big Tech's hemming and hawing because he think I was just pulling that out of my butt. But no, dude, it's not. Because they actually tested 3 guns in the same battery. That means they're all attached to the same turret with the same firing solution and the same powder and everything. And the round variability is a particular variability. And when you look at the difference between the alleged Coriolis and the round variability, 10 times removed. That means that if somebody...
This sounds like word salad with it to me right now. I can't...
What are you talking about, dude? Word salad?
What?
Dude, I'm done with you. You're just going on mute, dude. You're a dumb fuck. Thanks. And go fuck yourself, dude. A Big Tech, dude. Let me explain.
I think
What did I say that was word salad, dude?
Yeah, I think... Yeah, that was unfortunate that he said that.
Yeah, I know. Done fucked up, didn't he?
Yeah, he doesn't know you guys well enough.
Okay, let me tell you why, friend. I was actually in the military. And I was a forward observer as well.
If I got the difference, like the variability in where the round lands is more determined by the nature of the shell than the Coriolis effect. It's like it's a negligible difference if it was a difference at all. Is that right?
All right, hold on. I was checking the chat. Somebody had to mention my name in there, so I checked it real quick to see what they were saying, but it was of no consequences whatsoever. All right, so what were you saying?
So you're saying like the variability in the circle where the hitbox for the shells, it's like there's a 10 times difference variability just based on other factors besides Coriolis. If that was a thing, maybe you would say. So they don't actually factor for it because it would be such a small. It would be such a small difference in comparison with the variability of the rounds and things like that.
Right, that there'd be no way. Yes, correct. So if you open up a field manual of the scouts or any other thing that has forward observers in it, you'll see a table of supposed corrections with Coriolis and all that nonsense. But then you'll see the actual field observers table of bracketing. And so what bracketing is the first round that they fire, you're going to give them a grid coordinate. Okay, they're going to do their firing solution. They're going to fire. The round is going to come and it's going to land somewhere near that coordinate. Okay?
Mm-hmm.
Now, it is not going to be exactly where you asked it to come, except by a sheer act of God and chance. It's usually going to land up to hundreds of meters off. You then have to correct it by telling them to add or minus or whatever, right? Now, the variability of that... Yeah,
Coriolis is going to move it like a meter or two or something like that, right?
No, 10, well, like up to, like 30
Maybe
versus
a dozen
300.
or two. Yeah.
Yeah.
Right,
exactly.
Yeah, so it's like the sniper who's shooting a mile. The wind is going to move his bullet, 18 inches, and the spin drift is going to move it 12 inches. And the Coriolis, if that was an effect, it's going to move it 3 inches. So he just leaves that out.
Yeah, like the standard table is 4 centimeters per 1,000 meters.
Right.
And wind 1 mile an hour in that span is going to move it 10 times that.
Right.
Yeah. So what usually happens is you fire, you either hit or miss, and then your spotter corrects you, and then you hit with your second shot based off where your first shot lands. Right?
Now I've seen a demonstration where a sniper, like a long range shooter, will dial in his scope, right, and he'll aim dead on target, and he'll shoot a grouping of rounds on target east, and he'll hit above, and shooting west, he'll hit below. Or maybe I have it reversed. I don't remember. But one direction it's up, and the other direction it's down. All things being the same. Gun locked in, the grouping is below and above, depending on if it's east or west. And the explanation is given is that the Earth's coming toward you and up versus away from you and down. So just the hang time of the bullet and the the independent reference frame.
It's called the Ayat-Vos effect.
Model, right?
The Ayat-Vos effect.
The
problem,
effect. Right.
Yeah, the problem with that. Here's the problem with that. All right, dude.
Oh,
other people are speaking, dude. In case you didn't notice that, Mr. Truth. So I'll just put you on mute, and then I'll unmute you in a second. Your big tech. The problem with that, okay, is that they claim that this happens with bullets, but then they claim it doesn't happen with airplanes. How is that possible?
Because airplanes are gliding in the air.
So are bullets, dude.
Yeah, but it's a little bit of a different nature, right?
Well, how is the laws of physics different just because one carries people and one doesn't?
Well, that's not.
It doesn't happen with helicopters either.
Well, the thing is, there is a Coriolis effect. Wait, hold on.
Are you talking about like munitions, like aircraft munitions? What you're talking about?
No. The whole airplane.
I mean, the
airplane is an object traveling through free space, right?
But it's not on a linear trajectory.
So is a bullet.
But a bullet's on a linear trajectory.
No, it ain't.
It ain't.
Bullets travel in arcs, dude. You didn't know that bullets travel in arcs?
Well, I know that, but it's a continual arc line, I guess.
You mean ballistic trajectory, maybe?
Yeah. But it's on its own. It's in its own.
A ballistic trajectory
previously determined reference. It's in a previously determined. I don't know, what would you call that? Vector. I mean, the airplane is gliding in the air,
able to correct itself.
Yeah.
Okay. Here's the main difference, bro. I'll help you out. A ballistic trajectory. It's decided, and it's just following out its physics till it runs out of energy. Whereas an airplane can alter its path because it has power and steering surfaces.
Yeah. So I think that would be the answer. And actually, it was Owen Benjamin who hit me with the question. He said, well, if Coriolis affects bullets, why doesn't it affect air balloons? And it's like, well, it does. If you accept that Coriolis affects the weather, and we have the jet stream, and we have the air itself. The air itself is conforming
the
to
wind is now Coriolis.
It's a reach.
Wind spinning ball Earth.
No, I'm not saying wind, but the air. There is a jet stream, and there is
a jet stream is.
And
so if a helicopter hovers, if I hover in a helicopter, I can just go travel out west after a few hours.
Well, if the wind's blowing that way, I guess, yeah.
You've lost that. I'm looking for the Earth to spin underneath it.
Yeah, but that's not how it works.
No.
That's not what would. That's not what would.
Welcome to stationary Earth.
Spinning. No, that's not what would happen if what I'm saying is true.
Well, Neil deGrasse Tyson says all it takes is a 40-yard field goal.
Yeah, well, he's a weird entertainer. He's a weird entertainer who's always clout chasing.
All right. Before we get too far ahead, let's see if Mr. Truth actually had something to add, because I told him I would unmute him. So let's see if he's still here. Hold on, he might have left. Mr. Truth, all right, whatever. All right, Truth, you lost your chance. All you had to do was wait for 45 more seconds.
So yeah, I guess, and I think the balloon would be receiving some effect because it's suspended in the air, and the air is receiving, Coriolis deviation effects in the way that it's moving in its currents. So it might be extremely minuscule, but
the air moving in currents ain't due to the ground moving. It's due to temperature change and high pressure going to low pressure. So it wouldn't be the ground moving.
The jet stream is caused by that?
I wouldn't say it's caused by the ground moving.
Well, what is it caused by?
The jet streams.
Yeah. Why does it only flow in that direction against the spin of the Earth? Or whatever. Why does it flow? Why does the jet stream do what it does?
I don't know about jet streams, to be honest. No, I don't know.
Does anybody here know? Did I just find the silver bullet? No way.
No.
Surely you guys know what it's about.
Oh my goodness.
You have to find a question that a flat earther doesn't have a really clever answer for.
You mean, why does the jet stream move and flow?
Yeah, why does the jet stream move?
What do you think? Well, let me ask you this question. What do you think it does?
Yeah, it moves from there's a stream of current of air at high altitude east to west, isn't it? Or is it west to east? I always forget. I was going to turn it around. I think it's east to west.
There's a subtropical one, and then there's the one above the tropics. Right, and they do generally go. The main ones go in a consistent direction. Yes, that's true. And what?
I was wrong.
Have you ever seen the jet streams? Have you ever seen a heat map of the jet streams?
Yeah.
So what do they look like?
Little wavy line.
Yeah, they're all wavy, right? So they go north, they go south, right?
Well, it's flowing west to east, but not always in a straight line.
Right, so they go north and south, right?
Right, they're deviated by pressure systems.
Right. So it's a squiggly line, right?
Mm-hmm.
Okay, so yeah, cool. So then what?
So what's making that air move east to west? I mean west to east. In a squiggly
What's making it move north to south?
Well, it's like getting bumped by pressure systems that are interacting with it. So it's like a current. Really? It's like it seems to be like a river. Water's seeking a path of least resistance. We call it flowing downhill, but it'll go left and right, but it's always going down. So the water's always flowing down, whether it's left or right, doesn't matter. It's all down. So this is always going west to east, whether or not it's north or south. It's always west to east. Never like stops going west to east. It's just like deviates off of straight, but it's going west to east. So what's causing that current west to east?
So wouldn't that be the high pressure going to low pressure and temperature variables?
I'm sorry?
If you're saying it's like pressure systems, isn't that going to be like high pressure going to low pressure and hot going to cold, like different variables within that region?
So why would there always be lower pressure in the east and higher pressure in the west?
How does the sun move?
Yeah, what's weird is it seems like you're acknowledging that these currents are going over something that's stationary, when before you told us they were all moving together.
Yeah, I'm trying to find out why you think it's the ground causing that. I don't know what else could be causing that apart from the variables that are stated.
Right, so which way does the sun move?
It doesn't.
You sure?
As far as I know. I mean, you mean like relative to the center of the galaxy, or what do you mean?
Oh, dude. No, I'm just saying, okay, look, dude. We don't have to go into your storyland every time.
Okay.
Okay. On the Earth, we see the sun.
What direction does it
That's
appear
what we
to
see.
travel? Where does the light appear to go from and to?
I mean, look, if you just take let's just take solar noon. Just take solar noon and chart it around a map, and then use the cardinal directions. Which way does the sun move?
Well, the light travels across the sky relative to me, yeah, for sure. But so you're not gonna trick me into saying the sun moves. The earth moves. You're trying to trick me.
Well, dude,
yeah, it goes.
Let me tell you, we both see the sun move.
The sky east to west. Yeah.
Yeah, but keep in mind that I changed it to solar noon being over a location on the Earth. So if you were standing directly underneath it, it would be 90 degrees to the surface, right? Directly above you, vertical. And that location changes throughout the day. And if you chart that in a cardinal direction, so I changed it to make it more concrete. Right. That definitely happens, right? It's over me now, let's say, and then it's over somebody else later, right?
Mm-hmm.
So what direction does it move? East to west, right? Or what? No, hold on. No, I could be wrong.
Yeah,
my memory.
The sun goes. The sun is east to west through the sky, but the jet stream's west to east through the air.
Oh, there you go. So they're just counterbalanced. As the energy that the sun imparts transfers over the surface, the ambient system fills it up, and it moves from that direction. Easy.
Amazing.
Sun being the greatest source of energy, right? In the regards temperature variations in the atmosphere, right? And it always has a degree tilt from the tropics, right? And so guess what else always has a degree off from the tropics? The streams. So it's not unreasonable that they're just counterbalanced. So what were you trying to say about the streams? Because it seems you had something loaded in the hopper.
Yeah, so my understanding is that the jet stream is primarily caused by the Coriolis effect, which is the apparent deflection of moving objects due to the Earth's rotation.
No. Apparent deflections can't cause a motion, dude.
Well, it's relative to the Earth's motion.
No.
So it's the motion of the Earth causing an apparent deflection.
No. This would need to be an actual deflection, not an apparent deflection, because you're talking about a stream of matter, being the air. It has force behind it. It's not apparent. It is. Being an apparent deflection is something moving through a reference frame being viewed from a non-inertial reference frame. So it has nothing to do with that whatsoever.
Well, the thing is that, no, the idea is that the air masses are moved toward the poles because of the deflection of the Coriolis effect. And as they do that, it causes a cycle.
What deflection?
Yeah, and there's an apparent deflection of the...
No. We already just went over this, dude. There's no such thing as an apparent deflection actually moving anything.
Right, it's the Earth.
Apparent deflection is caused... Hold on, friend. An apparent deflection is caused by something moving, right? And you viewing it from a different reference frame. So it's just you moving in a relationship to it that's causing you to appear like that thing is moving. When you're talking about the wind, you're talking about something actually moving. So you can't get actual motion imparted on something from an apparent motion, which is just a visual thing. Hope that sank in.
All right, so the Coriolis effect, though, I mean, Coriolis himself was a meteorologist. He's studying weather. So the Coriolis effect is an apparent deflection caused by the Earth's rotation. Definitionally, that's what his idea was.
You're wrong. No, you're wrong.
I am.
An apparent deflection is just that, an apparent deflection. Caused by you moving relative to something else moving in a separate reference frame. And so the way you are moving compared to it just makes it look like it's taking a different path. It's not actually taking a different path. You're talking about a jet stream, which is actually taking a different path. Those are two different things. So clearly the Coriolis in an apparent deflection is not sufficient to do anything here. It has no causal power to move things. Now, if you don't know the answer, I'll tell you the answer.
All right. I'm trying to grasp. This is not easy, actually. I'll be honest.
It's not. That's why I asked you. If you don't know, I'll tell you.
Yeah, please go ahead.
No problem. So, racetracks. You've seen them?
What tracks?
Racetracks.
I'm not messing with you. The first word keeps cutting out. Face tracks?
Like, no, like, you know, like, 100-meter dash.
Race
500. Yeah.
Racetrack, yeah.
Oh, racetracks are usually oval. The inner track has less feet than the outer track. And because of that, you'll notice in races, the starting points for each lane will be a different spot, right?
Right.
Yeah, the staggered start.
Otherwise, the inside guy would always win, all things being equal.
Totally.
Right? So if every single racer can only travel 20 miles an hour, and let's say they do perfectly travel 20 miles an hour, they'll all end up at the end at the same time if they stay in their tracks. However, if the homeboy on the outside tracks moves into the lesser track, he'll win the race. And if the guy on the inside track moves to the outside track, he'll be way behind. Right? Make sense?
Mm-hmm.
However, if I tell you they must all arrive at the exact same time at the finish line, but they skip tracks, then that means somebody has to slow down and another guy has to speed up. Make sense?
Yes.
Okay, so the claim in the globe world is that the Earth essentially is a bunch of different sized racetracks. And when you cross into one of the racetracks, you either have to speed up or slow down. And because there's no mechanism to slow you down or speed you up, that you then experience a portion upon yourself in free space that causes you to alter your trajectory. Now, that is not Coriolis. That is actual deflection, not apparent deflection.
I just found out a problem with the answer you gave me a bit ago, by the way. Did some reading and discovered something I didn't know. Wait a minute. Let me see if I understand. Oh, no, never mind. No, I misread something. Cancel that. We're good. So let me read what I just pulled up a little script on this to check, literally from AI. And it's telling me as air moves from the equator toward the poles, it retains its original eastward momentum, which appears to curve eastward relative to the slower rotating surface of the Earth. And that's due to the Coriolis effect. So it's actually just it's keeping the same momentum. It's not actually speeding up or slowing down. It's just a retention of momentum that appears to change, but there's a directional change, but it's a continuation of basically angular momentum. It's not easy to comprehend, actually. I still got to cook on this. This might take me 48 hours for this to sink in.
Yeah, so I'll give you this. That explanation is melding the two things together into one. You just have to separate it out, apparent versus actual, and then you'll solve it.
So the air moves from the equator towards the poles, and that's because of the pressure difference, because of the heat. It retains its eastward momentum, which appears to curve relative to the slower rotating surface of the Earth. I get it. Right. Okay. Because at the equator, it's rotating faster than the further north you go, the slower, the smaller the great circle is. So at the higher latitude, as you decrease in latitude, it's a
hold
slower
on a second.
rotation. Slower velocity.
You almost had it. There's no such thing as a smaller great circle.
Why not? Oh yeah, the great circle would be the total size. Yeah, you're right. Latitudinal circle, I should say then. So as you move from the equator toward the poles, you're getting smaller and smaller circles. So it appears to curve, but it's actually keeping the same momentum and going at it's inheriting momentum that it got from the equator, but it's moving north, which makes it appear to go left. And
this all started because he claims the military's out there accounting for Earth spin.
No, the other guy
Unreal.
claimed that. But we are piggybacking off of that. So yeah, it's not actually a force. It's just traveling north. But since the Earth is moving under it at a slower velocity in the north than at the equator, it starts dragging behind, which causes the appearance of it's traveling in a circle.
Mega Man stuff too. Which is the bigger one?
Bigger one. Give him the bigger one.
What's that?
Yeah, so how come that doesn't work with planes?
In what do you mean that it doesn't work?
Well, planes can leave from the north and arrive in the south, and they don't have to have increased their speed. And planes can leave from the south and arrive in the north, and they don't have to decrease their speed.
Well, they just keep a heading, and they have instrumentation for constant adjustment, right? They just lock onto a heading. It wouldn't just be.
Dude, what's the differential? What's the differential in the rotational speed
between what and what?
Let's just say New York City, LaGuardia Airport, and an airport in Brazil. Or sorry, no, an airport on the equator.
I mean, do you need me to run the numbers, or should I just take a guess?
Well, it's 1,000 miles at the alleged equator, right?
Right. So New York could maybe, I don't know, is it like half of that?
We could probably safely say half.
Right.
Okay, so if a plane's going 500 miles differential, right? An hour. How's it going to alter itself to make up for that?
How is it well, it does get affected, well, basically by the jet streams. Well, I mean, it's going to choose its speed based on.
No, dude. See, the problem with the jet streams. Here's the problem, dude. Here's a huge problem. The jet streams. This answer of the air moving up north, dude, would make the entire arc a jet stream, not just a certain portion.
Make the entire arc a jet stream.
Yeah, the explanation you gave, right? The air is moving from the equator towards the north. Mm-hmm. It's retaining its velocity, right? And that would mean that the jet stream would be the entire arc all the way up until you hit the North Pole.
No, the jet stream is like a boundary. Close. The jet stream is like a boundary between these swirling heat layers. It's like it creates like basically like a river. Like it carves out a channel between.
Yeah. Okay. So systems. Why are they pretty much in the same spot all the time?
Because of the pressure systems that are kind of general.
Oh, I thought it was because of the Coriolis.
Well, the Coriolis is what gives them their deflections, which means like an apparent motion, a swirling effect. But the position is created by essentially.
Well, dude, I mean, it's not an apparent. It's not an apparent motion, dude. Because when you get your plane into that stream, you go faster. There's nothing apparent about it. It actually is faster.
Faster relative to the surface of the Earth.
Right, and so that means faster, not apparently faster, but actually faster.
Well, no, not absolute velocity is increasing, just relative to the surface of the Earth.
What? When you fly into a headwind, slower.
If there was no absolute velocity differential, then when you entered the jet stream, your plane would not go faster.
Faster relative to the surface of the Earth.
Right, so that means that the air at the ground level is going one speed, and the air up high is going a different speed, which is why the plane enters the jet stream so he can get a boost in speed, which is an actual boost.
No, I agree with you. Yeah,
no, relative to Neptune.
Yeah, never mind. Yeah, hey, give me a break. It's late. Yeah, I think that went over. You're right about that. All right, so it goes faster because it's jumping. Jumps into the lazy river, so I can swim faster, with the wave than against the wave in the ocean, or I can swim faster downstream than upstream. Same thing. Just a river of water that's moving, and you can go with the flow or against it, right?
Exactly.
Yeah, and so that boundary in between all these swirling masses of heat exchanges from between the equator and the poles creates like a river of water that's going around,
right,
west to east.
Yep, contrapositive to the way the sun moves. Perfect. So we got these dynamic energy systems, right?
Yeah.
Okay, so then what do we need? What do we need the Earth spinning for?
Well, mine has a dynamic network for why those things swirl the way they do.
Are you sure about that?
Well, I mean, we're calling it Coriolis. It's an apparent deflection.
Have you ever seen an azimuthal projection that shows the jet streams?
No, I've never looked at it on that.
If you look on a globe, it looks like a big pile of gobbledygook. But if you look at an azimuthal projection, they look like circles.
Oh, could you show that to me?
I'd have to find it. Give me a second. I'll look at my.
I was just going to ask that because when I'm looking at it on the globe, it looks nice and symmetrical. North and south look similar. Like, how could you make that work? Wouldn't there just be like way bigger swirls around the edges of your azimuthal projection? And wouldn't they be traveling way faster since the east to west distances on the azimuthal projection are kind of wonked out? Wouldn't the southern swirls go wouldn't southern hurricanes be going like way fucking faster than northern hurricanes?
Why?
Because the east to west is all stretched out on an AE map.
So this is the thing you have to remember with a north-centric AE azimuthal projection. It's North Pole centric. It's only referencing one rotation in the sky.
But objectively, I mean, you could measure the wind speeds in Australia.
Dude, wait till you see this. Dude, when you see what I'm about to post, it is literally going to make what you said look like absolute nonsense. I'm not saying that to be rude or anything. I'm just saying, I didn't even realize how dramatic this is from this animation, but this is not what I promised you. This is something separate. Give me a second to download this. Because remember, the idea is that the Earth is moving in this perfectly rotational thing, and these perfect rotations is what cause these perfect Coriolis. Let me post this. This is a GIF of an animation that's pretty.
The one that Quetzalcoatl just posted is just obviously garbage. You just tell in 5 seconds.
What's that?
That's the azimuthal projection. Why is it garbage?
Which one? Hold on. Before he says it, which one's garbage? Because you didn't actually claim which one. Is the one on the left or the one on the right garbage?
The one on the right.
Okay. Go ahead. Talk about it.
Well, because nothing's moving north and south. It's just like a perfect donut. That's not how the jet stream is shaped.
This is why I asked you. This is why I asked you the question before. When you're looking at it as a azimuthal projection, when it's north-centric, there's only one rotation accounted for in the sky and projected out from the north. But there's 2 rotation points in the sky, right? Or am I wrong?
2 rotation points of what?
The stars in the sky. That's why I'm referencing the sky.
Oh, I thought we were talking about the weather.
We're talking about the dynamics of the sky, how it moves. Sun moving.
We're talking about jet stream and stuff.
You're talking about, the further south you go around Australia, then according to this north-centric polar projection, the winds will be going faster. But it's north-centric bias. There's only one rotation accounted for. So map project.
You propose a different projection?
If we're referencing the motion of the movements in the sky, then we must reference both rotations. This is just a projection on a map that's biased to the northern projection. There's other ones that you can get that are biased from the southern projection, around Antarctica, for example, where the inner circle will be around Australia.
Yeah.
Yeah.
Those are polar projections that we're
they're polar
of the globe. They're projections of what? Of a globe.
So we're talking about the movement of the things in the sky, right?
Yeah.
Okay. how that's relevant to a ball or how that's relevant to a flat Earth. So how it's relevant to a ball is obviously on this A projection. If we're looking at it, it's not taking the account of 2 rotation points in the sky. We're talking about how the
North Pole
sun
and the South Pole?
Yeah, North Pole and South Pole. Where do those poles come from? Are they ground positions?
From the globe.
Yeah, from the globe. Because there's 2 rotation points in the sky, not just one.
Yeah.
Yeah. But that doesn't mean that there's a globe. It means there's 2 rotation points in the sky, and the Earth is measured flat. So you're not going to get this wide arcing around the Tropic of Capricorn if it's projected out as one of the wider circles past the equator on an AE projection. It's not that. It's a circle around the southern rotation point, which was demonstrated with the 24-hour sun in Antarctica, where the sun is circling for 24 hours on the Tropic of Capricorn around the observer in the middle of the circle. Same thing that we observe in the north.
I don't get it. I got to be honest.
That's fine, buddy. No problem. I'll give it back to AI.
Hold on, I almost got this thing.
So, like, the sun migrates south and then circles around the other projection?
That's what we observe throughout the year, yeah. So, for example, a couple of days ago on the 21st, right, and summer solstice in the south relative to us in the north, the sun is circling on the 23.4 degrees south southern latitude, called the Tropic of Capricorn, the southern circle. In 6 months, the sun's going to be circling the Tropic of Cancer, 23.4 degrees north of the equator, a circle around the northern point. Sun circles around 2.
Wouldn't it be having to, like, go do a figure 8 or something to go on a different path?
That's potentially what it could be.
Yeah. So why is the world flat?
Oh, because it's measured that way. Mean sea level is a horizontal reference datum. In this reference, we're going to be measuring the elevation angles of stars with reference to north, south, east, and west. East and west are circles around poles. In this instance, north and south.
Quick question. Do you own a sextant?
Yes.
Have you navigated at sea?
Sorry. I used to own.
No. Hold up. Have you navigated at sea on a transcontinental voyage?
No, but I've used a sextant.
Okay. All right. No. So you haven't.
No, literally stopped. What the fuck you keep going no for?
You have a sextant, but you have never actually voyaged transcontinentally.
Not transcontinentally, no. Just around the waters around Great Britain.
Okay, so first of all, can I ask where you bought your sextant, just for fun? Because there are a lot of. Is it full brass? This is not like trying to check your accuracy. This is more of like a hobbyist thing.
Yeah. So if
full brass.
If you want to know, right? Royal Cadets. When I was young, 13, 14
Royal
years.
Cadets. Is that Royal Cadets? Can I ask if that's an equivalent of Boy Scouts?
No, that's the
holy crap, dude.
The Navy
Jedi.
Royal Cadets. Great Britain.
He went on a transcontinental voyage with his Boy Scout troop.
No. I'm asking if Royal Cadets is like similar to Boy Scouts. If I'm wrong there, correct me.
No, it's affiliated with the Royal Navy. It's when I say 13, 14.
So it's more similar to like the Civil Air Patrol.
Yeah, it's just a junior group of the military dude.
Okay. Yeah. That's fair. I'm just curious. I'm sorry. I don't know other people's countries. Like, I'm asking for information, right?
But you asked about his sextant. What's wrong with his sextant?
Say
again? Would you want to know about the sextant, dude?
So the sextant, I'm asking if you have made a voyage over 2,000 kilometers.
No. I don't think I would have achieved that in the small journeys. I couldn't add them together and say 2,000. Definitely not.
Yep, that's fair.
But I know how to use a sextant. What's the problem? Is there something about 2,000 miles that means that the surface that you've travelled is curved?
No, it's just,
okay.
It's just the fact that you're not a serious seafarer. You've never actually made an actual voyage.
Sorry, seafarer.
You've never
dude.
actually had.
When I was 13, 14 years old. What the very fuck are you talking about?
Say again.
I never claimed to be I never claimed to be a seafarer. What are you talking about?
So you've never actually.
Actually, what? Used a sextant, an elevation angle of a star above the horizon. Yeah.
You're not a member of the Royal Navy, are you?
No, I'm not a member of the Royal Navy. When did I claim that I was? I said I was a Royal Navy Sea Cadet when I was 13, 14 years old.
Yeah, and that's
not 15 or 16. I didn't say that I did that in my career now. But I've used it to measure an elevation angle of a star above the horizon and gained an angle measurement. What else do you need to know, dude, about the sextant?
The sextant is only actually accurate and valuable because of the curvature of the Earth.
No, it measures angles. Do you know what an angle is?
No idea. Please educate me.
Okay, so an angle is the intersection of two straight lines that meet at a vertex and the measurement of the deviation between them. Give me, for example, 90 degrees, 45 degrees, 180 degrees, 260 degrees.
Okay, all right. Will you play with me for a second here?
No, I'm not going to play with you. You said that a sextant only works.
All of a sudden.
My friend,
you
thank you very
made
much.
that sound.
Hold on,
you made that sound British for a second. Like that sounded creepy.
Like you want to avoid your embarrassment. Calm down.
So
you
hold
said
on.
that a sextant only works if the Earth was a globe. I've pointed out that it just and only measures angles. An angle is the intersection of two straight lines. Can I ask you a question?
No, and that's what you're missing. All right.
No, it doesn't measure angles. Doesn't measure angles. It doesn't. It doesn't measure angles. Or
no,
does it?
Does.
I need you to answer the question.
But with reference to your position.
Position? What's my position?
Longitude and latitude.
Okay, so longitude and latitude are measured from angle measurements to things in the sky. For example, your latitude north of the equator is derived from the elevation angle of Polaris. Circles of
derived is a calculus term. This is actually pretty clearly.
Haven't finished.
Derived is the wrong fucking term, dude. This is very clearly, at the least, algebra.
Excuse me. Where do we get our latitude from? What is that reference to?
Latitude is north and south.
No.
From the
latitude is a circle around the ground position of Polaris north of the equator. South of the
north
equator.
And south.
Yes, but that's circles of equal altitude.
Very clearly.
How do we measure
north and south? You're being too much of a nerd to back up something you don't understand.
I do. How do we measure and figure out our latitude with a sextant?
Reference to an actual star.
Which one?
Polaris.
Good. So you understand that latitude is a circle of equal elevation around the ground position of Polaris.
Okay. Can I say something?
No. You can answer my question.
I will say something. You will not cut me off. The only way this idea that you're floating might make sense is if the world vibrates up and down to adjust to make sense of different angles on a star versus.
He's just told you about an angle. So what is vibration going to do with angles? You've even almost agreed with him.
We've already proven the vibrations that we take off Polaris match entirely off.
What vibrations are
rotation?
You're not even on subject.
Controlled with a rotation around the sun.
You're just talking.
Vibrations are accounted in angles.
So the only ways that calculation can be wrong.
Not a calculation, it's a measurement.
Can you stop talking for a second?
No,
the only way
you keep saying is incorrect.
I'm floating away. They could be wrong. Please stop.
The things that you are saying are just wrong.
Please stop talking.
No.
The ways they could be wrong, and as you would say, they would be wrong.
What does a sextant measure?
The measurement between the sun and the horizon. Depending on what you're measuring, you can measure moon, the horizon, everything else. It's an angle between.
There we go. What's it? An angle
between sight of horizon and whatever you're sighting, right? You could sight Jupiter in the horizon on a sextant.
You could exactly.
And then depending on your chart, you can find your location.
Always.
Are you a sailor? Are you a sailor, buddy?
Dude, we've had this conversation. I have sailed, but apparently not a further enough distance or gained a career that's going to satisfy you.
You wanted the
But within this subject, right at the moment, I guarantee I know a lot more about it than you do. For example, what is a height of eye correction?
Height of eye.
Height of eye correction. It's literally given away within the fucking question. What is it?
It's depending on the height you're observing from.
Okay.
Where and what you're actually able to see, and it's.
What do you correct to?
I used to have this memorized. It's actual squared function that.
What's it corrected to?
I think 3/4, but I could be fucking this up.
See, again, it's like you're not listening. It is a height of eye correction.
Height of eye? No. Shut up. It's your height of eye. So,
can you
give me a second? Can you give me a second to speak? Can you give me a second to speak?
Can you answer the questions that I'm asking you? Can you do that?
Yeah, if you stop.
Trying to wrangle a retard at the moment.
Alright, so.
Stop spazzing, Snake.
Say again?
Stop spazzing is what you from the peanut gallery.
Can someone speak one more time so I can hear you?
Height of eye, what is it correcting for? Hurry up, man. Take long.
So, height of eye, it's the higher you are upon the horizon, the farther you can see. That's to put it basically. And I'm not going to be a pussy and look it up.
No.
Am I wrong?
No, I don't need to look it up. At the moment, I can cite it from my data.
Am I wrong? Am I wrong? It's like 3/4 square root.
A height of eye correction corrects for the height of eye above mean.
Yeah, what's the calculation? Give me the math.
Excuse me. Stop running away.
Give me the math.
Stop running away.
Give me the math.
Stop running away.
No, he's lost.
What's the number?
He's now a broken toy.
If you're such an expert.
We don't want to play anymore.
Give me the number. What's the height of eye correction?
What's it correct for?
What's it correct above the horizon you are? So
no.
Can you guys give me a second to speak how we actually use it?
No.
He just told you the answer. He told you the answer.
I really don't care. Can I give you how we actually use it functionally? No, for fun. Can I give you how we use this functionally?
Yeah. What's it correct for? Where does it place you, the observer, with the eye?
No, and this is totally separate from the discussion. This is how we use it.
No.
Can you guys stop interrupting me and just let me explain?
No, because you keep not answering the questions.
Well,
or if you do, that's a wrong answer.
And then let me finish this first. Let me finish this first. Shut up and let me finish first, and then
we're still in this sunshine.
So
sorry, we're gonna side away and have a quick chat about something else. and then we'll get back to the subject. What you fucking think this Tea Party?
Will you guys actually let me teach you something about naval history now?
Not interested in naval history.
Okay, that's fine. If you guys want to learn, it's okay.
Okay, bye.
I don't give a shit.
Okay, bye then. If you're not here to answer any questions, you think you're going to educate us about naval history for some reason, when we're not talking about naval history. We're talking about angle measurements with a sextant that you brought up.
We're
and
talking
how you
about
said
like
that only
actual.
work on
No,
a
no.
curved surface.
Would you disagree? There is
You
an
don't
idea
know what
that
you're talking about. Stop
navigation,
embarrassing yourself.
navigation, and functional like actual decisions are made off of observational light, right? At the end of the day, observational light. Would you disagree?
What do you mean, like?
Are you broken or something?
Light and reflections.
What, taking the angles?
Yeah, 100%.
Yeah, measure angles. Specifically elevation angles, right? We measure the elevation angle of the star above the surface of the Earth, don't we?
We certainly do.
Yeah, that's my point, and it's not worth
Exactly,
arguing
that's the
over.
point.
It's literally.
So where does the globe come into the angle?
If you're not willing to actually look at straight
If
up
you're not willing to actually answer the question,
horizontal like calculations of mass height and like how we calculate that shit, you're not willing to look at like actual.
You don't calculate. You don't calculate an angle.
We can't actually bring that out to the star
We're interested in what we measure.
Like you are so diluted and
you are diluted because you're trying to calculate an angle.
Possible.
Why would you measure the angle first? What would you calculate it for?
There are actually good conversations to be had.
Exactly, and not with you.
So fucking diluted and poisoned that you can't even understand.
Like,
that
you can't even answer what an angle is.
Masthead height, if a like let's say a pirate schooner, right, with masthead height of 135 feet is farther out on the horizon, it will look shorter. You are retarded. This is the saddest display of optical science that I've ever seen, to be honest.
Oh, brother, man, seriously.
It is.
Yeah, I'm going to. That is the best display. That is the best display of somebody who's decided to overdose on copium. Now you're coping, dude. Yeah, you're broken. I don't know what happened to you. At what point?
Before I leave, can I ask a question for you, brother? Brother, can I ask you a question?
You don't get to ask me any questions, dude. You
I don't get to ask you questions.
When you disengage from the conversation.
A foolproof evidence of a man who is secure in his beliefs.
I'm definitely secure. You just didn't want to talk about it and run away. Displaying that
a man who is secure in his beliefs does not let me ask you a question.
This is now projection.
A man who is secure in his beliefs does not let me ask a question.
Yeah, this is just projection, dude. You're trying to hide. You're trying to point the blame upon me. No, it's you that run away. You that run away. Remember?
No. My brother, you're very secure. You're very secure in your beliefs, are you not?
Are you drunk or high? Drunk, high. Which one is it?
Brother, are you very secure in your beliefs?
He's trying to the bottle. He's trying to redeem his loss. He's lost, and he doesn't know how to answer any of the questions. He's trying to revert it back to you.
No, it's.
It is exactly
impossible to argue with a retard.
Exactly. So who's trying to calculate a measurement?
Me.
Exactly. So who's the retard then? You. Well done, Nobbin.
Excellent rebuttal, child.
You're right.
You measure
I
measurements.
joined a chat that's full of fairy tales.
You measure measurements, don't you? You don't calculate them. You measure them, don't you?
No, it's okay. I apologize for thinking you guys had actually something.
Just go with that, man. Just fuck off.
No, it's okay.
Bye.
Still fucking doing it. Why?
I respect.
He's apologizing for not understanding what the fuck we're talking about. He's talking to everyone. What's wrong with this child? Why is he still speaking?
No. Let me finish. I respect the fucking last.
You are finished, mate. You are finished.
Another fucking broken toy.
Yeah, if you can't answer the first question, don't move on to another.
Wow.
I will say,
you'll be okay.
I'm not even a flat earther at all, but like that dude literally didn't know what high to high was and was googling it actively. Whenever you asked, that shit was hilarious.
The best part is the height of eye correction doesn't conform to a globe either.
Eye is just high to eye. It's kind of funny.
It's the higher you are, the farther you'll be able to see. It's pretty fucking simple. It's not like even that mathematical calculation. It only works on a globe.
No, because the height of eye correction formula actually places the horizon at a closer geometric distance than if it were a globe. So, no, there's no globe in that formula.
No, it doesn't work if it's an infinite flat plan.
You don't even know what it's for.
Holy crap, dude. Are you that dumb, dude?
Based off the horizon. If it's an infinite flat plan.
Dummy, are you dumb? Hey, Dumbo, are you dumb? I'm just asking a question because I want to know.
He doesn't know how to answer questions.
Okay, so let me just put this out there for the slow kids. Okay, I just want to put this out there. The ground below you is below you. Wow.
Dude, I don't even know what that means. He might be on my side. I don't fucking know. Like,
it's the most simplest explanation. You think it's like
There's 3 axes that exist in 3-dimensional free space. There's 2 axes that exist in an image. Ah. Profound.
So a dip, height of eye correction, a correction to be applied to a sextant's altitudes to compensate for the height of the eye above mean sea level. So to compensate, to replace the observer from mean sea level, you correct to put your eye on the water, height of eye correction. It's not that hard. Still trying to figure out where a globe comes into it, because the sextant can only work on a globe, apparently, according to this man. When all we're doing is measuring angles from the surface of the Earth after correcting for the height of eye. Your 2 straight lines for your angle are mean sea level, the surface of the Earth, and the imaginary line between the observer and, let's say, for example, Polaris at 45 degrees. Remembering that when I measure 45 degrees, that's my latitude. My latitude being a circle of equal altitude around the ground position of Polaris. That measurement is taken from a flat Earth. Latitude requires a flat Earth. Welcome to flat Earth.
Yeah, but did you calculate your vibrations of your angle?
Yeah, man, I calculated my vibration, dude. Yep.
Oh, that's good.
tip angle is perpendicular to the surface. So what gives?
Yo, is anyone here?
Yeah, some folks are here.
Any folks of the Flat Earth persuasion?
Yeah, I think all of us.
Really?
Yeah, unless it could be proved otherwise.
Prove that you guys aren't flat. I mean, I wouldn't. That would be your like domain, I assume.
No, about the ground being flat. If you could show it not being flat, that'd be good.
I'm just wondering, like, how do flat people explain sunsets?
Sunsets is dependent on the distance from the sun to the observer over the Earth. Now, the sun doesn't set. We observe this with the 24-hour sun, so we know where the sun is. And if you stand inside this tight circle of the sun, you can see the sun for months at a time above the sky. So the sun doesn't actually set unless the observer is far enough away from the sun. This is based on perspective.
You said that sunsets are dependent on the distance from the sun to the observer over the Earth, and the sun doesn't necessarily set. We just observe it. And, some examples like the 24-hour sun might show that. I hear you. But, like, at the equator, it seems like it does set, and I just don't know how that would be possible.
Yeah, I'm getting to that.
Okay.
So when you are far enough away from the sun, or not within its circle, or one of the circles that it performs, when the distance is too much.
Wait, the sun performs a circle?
Well, yeah.
What does that mean?
Did we not just see this when we observed the 24-hour sun in Antarctica? The sun's
I don't know what it means to perform a circle.
It's circled around the observer, 360
Do you
degrees.
think the sun is moving or the Earth is moving?
Well, what we observed was the sun to move.
I mean, it must be going pretty damn fast to be like moving across the sky,
Yes.
So quickly.
Yeah, lots of things move in the sky, don't they?
How fast do you think the sun's moving at?
I don't know.
Like, it's a speedy ass boy. It's like Sonic the fucking Hedgehog.
Yeah, right.
Wait, how far away do you think the sun is?
If you go to timeanddate.com, you can look at the subsolar speed if you're interested in this.
But how far away is the sun?
Don't know, dude.
Yeah, you can't triangulate it on a globe either, so don't even try.
You can't triangulate it on a globe. Triangulate what?
Ray, you're not listening. You seem to have a lot. You seem to have a lot of questions. Yeah. Seem to have a lot of questions that I don't know whether
I just don't know what you mean by triangulation. That's a new concept to me. Like,
hey, listen, you've had this discussion with us like 5 times, dude. We know where this is going.
The triangulation of the speed of the sun?
NPC resetting. Like you're bricked, like a Nintendo.
I'm bricked. That's a little bit.
He's respawned.
No, go on, carry on. So, no one knows the height of the sun. How does that make the globe? Just try and get to the answer quickly.
Well, my theory is the further away the sun is, the less oblate the Earth must be, because the gravitational effects of the sun would be less. And so I think the degree to which the sun is oblate is going to be a function of the solar distance. So I think it's highly relevant.
What's gravity and its effect?
So gravity's not real. What I actually meant to say was skibbity. Does that help you?
Yeah, you have a lot of skibbity.
We do. And so the skibbity factor tends to accelerate mass, which is very interesting. And it seems to fall off with distance. It seems to employ a potency called Riz, but it's not fully understood.
Yeah, gravity equals mass times acceleration. Is that what you're claiming?
Whoa! I never said the word gravity. I said the word skibbity.
Oh, yeah. Oh my god! It's like arguing with a child.
It is like arguing with a child. That's what people said to Socrates and to Plato. The Socratic method was very effective. It cut through them, and they said they were talking to a child, but really they were talking to the wisest of them all.
Okay, Dunning-Kruger.
The Dunning-Kruger effect isn't even real.
What's the point?
Well, you're proving it right now, so.
I'm proving it's not real by being both.
No, you're proving it's real right now because you don't think you're affected by it. You think you're the smartest person in the room right now. You're coming at us with a freaking NPC resetting brick Nintendo.
Well, there are two studies I'm going to put inside chat, direct your attention to. So the first study is called, I don't know if it'll embed, I guess it won't, but the first study is called The Dunning-Kruger Effect. It's a statistical artifact. And the second one speaks about Dunning-Kruger not actually being, statistically significant.
Do you have anything productive to say about the nature of Earth, or is this just about, your own psychological discomfort with the topic?
Well, you hold on. Pardon me for getting clarity on the term that you introduced.
No, I just described what you were doing as having a Dunning-Kruger effect.
You were appealing to a psychological phenomenon, but I was telling you that psychological phenomenon is just a statistical artifact. It's not real.
Oh yeah, just like your globe calculations. Just like your globe is all based off of statistical mechanics too.
Statistical mechanics? We're not talking about statistical mechanics. We're talking about statistics.
Well, you're in a 24-hour flat Earth room, so yeah, we're going to talk about the statistical mechanics of the globe and how you only have mathematical artifacts called datums to show for it. You don't have any actual measurements.
The plural of datum is data, not datums.
Well, in this case, we're referring to one datum being the globe.
You said datums. That's not the correct plural. The plural is data.
Yeah, well, you know what? They call the datum a model, and I'm referring to multiple models here. Data is not a model. Data is not a model. A datum is a mathematical model that as a specific lexical reference here to a globe.
Do women go on datums with you when you speak about the flat Earth?
You can look up multiple datums on a website. I can show you 200 datums of Earth.
You're so autistic, dude.
You interested? You can go to esri.com, esri.com, and you can start exploring all the different datums.
Can you talk about this information on datums or no? Yeah, so my life aspiration is to have a beautiful farm. I think the Earth is a datum, and I think it's very like the sun very fast and gravity not real. What? That would be such a good like SNL skit. They should make it.
Yeah, you should probably fuck off as well.
Probably. I don't know.
Yeah.
And Merry Christmas to you too. Happy New Year.
Yeah, I think probably more than likely. Yeah, just fuck off.
Merry Christmas to you too.
Yeah, no, I don't think so.
Here you go. You can go to esri.com. They're in the business of providing datums. They got datums galore. It's basically a globe shop. Posted at 18 minutes past the hour.
was pretty weird. Hello? Oh, watching the video. What?
Morning. Hello.
Why is everybody muted? What's going on?
We're meditating.
Oh, I didn't know people that lived on flat Earths needed to meditate. It's new to me. Like you guys just kind of, I don't know.
With that?
Meditation?
Yeah.
I don't believe it works. I think it's just
You probably haven't done it right.
No? How do you do it?
It's a skill, honestly. It takes a while to understand how to do it correctly.
Okay, so it's more than just sitting crisscross applesauce and closing your eyes, right?
Technically, no.
Okay.
It is just that, but you also need to be. I don't know, it's kind of hard to make your brain go stop, you know? Like.
Yeah, I don't think that's possible.
Yeah, it takes a while to, like, you know, do it. Like, for me, it would take me, like, you know, 15-20 minutes to get to a point where my brain is actually, you know, not thinking of anything. But, like, then I would get too, like, you know, excited about, like, what's happening, and then I would lose focus. It's kind of funny.
Okay. Are you an Indian, Bangladeshi, or Pakistani?
Indian.
Okay.
Yep.
Maybe that has something to do with why you believe that meditation actually exists.
What do you mean? I mean,